Okay, and I'll start. Okay, so this session is called Real-Time Data Processing in Fabric, Tracking a Cycle Rate. And my name is Grímur Sæmundsson. I work for Software One here in Reykjavík. We used to be called Crayon, but then we got taken over by Software One. So now I worked for Software One for 2 days. And Software One is a global company. I'm not sure if you heard of it or not, but they have a presence in India as well. And my idea with this session was to have like a light-headed way to show the capabilities of real-time data processing in Fabric. And we are gonna run a short demo where we follow a cyclist around the Reykjavík area, and we're gonna track how far he is away from home, what the nearest booze shop is, because we have a bit of a strange system here in Iceland. It's only the government that's allowed to sell alcohol, and we have special shops to sell the alcohol. And I thought it might be fun to track how far away you are from one of these booze shops when on your cycle rides. And to do this demo, we are gonna use the capabilities of real-time processing in Fabric. We have 3 different data sources. One of them is basically just an export that I made from the sport watch that I have, the Polar sport watch that I wore when I went on the cycle ride. And then there's another file that has the coordinates of all the booze shops in the Reykjavík area. And then we have also to be able to track where we are on the map. We have something called geogenes that have like the boundaries of the postal codes in Reykjavík. Then we can track where we are on the map, or in which postcode we are. So if we just go briefly over real-time intelligence in Fabric. Real-time intelligence in Fabric is basically an end-to-end solution where we have, we can use it to process event-driven data or work in event-driven scenarios. And we're basically working with streaming data that is sort of coming into the system continuously. And it's very often used to process data logs of some type or another. And because we are working in Fabric, we have like this suite of systems that we can use. So we can go all the way from ingesting the data into Fabric into providing immediate visual insights. And this is basically what we're going to do in this demo. And just to make things a little bit more interesting, we're going to use the native programming language that we use to process streaming data. We're going to use KQL to do some geospatial analysis on the data. And we're going to look very briefly into triggering. So if some condition is met in the data, we are going to send we can send a text message or a Teams message or a email or many other things. Deeper into that later. But as you probably know, Fabric is a is a sort of do-it-all type of a system. So when we are working with real-time data in Fabric, the real-time data gets to be a part of like an organization-wide data catalog. So underneath Fabric, we have this thing called one lake, which is basically where every data is stored that we use in Fabric, and the real-time data is there as well. And there is, of course, there has been a big change in how we provide our analytical systems with data, and how much data we gather and create as well. And I tried to Google just before I started this session, and I tried to Google how much data does an electric vehicle create, and I got like the first two things that came up. One of them said about 4 gigabytes a day, and the other one said 120 gigabytes a day. So a lot of data anyway, an electric vehicle creates. And all this data has to be processed somewhere, and the batch-based systems, they are sort of no longer able to process the data in a good manner, because it's just flows so fast and it's so much. And that's where the real-time intelligence comes into play. And there is sort of in this area of work, the classical architecture is called lambda architecture. And that's where we have like some device creating data, and we ingest it to the cloud usually, and then we sort of split it into the fast lane and the slow lane. And the fast lane is for like real-time processing with real-time dashboards, and we have systems that react to anomalies in the data instantly. So we have instant reactions. And then we also have the slow lane, and we can call the slow lane, that's sort of where we store the data to do some processing after the fact. So you can see, okay, something happened and we had to stop the system, and then we want to find out why did this happen. And then we have all the historical data in a data lake or some other persistent system, where we can run slow and maybe time-consuming analysis on the data. And that's sort of basically the idea of the lambda architecture, and where we have one system that reacts instantly, and one part of the system allows you to do some work after the fact. I thought I had, oh yeah, here is the video, sorry. I thought I put it earlier in there. So, this is basically what we're going to be doing. We have a map of Reykjavik, and on this map we have all the different booth shops, and one of the dots is the cycle or the cyclist. And we are going to follow some facts about the cyclist. We're going to see in which postcode the cyclist is, where the nearest booth shop is, and how far away we are from it. We're going to follow the heart rate of the cyclist, and then we're going to just follow how far away we are from each booth shop. And I don't think I said it earlier, but the big idea maybe behind this little demo is that I want to convince you how easy it is to get started with real-time intelligence in Fabric. So this is basically a fun little project that I just threw up in one evening. And after this demo, I hope you're going to be able to do the same. So basically, if I just push play on this video here, this is what we're going to create. And you can see the heart rate is changing. Somewhere around here is the cyclist. And here the nearest push-up is Greenland, which is around here. It's in postal code 105. And here are all the different push-ups they have. And after this demo, I hope you're going to be forward. Okay, this is now the nearest push-up. We are now in postcode 104. On this video here. Etc. And there is one weakness in the data that I'm working with. When I was working with geodesic data that works on the postal codes, I felt that they were a bit too specific. They were sort of too, they were a little bit too good on drawing the boundaries. So I ran it through a little program that sort of went through, okay, this is, you can make this a bit smaller and maybe not quite as good. And then there's a little path here where we are not going to be in any posted code. So I've run into problems sometimes when I'm doing this demo that it doesn't find the posted code. But then, sort of, when we finish that stretch, we are in the posted code again. So, know what's happening if this is going to happen. Okay, and as I said, we got 3 kinds of data. We got the streaming data, which is the export of the XML file that the Sportwatch creates. It's of a format called TCX, which is something from Garmin. And then we got another file that contains the coordinates of the push-ups. And of course it can be anything really. It's just, I thought it was fun to have push-ups. Then you got the GeoJSON polygons that are the postal codes. And one at the top is what we would call streaming data. I'm going to have a little Python program run that takes this data and pulls it into, or pushes it into Fabric. Okay, and then we have one table that contains the shop coordinates, and this is what they call reference data in the business. So we got 2 types of reference data and 1 type of streaming data. And all of this goes into a KQL database, and there we can run queries and in the end visualize them. And again, this is sort of the architecture of the solution. You have the TCX file and the Python program that pushes it into it's actually a tool in Fabric called Event Stream that pretends to be an event hub. So it sort of exposes itself as an event hub, and we can use that endpoint. Okay. The endpoint sends it into an event stream, and the event stream pushes it into an event house where you have a KQL database. And in the KQL database, we're going to show it the data in a real-time dashboard, which is basically what I showed you in the video. And maybe if you have time, you can do some after-the-fact processing in a notebook. And the event stream also pushes it into an activator. And in Fabric, an activator is a tool that sort of reacts on the data as it is flown in. So maybe we're going to try if maybe the heart rate gets too low or if we're too far from the boost shop or something like that. And then we can send a Teams message, we can send an email, etc., etc. Or start the process, and there's a lot of things that you can do. Okay, and maybe the heart of the system is the event house, and that is good for, as I say, any scenario that includes event-based data. And we are streaming data that is sort of where I am at each moment, and then we use that to calculate sort of how far away I am from boost shops, etc. And in the event house sort of indexes and partitions the data to make it to make the queries faster. So we have indexes and partitions that are based on ingestion time into the event house, and that's something that sort of happens behind the scenes. There's nothing that we need to worry about, just what it does. And the event house can have more than one KQL database. That's a good thing to know. And when we add it to one lake, there's just a little switch that I have to remember to turn on. I very often forget. And then we can query it by Power BI. We can take the data and put it into a warehouse or a lakehouse, etc. Or do these after-the-fact analysis. This is this thing called one lake availability. You can look at it as the slow path in the Lambda architecture. So we are going to create an event house in Fabric. So I've already created a workspace. I hope it's here. Yep. So we are just basically in a workspace in Fabric, and it's a new item. And I've actually just made event houses and event streams my favorites, so they just come up here. But of course, you could go to all items and search them there. But anyway, I'm going to start by creating an event house, and I just call it EH1. We are going to create an event house in Fabric. Very quick. Get started. And so here we have the event house, and here we have the KQL database. And we are going to start by creating all these different tables. So we have code to create the tables here. So this is a KQL code. I'll say, okay, I'm here in the KQL database. Let's query with code. And it starts by coming with some suggestion of how I can query the data. So this is all sort of KQL queries. But we don't have any data in the database yet, so we're just going to have to remove them. And we're going to start by creating the one that contains the shops. And then it's the postcodes. And finally, it's the one that receives the data about the cycling. So now we have 3 different tables. And it starts by coming with some suggestion of how I can query the data. And the next thing we need to do is to put some data into the 2 reference tables. So we have a JSON file that contains the placings of the shops, and then we have a CSV file that contains the GeoJSON code. Very hard to say this word. GeoJSON code that contains the boundaries of the postcodes. And just click on the three dots here and get data, local file, and then you have to select the table here, browser files. So we're going to use the JSON file here. And then we have a CSV file that contains the and that's basically just next, finish, and then I have to wait for this one to finish before I push close. I found that if I push close too early, there's like a 50-50 chance of it finishing what it started. Sometimes it finishes and sometimes it's just things that I'm cancelling. Okay, so now we've put some data into the shop table. Then there's the postcodes. Get data, file, postcode, browser files. This one to finish before I push close. So this is basically what the JSON looks like. It's basically just sort of the boundaries of the postcode. Sometimes it finishes and sometimes it's just things that I'm cancelling. And I've simplified it quite a lot. So now we've put some data into the okay, so let's finish. Then there's the postcodes. Data. Wait. File. Postcode. Files. This data is a little bit more complex than the one that we ran earlier. But now it's finished, so now we can push close. And we have the postcodes in here. Okay, so now we have prepared the event house to receive the data and do the data processing that we want. And then let's have a look at the event stream. Like this. The event stream. That's basically a tool to ingest data into Fabric. And it has a couple of protocols, and they are sort of increasing the protocols it can handle. I think actually we have more than those here. But these are like the classic protocols to receive data from devices. Kafka, Event Hubs, and MQP. And then they have sort of extended this as well. So one of the things we can do is connect it to a couple of types of databases, like SQL Server in Azure, and I think we can use Oracle and some other databases, Postgres, where we run what they call, or follow what we could call change data capture. So we get a message every time some data in the database changes. So I think this is actually a very good idea to have like an almost real-time update on what happens in the business systems. And then there's another thing called Fabric Events, and there we are using or following what is happening in our Fabric state. So if somebody deletes a report, or if somebody creates a lakehouse, or if somebody names something or something, if something happens, the event stream catches it and does what it deems necessary about that. Okay, and that's sort of the ingestion. And then we can have little component called transform. So we can add calculated fields, we can group and aggregate the data, you can join it and union it with other streams or tables, and you can expand arrays, etc., etc. So it is something very important when you're working with JSON and XML. So you have a little calculation machine in the event streams. Okay, and then you can land the data somewhere, and you can land the data in event houses. You can land it in lake houses and in custom endpoints. So you could send it to some other system that is able to catch streaming data that has like a specialized endpoint to do that. And also this thing called Activator. Where you can react on the data. If we create the event stream, so you have a little calculation machine in the event streams. Okay, and then you can land the data somewhere, and you can land the data in event houses. You can land it in lake houses and in custom endpoints. We're gonna create the event stream in the same workspace. Some other system that is able to new item, streaming data, and stream, and just call it yes. And also this thing called Activator. You can react on the data. If we create the event stream, deleting a lot of Power BI stuff before the demo. I hope this is just something to do with that. All these error messages. Okay, so we are actually going to create a custom endpoint. I'm going to start by doing that. And I'm just going to keep the name as this. And to be able to retrieve the information about the custom endpoint, I'm going to have to publish it first. So that's quite important. It took me some time to figure that out. So we published it, and now we have a custom endpoint that is ready to receive data. We are actually going to create a custom endpoint. I'm going to start by doing that. And I'm just going to... Okay, so it's SAS key authentication that we're going to use. And what we need to have to be able to send data into this event stream from outside the cloud, we need the name of the event hub, so we published it, and now we have a custom endpoint that is ready to receive data. Okay, so it's SAS key authentication that we're going to use, and what we need to have to be able to send data into this event stream from outside the cloud, we need the name of the event hub,
Hey, hi, Grímur. Aditya this side. Sorry for the interruption. Uh, you're on mute actually. Could you please unmute?
Have I been on mute the whole time?
Yeah, just like few minutes back. So you were covering something.
Okay.
Yeah, thanks.
Okay.
Not the whole time. It's about 2 minutes.
Okay.
Yeah.
Oh, I'm so happy. So glad.
Yep, no worries.
Okay. So, do you want me to sort of do something again, or is this just okay to just continue? Could you just follow on the screen and? Yeah. Okay. I'll just continue. Okay. So now we have the. Yeah, we're going to connect this to the event house. That's basically what we're going to be doing. And so it's event house, and suggest the same workspace as we're in, and we select the event house that we just created, find the KQL database. Just follow on the screen. Oh yeah, and also that's maybe best of it. I'm just working on one screen, so I don't really see the messages, and that's good for you to know. Okay, so we got the KQL database, and then we have to choose the table, and that's going to be this one here called cycle right, and I just save. And because it hasn't gotten any data, then it doesn't really know what the data is going to look like when it enters the system. So it says here, okay, I can't really show you anything, and I can't really tell you that if it fits into the table. So it's skipping the validation. Okay, so now I think it's time to start sending some data. Okay, so we got the KQL database, and then we have to choose the table, and that's. Oh, it's sending the data. And it is save. And because it hasn't gotten any data, maybe know what the data is going to look like when it talk about enters the system. So it's real-time dashboard where it's sending the data. Show you anything, and I can't really tell you that if it fits into the table. So the real-time dashboard, the main source for it is a KQL database in Event House. That's sort of the native source. But you can also connect it to Azure Data Explorer and Azure Monitor. And maybe if you remember how it looked when I was showing to you, then we had little tiles. One of them showed the map, one of them showed the post number we were in, and one of them showed sort of the distance to booth shops, etc. And we can have it so it refreshes automatically, and we have sort of everything from continuous, so it's just as soon as it receives the data, it's going to show it, to 1 day refreshing tools. And maybe if you remember the data, so should be some data here. Little tiles. One of them showed the map. One of them showed the post number we were in. So I'm going to go to the event house. The distance to booth shops, etc. If you go to the cycle right, we can have it so it refreshes automatically, and we have sort of everything from continuous a little bit. As soon as it receives the data, it's going to show it, to 1 day refreshing tools. And the data. So should be some data here. So I'm going to go to the event house, and Yeah, to publish. Okay, now we have data. Send it into the event house. And go into the event house and the cycle right. Go to query with code. And basically we have a couple of KQL queries. One that creates the map that we just saw and sort of shows us where we are on the map. We have, and also this query, it connects to the table where all the bootstraps are and shows us like the nearest bootstrap, etc. So copy this one and try and run it. Okay. So this is the data that we have. These are all the different bootstraps. And here we are going to get the data about the position of the bicycle when it starts flowing into the database. And also this query, it connects to the table where all the bootstraps are and shows us like the nearest bootstrap, etc. So copy this one. Okay, it's probably just some lag that we're experiencing. Okay. So I think I'll just take all these different queries and paste them in here. Oh yeah, here we have some data for the bicycle. Okay, so here we have the results of the query, and we can add visual, it says here. So you can add visual, and it shows it as a table. We want to see it as a map. So somewhere around here we have maps here, and it actually makes a small mistake here. It doesn't really know how to create this map, or I guess it's wrong in the beginning maybe. So instead of infer, we're gonna use latitude and longitude, and it mixes up latitude and longitude, so we have to choose it says latitude here, and it says puts longitude in there. So use latitude, and then it sort of figures out what it's doing. And we want the names of the bootstraps, so we just choose here audio string. So I can go here and then you can see what each job is. Okay, so now we created one visual, and we can click Save to Dashboard, to a new dashboard. The one, our workspace. We can open the dashboard. Then we see we have the map, and we want to have it refreshing continuously. So we're gonna go to Manage and auto refresh. We turn auto refresh on, and then we have two parameters. One of them is how frequently are we going to allow ordinary users to refresh the data, and also how often do we want to refresh it. The thing is, each refresh costs capacity units in Fabric, so we want to make sure that they're not sort of spending it on things that they don't really need. So we're gonna choose continuous and continuous and apply, and then you can see the bicycle is here and it's moving. Okay, save it. Then is the next query with another geological function that we're going to use. Here we have a function called geopoint in polygon. So the polygon is the postal code. That's the GeoJSON for the postal code. That's the polygon that we're joining against. And the point is the position of the bicycle, really. Run this. You see, okay, he is now in this postal code here, 170 centimeters. And we click Add Visual. And we don't want to show it as a table, we want to show it as a stat. And save the dashboard. Use our dashboard that we just created. There's going to be 2 more queries. Nearest push-up. You see, okay. He is now in this postal code here, 170 centimeters. And we run the query. So this is the nearest push-up. It's 2.4 kilometers away. And we're going to click on Add Visual. We want this to be a stat as well. And just created. There's going to be 2 more queries. And in this case, we want to know if we are too far away from a push-up. Too far away from the nearest push-up. So we have this thing here called conditional formatting. So here I can click string here, sorry, so not just the distance. But in conditional formatting, we click Add Rule. And now we created the rule, and then we edit the rule. And we say, okay, if we were further away than half a kilometer from the nearest push-up, we're gonna make it red. And we're gonna have like a alert icon. And up here it says color style. It can be either bold or light. Light, then it's just the letters that are red. But bold, then it's the background that gets red. So I think light is enough for us. So I just save it. And here we are further than half a kilometer from push-up, then it looks like this. Okay, save the dashboard. Make it red. And we're going to have like a alert icon. Yeah, I said it was 2 more earlier, it's 2 more now. It's just up here it says no. Color style. It can be bold or light. So this is all the push-ups, and this is the distance to the different push-ups. And maybe if we go here to Add Visual, and we could show it as a table. We could also show it as multi-stat. And you get it like this. Okay, and then it's saved to dashboard. And yeah, I said it was 2 more earlier, it's 2 more now. Okay. No, and it's the last one. I'm just gonna follow my heart rate when I'm cycling. So this is all the push-ups, and this is the distance to the query. And this we want to see as a line chart. Get the query results. We could also show it as multi-stat. and not visual. And we want to have this a line chart. Save to dashboard. And not save to dashboard. That is the last one. I'm just gonna follow my heart rate on a second. Okay, let's open the dashboard. So this is basically what we created. Yeah, as I said earlier, along this stretch here, we're sort of outside of the poster code. That's basically because I just made it too small. Okay, so maybe you don't necessarily want people to stare at the dashboard the whole time. So we can set alerts. We can set an alert on a specific visualizations. I just click in the lightning here, and then it gets this window here. So it says, okay, on each event, when here stationary distance is equal to etc. So this was maybe not a good choice. Necessarily want people to stare at the dashboard the whole time. Each event, when heart rate, set an alert on a specific visualizations. I just click in the rate is equal to, and then it gets this window here, 139. So it says, okay, on each event, when, and then it's gonna send me a Teams message. And it says, okay, every time the condition is met, maybe I don't want to do it specifically in this particular case, but maybe if it happens less frequently, then maybe I want to. So I can select which people I want to send a team message to, and I can change the headline, I can create the notes, and I can put it in context. Then it says here, okay, when it has been true for X amount of times, and when it's been true for some time as well. And the condition, here we can also have sort of remembers the last point and tells us when it has changed from the last point. In this particular case, we say, okay, when it is 149, but we can also say if it's gone up 3 points or something like that. Then it says here, okay, when it has been true for X amount of times, it is done, and when it's been true for some time as well. And here's a fail to condition. Here we can also have good sort of remembers. Maybe I talk too long. And tells us when it has changed from the last point. In this particular case, we say, okay, when it is 149, but we can also say if it's gone up 3 points or something like that. Is this maybe I talk too long. A numeric change, numeric state is equal to 149. Send me a Teams message. See here. Is this? Okay, no, didn't have a rule name. Okay, so now we have an activator that sends me a Teams message every time that my heart rate or the cyclist's heart rate goes to 149. Me a Teams message. I was actually running this earlier. Have a couple of messages. Okay, no, didn't have a rule name. We have this thing here called Fabric Activator. Okay, so now and these are the messages that I've been receiving. It sends me a Teams message. And can also start a process. So action here is Teams message. We could run a data flow, run a pipeline, etc. Or we could even put up like a Power Automate workflow. So these are the options that we have like out of the box. I think this is a really powerful tool. And also, as I said, you don't really want to be staring at the screen all day. Maybe it's better if it just lets you know if something has happened. So, yeah, now I'm just going to open for questions, I think I've actually spoken a little longer than I was meant to. Or we could even put up like a Power Automate workflow. So these are the options that we have like out of the box. I think this is a really powerful. I don't know, questions? And also, as I said, you don't really want to be staring at the screen all day. Maybe it's better if it just lets you know if something has happened.
Hello guys, if you have any questions, you can ask in the chat box.
Yeah, so Iceland is not a very big country, and I am actually the only one in the world with my name. So if you want to discuss with me, you can just find me on LinkedIn and have a chat there if you want. Okay, then I think I'll just say thank you.
Thank you. Thank you so much, Grímur, for your wonderful session on real-time intelligence with real-time use cases. On behalf of HDAC, I would like to thank you and appreciate for joining all the way from Iceland and sharing the valuable insights. Your real-time industry use case and practical examples on your activities at Fabric and real-time intelligence gave much understanding of real-time intelligence. And it was truly an insightful session. And thank you once again for joining us. Thank you so much.
It was my honor. I was actually very chuffed with sort of speaking in Hyderabad. It was very exciting for me, even if it was online.
Yeah. And really thank you for joining us despite of different time zones as well.
Okay, thank you very much.
Thank you everyone.
Bye.
Thank you. Bye.
And real-time intelligence gave much understanding of real-time intelligence, and it was truly an insightful session. And thank you once again for joining us.
It was my honor. I was actually very chuffed with sort of speaking in Hyderabad. It was very exciting for me, even if
धुरंधर का हर स्टेप है बिल्कुल accurate and precise, just like the precision of Invisalign clear aligners, जो अपने revolutionary smart track technology से देते हैं आपको highly predictable results. Redefine your smile only with Invisalign, the world's leading clear aligners, और देखिए धुरंधर the Revenge, only in theaters from the 19th of March.
And thank you once again for joining us.
It's my honor. I was very chuffed to speak in Peterborough. Very exciting for me. Even though
Yeah, Vijay will join in another 15 minutes and then we can start. Meanwhile, I think you can be ready with your questions. I think Vijay has a long experience on working on Power BI and he teaches it. So if you have any doubt around Power BI, not only what he's showcasing today, please go ahead and ask that. He is a really good mentor. So take the full advantage of that. Yeah, Vijay will join in another 15 minutes and then we can start. Meanwhile, I think you can be ready with your questions. I think Vijay has a long experience on working on Power BI and he teaches it. So if you have any doubt around Power BI, not only what he's showcasing today, please go ahead and ask that. He is a really good mentor. So take the full advantage of that. Yeah, Vijay will join in another 15 minutes and then we can start. Meanwhile, I think you can be ready with your questions. I think Vijay has a long experience on working on Power BI and he teaches it. So if you have any doubt around Power BI, not only what he's showcasing today, please go ahead and ask that. He is a really good mentor. So take the full advantage of that.
Hey Vijay, can you hear us?
Yeah, I can hear you. Yes.
Can you please
I
test
made you the
your
presenter. You
screen?
can test check that screen.
Yeah.
And Aditya, are you ready to introduce the speaker?
Yes, yes, I'm ready. I'm ready. Hey Vijay, can you please test your screen sharing and audio?
Yeah. Can you hear me? Am I audible?
Yes, you're audible.
I'm sharing the screen. Can you see the screen?
Yes, we can see the screen.
Great. Okay, great.
Yep.
You can test check that.
Okay, we'll start in 2 minutes.
Not a problem.
Yes, yes, I'm ready. I'm ready. Hey Vijay, can you please test your screen sharing and audio?
Yeah. Can you hear me? Am I audible?
Yes, you're
I'm,
audible.
I'm sharing the screen. Can you see the screen?
Hey Vijay, can you please test your screen sharing and audio?
Yeah. Can you hear me? Am I audible?
Yes, you're
I'm,
audible.
I'm sharing the screen. Can you see the screen?
Hello, everyone. A very good evening once again. After an insightful session on real-time intelligence, now it's pleasure to introduce our next speaker, Vijay Perepa. Vijay is a Microsoft certified trainer and a corporate trainer, and also a well-known community contributor in the space of data and AI. With his expertise in
After an
Microsoft
insightful
Power
session
Platform,
on real-time
Azure,
intelligence,
data
now it's
engineering,
pleasure to
and
introduce
Microsoft
our next
Fabric.
speaker, Vijay
And
Perepa.
also,
Vijay is
Vijay
a Microsoft
is
certified
actively
trainer and a
contributing to the
corporate trainer, and
HDAC from
also a
long time.
well-known community
His
contributor in the
in-person
space of
sessions at
data
Bangalore
and AI.
location
With his
and virtual
expertise in
conferences
Microsoft
brings
Power
a lot
Platform,
of
Azure, data
insights to the
engineering, and
community.
Microsoft Fabric. And
And
also,
today we have
Vijay is
Vijay once
actively
again.
contributing to
He
the
will be sharing his
HDAC from
valuable
long time.
insights on
With his
Microsoft Power
in-person
Platform.
sessions at Bangalore location
Please join
and
me.
virtual
A warm
conferences
welcome to the
brings
Vijay
a lot
Perapa.
of insights to the community.
Thanks, Vijay, for joining with us,
And
and the
today we
stage is
have
yours.
Vijay once
Yeah.
again.
Thank you.
He will be sharing his valuable
Hi.
insights
Hello,
on
everyone.
Microsoft Power
So,
Platform.
good evening from
Please join me.
Bangalore.
A warm welcome to the
So,
Vijay Perapa.
today's whatever topic I'm talking is very general and very
Thanks Vijay
basic
for
about
sharing with us.
Power BI,
The
but
stage
at
is yours.
it is very important topic which every beginner of Power BI need to understand. Rather, even if you are using Power BI for a long time, these topics you might have not addressed very well. So these topics are required. So let me give you a thought process of basics, how to use these basic elements to understand Power BI in a better way, right? So let me share my screen and then begin with the introduction, what exactly we are going to do today. So whenever you have data, normally in most of the organizations, your data will be Excel. And in many corporate trainings, when I visit the offices, the teams are actually looking at to understand how to deal with only the Excel itself. Of course, you will have some users definitely will have an access to SQL Server or other kinds of data sources, but maximum participants are actually looking at how to use mainly Excel. So how to deal with Excel in Power BI. And that too, that Excel is not coming in a very easy shape, or maybe not in an understandable shape. Maybe it is having a lot of issues with respect to the data quality. So how to deal with those kind of problems and convert it into kind of enterprise ready data. Even though it is a small data, but they wanted to make it more robust schema so that they can use that schema and they can understand the schema very well and they can create a nice Power BI report. So today's session is completely a very basic and give you, but it's completely I mean evergreen concept. Any Power BI user should know it. So my request is understand the topics, ask the questions, and any questions can be answered so that you will be able to understand the topic. So let me begin with the data. So most importantly, whenever you are dealing with data analysis, you need to know what kind of data you are dealing with. And more another important thing is when you are actually dealing with the data, what data you are dealing with and what you are looking at with the data, what you want to do. For example, whenever I am actually dealing with the data, I will be doing some kind of analysis. That is, either descriptive analysis or diagnostic analysis. That is the first one. So descriptive analysis means describing the historical data and telling what happened, why happened, how happened. So that is what is descriptive analysis. And also we call it as diagnostic analysis. So this is also a part of descriptive analysis where you are diagnosing it and finding out the remedies for the future so that it will be taken care and your business will have rightful things and you will be getting, maybe your profit is low. What are the things you need to do? What happened so that your profit is down? What you do, then you will be able to get a better profit. To understand that, you will be basically do diagnostic analysis. So Power BI most of the time supports descriptive analysis primarily. Who are the basic business analyst or a data analyst, they start with descriptive or diagnostic analysis. There are two more analysis are there, that is predictive analysis and prescriptive analysis. So that is mostly using the machine learning and using the coding approach, which can be done in Power BI as well. But primarily Power BI meant for these kinds of analysis. Now, while doing the descriptive analysis, what you need to understand. So when I look at the data, I will be looking at the data in different views, different viewpoints. One, I'm actually preparing the data. So whenever I am preparing the data, how I have to look at the data. So what exactly I need to look at the data, then I can make it better. The second one is analysis. So when I'm analyzing the data, what I supposed to do. And third one is visualizing the data. So when I'm visualizing the data, how to look at the data. Why? Because when you're preparing it, if you do not see the way you're supposed to see at the data, your preparation will be incomplete. So majority thing you need to do is always you need to look at is looking at the quality of the data. So before looking at the quality of data, you need to look at the data types. So primarily the data types are text or number or date. And if you are already familiar with little bit Power BI, definitely you know that Power BI always allows you to have only one data type per one column. But when you are accessing the data using Excel, in Excel if you write 1, 2, 3 and A, B, C, it still gives you the answer. You write a sum formula, it will ignore wherever the text values are there, but it will only give you the answer from the cells wherever number is there, and it will allow you to get the answer. But in Power BI that is not possible. That is the reason you should be very careful. You need to understand the data types in a clear manner. So what is text and what is number and what is date, whether you have any such columns you have. And one more important thing you need to understand, which column is actually used for calculations when you are using in Power BI. For example, employee ID. Employee ID might be sometimes have a combination of different types. Maybe alphanumeric and numeric will be there. At points, maybe your Power BI showing you that data type in a wrong manner, you can convert into a text and leave it, because we never use an employee ID or a product ID or any other ID. We will not be using it for calculation. So if you have such IDs are there in a combination of alphanumeric and numeric, convert them into text. So your focus need to be only those columns which are primarily to be calculated. So their number and date columns are coming to the picture. And most importantly, you need to see that one column, one data type. So that is what, when you are preparing the data, that is a starting point. So now once I have cleaned that entire thing, so suppose you have a date column is there, but date format is not good. Some errors may be there. You can actually clean those errors and make them readable, and you can see that what date problem is it and what need to be done. You can understand it. So that is how you have to prepare it. That is the first step. The second step is the analysis point of view. Whenever you are looking at the data with the analysis point of view, you need to understand how many categories you have and how many columns which are showing the numbers. Because categories are subsets of your data. So they will actually create a subset of the data, and the number will be telling the story. So you need to understand how many categories are there. And based on, if you look at the data in the beginning itself, whenever you are starting a report or starting an analysis, if you are looking at the data with a kind of differentiation, how many columns I have categories, how many columns I have numbers. Numbers means which you are using for only calculations, where you want to see the descriptive analysis like sum, max, min, average, these kind of calculations wherever you are doing. Basically, those are numbers. Other than that, those are not numbers. If they are numbers, also fine. But again, for example, employee ID is there. It is completely a number column. I don't have an issue. But it is having a number with the alphanumeric also. Then it is a problem for me. So I will convert that into a text rather. Otherwise, if any number is really required to do some analysis to understand the story about the business, then I keep them as a number. But you need to look at the categories. When you look at the categories, you will have a complete understanding that what kind of analysis you're supposed to do, what your business is actually dealing with, and then you can take it forward. So that is why you need to look at the categories and numbers when you are analyzing the data. The next one is how to visualize the data. When you are visualizing it, you need to look at the data, how many data points I have, how many data series I have. This is very important when you are visualizing. Most of the time, one question I hear from many participants, when to use what chart. See, that is the question. Rather, you need to understand yourself instead of asking somebody, right? This viewpoint will give you understanding. Data point means basically category, and data series means number. So now, for example, I have to, if I have a revenue and cost by city, if I say that, so how many series I have? I have two series. One, this is series 1. For example, I have to, if I have a series 1 and then series 2, and this is data point. Now, when I want to create this kind of analysis, can I use for example, a donut? So now, when you look at a donut chart, what exactly donut chart is doing, or a donut or a pie chart, they will be taking care one series, and one data point. That means either you can show revenue by city or cost by city, but not revenue and cost by city in a simple manner. Of course, you can create a chart which can show all these things, make it little complex. But the objective of showing a chart is not to make it complex, but make it more simple to the end user, so that when they look at it without asking many questions, then to understand it and take a informed decision. So that is the objective of visualization. So at that point of time, you need to understand how many data points are there, how many data series are there. So normally when you have this kind of multiple series and multiple data points, you will be using, most of the time, you will be using column and bar chart. So that is where this viewpoint will give you an idea. And there your creativity will increase. Okay, now I have these many categories and I have to showcase these many numbers. Now which chart will give me a better idea? Then the question of when to use what chart will be completely vanished. Reason, you know when to use what chart, that will be clearly known to you. So that is what we need to understand. So while preparing the data, I will show all these points in the visualization as well. You'll understand. So in today's session, this is what I'm going to do. Why I'm going to this deep? Most of the time in many organizations, in many corporates, so these are very common problems where users are not actually focusing on. So when I have told this, even though a person is very experienced in Excel or maybe using the Power BI for some time, they found this is very important for them and they made a note of it and they started working on it. So that is what I'm revealing, and definitely it will be helpful for you as well. So now that is where you need to be very clear with. Now let us jump into the real data. Now when you are dealing with the data, first of all, when you are using Excel as a source of the data, my suggestion is converting that data into a table. Reason, when I access this data in Power BI will read the data as a sheet and data as a table. Now, when you access a sheet, you will have a lot of issues. Maybe the data is not loaded properly, even column header is not loaded properly. You need to again make your first row as a column header, and you need to do some further transformation. Sometimes that may be confusing. So to avoid that kind of scenario, whenever you have any Excel data, whichever data, for example, I have my data from A to I column or J column rather, is basically that is the data I need to see in Excel, in C Power BI. But rest of the area, for example, K, L, M, N kind of thing is there. These are the columns are actually my working columns, which I don't want to access in Power BI. So obviously that is going to be a more time consuming activity if I take my revenue data sheet as it is into Power BI. So that is the reason I have converted this into a table. Suppose if you want to convert any data into a table, suppose I have this data, I want to convert into a table, I am going to press Control L or Control T, both are fine, and that will be a table. And you'll have the table name in the right side. So where you can see the table name is very clearly there as table 3. You can change the name, but naming convention should be without any space or special characters. Then it will be added as a table. Then Power BI read that table separately. It will read a separate, that table is separately, sheet separately. When it is reading the sheet, it will read all the rows and all the columns where the data is. That is the scope of the sheet, so far as the data is concerned. But when you are looking at the table, it is only reading those columns and rows which are in the boundary of a table. So that is the reason I converted this area as a table already. Now you can see that if you look at the menu or a command ribbon, if I keep the cursor on the data, I can see table design, and name of the table is showing as revenue. So I'm not using revenue data sheet, I'm using revenue. And this is very one common thing I've seen in many whenever I went to any a training program, whenever I ask a basic question, I mean, yes, few people are already knowing about it, but many, I mean 60 to 70% of the Excel users do not consider table as important. And there is one small, also one doubt they have that if I create a table, it will consume more memory in Excel. So yes, that will definitely happen because the metadata within the table is more. So obviously it will consume more memory. But when you are working an Excel file for a Power BI as a source of data, definitely converting that data into a table in Excel, not a problem. It is very useful because you are not working with that Excel anytime. You can actually close that Excel, but Power BI is consuming the data through the semantic model scenario, so you don't have any challenges for that. So that is the reason, always convert your data, whatever data you're dealing with, into a table. Then another advantage is in a single sheet, you can have multiple tables. Even then, Power BI can recognize them separately. So where you want to do appending or merging, so certain things can be done very easily using such data. So now we are starting with the basic data. So now let's start with. Now we have several columns in the data. Now, but let us again understand how you get the data when you are using Excel as a data source. So whenever you are using Excel as a data source, your data will not be always a good data. Now, that will have some unnecessary columns. That will have some additional columns. Maybe that will not have some columns which are important for you. So then what you do, you start looking at the data preparation. Then maybe you are deleting some columns, maybe you are adding some columns, or maybe you are doing a VLOOKUP and bringing some data from other places, and then making it happen. So that is not going to help you, because if you start doing in one time, every time you have to do the same thing whenever you are receiving the new data, because it becomes a habit. Otherwise, your current data is not matching with the future data. So obviously, it's a difficulty for you. So that is the reason we need to first understand all the problem statements, and we are going to deal with those problem statements within Power BI very easily, right? So now let us understand. For example, in this data, the starting column is registration number. Registration number is not required by me for summarizing the data. Registration number is used in some scenarios, but not in my scenario. I want to just summarize the data. I want to see the aggregated results. That is the reason I don't want registration number column. So instead of deleting it from my current Excel file, I don't want to change anything, any structure of my Excel file. I want to keep the Excel file as it is, but I want to do the changes in Power BI so that that will be automated for incremental data as well. So my first problem statement is registration number, and then I will resolve it. The second problem statement is, no, that is not the problem statement, but actually the column, the date. In most of the training programs, I ask this question to everyone. Can you please tell me this date is a proper date or not a proper date? Somebody says, yes, sir, this is the right date. Somebody says, no, this is not a right date. This is you have written with all the values. But nobody will have a clarity. They're randomly telling whether it is a right date or a wrong date. But few people are really telling because they know why it is a right date or why it is a wrong date. But most of the time, people, I think 70 to 80% of the people in that training program might be saying that this column, we don't know whether it is the right column or wrong column. But they may say randomly, somebody say right, somebody say wrong, because they don't know the technique, how to look at the data. Why? Because you need to understand certain techniques when you are accessing the data. The reason I'll tell you, I will give you one scenario where I have been called to attend one small meeting, a quick meeting, because I resolve issues, and they've asked me to show, they're showing some data on their screen, somebody's laptop, and somebody showing the data, and I don't know that person very closely. So obviously when I go there, when I look at the data, since I cannot access his laptop, I can't use his laptop, or maybe I can touch and see the data properly. Just by looking at, I need to say your data is good or bad. So you need to have that kind of understanding by looking at, no, there is a problem with this particular data. This is not a good one. So how to resolve it? As a consultant, I have certain issues. When I'm doing a consultancy activity, somebody will ask me to see their data. When they think this data is good, they are very strongly believing this data is good. But when I look at the data, I will recognize and validate the data. There are some problems. I tell them this column have got problems. We need to resolve them. So that technique is nothing but, if you look at any number column or a date column, number or date will always align by default to the right side, and the text always aligned to the left side. So that is why if you look at, I have my date aligned to the right side, and now if I keep the cursor on it, I can see the formula bar also, and then I can say this is the right side. But not every time you will be allowed to access their laptop or their mouse and keep the cursor on the data. That is the reason you should have that understanding that, okay, if I look at this column is good or bad, I should be able to see. That is what is the data literacy, understanding the data easily. So that is done. So this column is a good column. This column doesn't have any problem. But this column has got a different metadata, because that metadata means that the data about the data, it is actually giving a format called long date. But actually the date is only 11th of January 2017 only. So, but anyway, Power BI will consider this, because Power BI will not take any metadata. It will take only the data as is, and it will give the metadata on its own. But Power BI will understand what metadata to give, what data type it has to give, and accordingly it will translate properly. So we don't have any issues with the date column, but there are certain issues where you have an issue with the date column. I will try to explain that also end of the session. But first let us understand this column is good. Now come to the student name, and interestingly look at the column student. That is showing student 130, student 131, and so on. Now sometimes Excel can mislead you. Reason, here it is looking like a text, but this is not a text. Why? One is it is aligned to the right side. But have anybody aligned it to the right side? Suppose somebody aligned it manually to the right side, you will definitely see that here in the what do you call that, left center and right alignment. That is not active. So that means it's a default alignment. So it's the column student name is aligned right by default. Means it should be a number. Text cannot be aligned. Yes. In Excel, there is an option to convert a text into a number into a text-like number, but that is not a text. So, for example, I have an option to do that. So these are the things you need to understand. Sometimes you are dealing with the data. So if I write some number 1, 2, 3, I can convert this number into like a text number, but it is not a text. So for that, I need to go to the options called formatting cell options. There in the custom, I have an option called custom. In the custom, I can make my text to appear like this, ABC, and just a 0. 0 is actually integer. ABC means the text which I want to add in the beginning. Now this will become ABC 1, 2, 3, but it is not a text. It is a number. So that is what is appearing here. In such case, when I translate this into Power BI will not take student 130 because Power BI will not take the metadata. It will take only 130. So if I want that student in the beginning, what should I do? I need to understand. So that is my second problem statement. The next one is department column. Now, sometimes what happens in the department column, you have certain hidden problems and you don't know where are they. For example, you see this here, there is a blank and you see here one finance, here one finance, here one finance. There three are different. But Excel will not give you that differentiation. For example, if I create here, like say department, and then I say proper finance once, then some spaces and then finance once, and then FIN small a capital finance once. Oh, I need to do that. And then I say proper finance once, then some spaces and then I can give finance and spaces, and I can give small FINANCE. Even this. See, this entire structure, actually all are different. But when I try to filter and see the data, to see the quality of the data, it shows only one finance. It is not showing all are different. But when you create a pivot table, you will get all these separately, then you'll have a problem. So how to resolve it? So that means in the department column, I have that quality of data, which is not a good data, so which I need to take care of. So that is what now I'm taking care in the department column. So now I have three problem statements. One is registration number. I don't want student name is not a data type. There is a data type issue. Department has got more problems. And then I have one more column where I have added some kind of errors. So that is what now I'm taking care in the department column. So now I have three problems. So that is my duration column. I have added some errors, and how to resolve errors, that also I will showcase. So now this is the data, and let us start with cleaning the data. Now, I hope you heard about medallion architecture. So what is medallion architecture? It has three layers of, basically three layers. The one is bronze layer, second is silver layer, third is what do you call that, golden layer. So bronze layer means the raw data as is, that is called bronze layer, which is not even not an enterprise standard, not even a normal small enterprise standard also. You cannot use it, you need to clean it. Then you will clean and process it and make sure that the data is readable and all the errors have gone. That is now clean data, but it's a flat data. That is called silver layer. In the silver layer, you will be cleaning the data and making sure the data is now ready to use. And the third one is, another step is golden layer, where you are converting or normalizing the data to a dimension and fact tables and making it an enterprise ready data. So that is called medallion architecture. So we are using the medallion architecture way, but you need not worry about that English. It's a simple activity. Clean the data first, then convert the data as a database kind of a relational database. We have related tables, and then we'll use the star schema, and then we'll convert that into a nice report. That is the objective here. And then how to create a report, how to add one background, backdrop, very simple way. not very hi-fi. So how to quickly create a report, we will discuss about it. So now this is the data. So now we have we have understood all the problem statements, and then let me jump into the next level. So I will be jumping into Power BI. So let me open a new Power BI instance. Very simple way, not very hi-fi. So how to quickly create a report, we will discuss about it. So now this is the data. So now we have we have understood all the problem statements, and then let me jump into the next level. So I will be jumping. Let me a blank report. Power BI. So let me open a new Power BI instance. Now I have my own practice of bringing the data into. Normally, I have seen many Power BI users. They just go to get data and click on Excel, and then they access the data and they load it. Or maybe they load and transform. There are two things. But I strongly recommend, for some reason, the reason is nothing but if you use get data option and load the data, most of the time you end up loading it. That is a common thing. Just click enter and it will be loaded. But I never do that myself. I don't allow myself to do that. Rather, I always go to the Power Query Editor, because the real gateway to Power BI is Power Query Editor. First, data comes to Power Query Editor, then the analysis will happen in Power BI Editor, and then the data loaded to the main Power BI desktop. So that is the reason I always go to the Power Query Editor and start the activity than doing that in Power BI desktop directly. So what happens, one more important thing, as a practically, very technically I'm telling, this is my experience and this is my participants' experience. Whenever you land into Power Query and start loading the data, you'll be more into that act of cleaning the data always. If you're using get data, your thought process will not be on the cleaning data, you are loading the data. So my personal preference is I will not use get data anytime. Rather, I will use the transform data to go to Power Query Editor and start from there. So then I know what options are there in the Power Query, what I should use. Because I think most of the beginners of Power BI are maybe using Power BI for 1 or 2 years. Never they have seen Power Query that extensively. Because Power Query is very powerful. Now, if you go to Fabric or you go to even Azure Data Engineering, so wherever Power Query interface is very powerful, it is growing in a big way. So everywhere Power Query is there. For example, in Fabric, you have basically the data lake Gen 2 or data lake Gen 1. That is purely Power Query experience. So obviously the data flows if you are using Power Query experience. Even Azure also, you have a Power Query experience in data flows. So that means wherever you go, even if you go to Power Apps, there you use the Dataverse, and to bring a data from external source to the Dataverse through the data flows, there also Power Query experience. So you need to have a complete better understanding in Power Query. So that is the reason I always tell my students that, or my participants that, please always start with Power Query Editor. Then you actually, that is a culture. You will start with Power Query, so you will have more understanding of the Power Query Editor. So I'm just going to the Home tab and selecting the Transform Data. So there I see the option Transform Data. This will take me to the Power Query Editor. Now, the Power Query Editor has got various options, which you are now clearly visualizing, and you can try. Then you start exploring the things. That's why I'm trying to say that. So there I'm going to New Source and then select the Excel workbook, and then let me take the data. That is currently what data I'm using. Let me just save this file because I've done small changes here. So let me now go back here and then pick up the file. It's called Power BI Dashboard. This is the file. So I need to open it. Now in this Excel file, there are so many sheets and so many tables, but I should know that I have to deal with one table. You should have a complete understanding of that table. So now suppose I have a revenue data sheet. If I select the revenue data sheet, what happens? Look at the quality. So it is actually picking up the column names properly, but sometimes even it doesn't pick up the column names properly. But when you go to the next slide, it is now picking up unnecessary columns. fees per hour. Till this I want data, but when you select a sheet, it will read the data to a lot because it is having some data in other places. Wherever data is not there, it is showing null and it is reading unnecessary data. Then I need to clean further. Why should I do that? So that is the reason I am selecting revenue. Revenue is a boundary. That means it's a table and it has only one specific boundary. Number of rows, number of columns are limited to that table. Power BI is reading table separately, and that is why I selected revenue. And then I have checked the box. Then you can see the OK button is appearing, and I'm just clicking on it. Then I can see the data is loading. Now I need to start with those actions. Now we are using M language so that we will be understanding it, right? Even I can do one thing. I can even show how to load the data using M language. Let me delete this. So now I need to first go to the file, location, and then I'm just going to that file name, and then I'll press right click. If you're using Windows 10, then you have to use Shift and right click. If you're using Windows 11, just normal right click is fine. You will get one option, copy as path. If you are using Windows 10, then you have to use the Shift and right click. Then also you will see the copy as path option. I copy it. What is exactly copying? It is copying the complete file path, including the Excel file name and extension as well. And then I'll go to the new source. This time I'm using the option called blank query. So here I'm using M language. So I'll just select blank query. Then you can see one blank query is generated, query 1. I can rename the blank query as revenue because my data will be from revenue table. And you can give any name for that. Now let me start working on it. So now I need to start with the formula bar. So let me start writing. So I need to take the data from Excel. It's an Excel file. Now here one more thing you need to understand whenever you are dealing with the data. So if I go to more data sources and if I look at the dialog, you see the data sources are separated by a type, file type, database, and Microsoft Fabric, Power Platform, Azure, online services, and other. So file type data sources, you cannot use direct query or query binding, etc. Right? It's just import query. That is the reason you need to understand what data types are there, what data sources. I'm using file because Excel is a file. That is the reason I need to start writing the formula. The formula is Excel. So I need to start with equal Excel, and then option is there Excel.workbook, open bracket. Excel workbook is a file type data source. So say file contents. Then I need to paste the location of the file. Now you can see Excel.workbook file.contents because Excel is a file type data source. Then where is the file, what file it has to pick up, which Excel file it has to pick up. And if I press enter, you will see the navigation in a different way. Now I have several tables. Now look at this item column and kind column. In the kind column, I have almost 1, 2, 3. There are 3 tables are there and others are sheet names. And the data is actually stored as a table. So you can see that all the data, you can see the tables are there. But now I need to pick up only the revenue table, which is a sheet, which is a table, revenue table. So item is revenue, kind is table. So that for that I need to write the next step. So now currently the first step is written here. I need to now start with the second step. Now in Power Query Editor, all the steps are actually referenced with the previous, primarily the previous step. You can also reference to any other previous step also if you want some different type of scenarios. But here every current step will refer the previous step. So whatever data received from the previous step, on that data I'm doing something. That is what is the intention. So now I can just go to the formula bar. I can click on FX. Now the source is coming. That is the previous step, referencing to the previous step. On top of the previous step, I want item equal revenue, and then kind equal table, And then from there, I want data. So now if I press enter, now I can see the table revenue is loaded. Now there is a step navigation is created, and then you can see the data loaded with many problems. And then from there, I want data. So now if I so with that, you can understand that. Now I will show you the step in a normal user-defined step, but I will show you the formula, then you will understand. Instead, I write the formula and confuse you. First, I will create a step using the mouse interface, and then I'll show you what step is written and what is the meaning of it, then you'll understand better. So for that, let me first understand registration number. When I'm removing the registration number, I'm removing a column. I'm removing a what do you call step. So now I can do one thing. I can right click on the registration number and I select one option called remove. If I press remove, now you can see in the right side, removed columns step added. But how to know that which column is removed? Because you will have several such other steps also later you may create. So I can right click on removed columns, the right side step you have created removed columns. You can right click on it and then you can go to the properties. There you will get a property dialog. Either the column name you can change it, the step name, or in the description you can give registration number column. Step you have created removed columns. You can right click on it and then was redundant. There you will get a property dialog. And then press OK. Now you will see that step has got an information. So whenever you hover the mouse on it, you will be able to understand what exactly you did there. And not only that, when you go to the advanced editor, in the advanced editor, you can see that step is added as a comment. So even advanced editor also, you can see that what are the things you have done, you will be able to understand. So now you have removed the column and look at the formula now. So table dot remove columns and custom one. So that is confusing to people. Now you may say, no, it is navigation. Why custom one? See, navigation is only the name. Only this step. Whenever you bring the data into Power BI, Power Query Editor, only this step will have a pseudo name. The real name is actually column one. Custom one. If I go to the advanced editor, you can see in the advanced editor, the first step is source. The second step one is custom one. It is not navigation. Navigation is a pseudo name to showcase that what you did there, but other steps will be created based on your name only. But yes, it is custom one. So now it is not navigation you can't use the name navigation there because it is created as custom one. Of course, you can rename that if you want, but I am good with that. So that is the reason you see the formula is table.remove columns from the custom one. That is a table. Whenever you are bringing the data from a table, that table is coming from the custom one step. There, whatever its table is there, in the table, please remove the registration number. Suppose I need to remove other column, not registration number. I could have just added that column name easily instead of registration number. If I had customer, then customer column would have been removed. Remove is not equal to delete. So obviously we are not deleting anything. We are removing from the memory of Power BI. So Power BI is now not going to read registration number from the Excel file. So it is using lesser resources to read the data. So you are actually making Power BI's job easy. Now we have a customer column and other columns are there. So now I mentioned about this student name, right? Student name is actually a number column. In Power Excel, it was appearing as student 130, student 131, and so on. So now I want to clean this column very easily. So there are two ways are there. One, you can go to the transform tab. There you can see one option called format. I need to select the column. Otherwise, you will not be able to add the right column in the right place. So I'm going to the format column and you see various options are available where you can see one option, prefix, add prefix or add suffix. So I'm adding the prefix and it is asking what is that prefix will be. I want to add in front student and then a space as well because student space number I want and press OK. you will be able to see that it is added as a student 130 and there is a formula generated. So table.transform columns, then removed columns is your previous step. And then in the student name, for each student, you are actually using a basically a student, and also you are adding a underscore. I mean, the space basically. For all the columns, you need to add the English India. Basically, the language is taken English India. Reason, my language is English India. My system language is English India. So that is why it's taking, and it is actually defining the data type is text. This is not compulsory. Suppose if I remove this, I mean, it will make it ABC 1, 2, 3, but still it is okay. But ABC 1, 2, 3 is not a good idea. When you translate this into Power BI Desktop, automatically this value will be added as a text. But yes, to have the capabilities of calculation within Power Query Editor, you need to have that in the formula. Formula like ABC 1, 2. You can just click on that and convert it into text also. So that is how you can do that. I've added a new step. So what I did, I've transformed the column type, and then the step before step was added prefix, and then student name is the column name. There I'm using the data type as text so that my data is converted. So now you can write this step as it is to convert get the column. So that is where your understanding should be. With that, we have student name column is done, and we have the customer column is fine. Date of joining, you see the date is proper. There is no challenge in this, but the problem with the department column. So whenever you are looking at any column in Power Query, always you need to activate few things. First, activate the column distribution, then column profile, then column quality. Now the column distribution will show you how many are distinct and how many are unique. Now, what is the difference between distinct and unique? Distinct means these values are repeated, but unique means these values are not repeated in the original data. They are only coming once in a time, like as AA, BB, CC, D. So here you have basically 4 distinct and 1 unique kind of, because 4 items are repeating. A repeating, B repeating, C repeating, but D is not repeating. So not 4, it's 3 repeating, 1 not repeating. So that is what the thing. So distinct means they are repeating. The values are duplicates. Whereas U5 unique means they are not repeating. So that is how you see the distribution. Then you see the column quality, where how many are valid rows, how many having errors, and how many are empties. For example, if you scroll right, in this department column, valid are 99%, empties are less than 1%. And also if you go to the duration column, errors are there. There are 17 errors, 2% of the data is errors. And that is how you can see the column quality. Column distribution will show you how many distinct and how many unique. And below, the column profile will show you the complete value distribution and also the description. So value distribution will show you how the values are distributed, and how many rows, how many empties, how many distinct, all the things are available. So that we need to take care of. So that is how we have the column there. So but in the department column, if I select, can you see that the department column, there are 2 missing values are there. That means there is no value. And most importantly, the value distribution. In value distribution, finance, the first one, then 5th one, 7th one, maybe 12th one, all are proper, F capital, all normal data. Why they are coming multiple times? So the basic reason for this is trailing or leading spaces, and sometimes non-printable characters are coming with the text. Non-printable characters cannot be seen while reading it except in Excel. So at that point of time, they look similar, but they are not similar. So how to deal with that? So that is where you have to trim the data. So now we are actually trimming the data. So if I right click on the department, and then I'm just going to the transform tab, there transform option, there you can see various transformation options are there. So now if I go to the option called trim, and if I just click on that, what formula is written? Table.transform columns, and your previous step is changed type, and then the column name is department. In that you are using the trim function, that is a text.trim, and then you can see text.uppercase, text.trim, and those things will come now. You'll see that. And then type is text. Same thing, you'll see one more formula, and where you do the text of maybe proper case. We'll see that. So now you can see that trim text is done. Now the next one is, if I click on the department again, now the another problem is there. So the proper finance is now once, but what about this this finance, this admin, this marketing, this HR, this IT? They are not in the right order. How to clean them? Very simple. Right click on the department column, go to the transform, and select capitalize each word, the capital case or proper case. If I click on that, now if I click on the formula again, the column again, this time the distribution is very good. And also you can see the formula. Now the same formula you written, table.transform columns, but your previous step is trim text, and there you have selected the department column, and you did the text.proper function, and then you have confirmed that this is a data type text, and then the data is now clean. So that is how you can take care of. Now I need to replace these empty values. Now what to replace? That is basically our business understanding. What we need to replace, we need to understand clearly, and what our business says. For me, my business says that wherever the empties are there, somebody were actually forgotten to write it properly. So that is why nothing is there. So wherever that empty is there, they have not written finance. So I'm writing finance there. But problem is I have fin and finance, both are there. I want to first make sure this is only one. Rather, I want to have fin than finance. So I'll right click on department, and I can see one option, replace values. I replace finance with fin, and I can press OK. So that is also resolved. Now I can replace values wherever the null value is there, because empties are considered as null in Power BI. So null to be replaced with fin, and press OK. Now I do not have that problem. If I select this department, you see now the empties are 0, and the distribution is now proper. So with that, I have done all these steps. I hope you are understanding the new thing. If you have not come across this earlier, but yeah, if you know it, maybe what exactly you have added, what added value to you can just tell that in the comment section. So, but anyway, we can go to the next step, that is the duration column. Now, errors in Power BI. How to understand errors in Power BI? So that is very simple thing. First of all, convert that column into proper data type. Sometimes what happens, you might see some columns ABC 1, 2, 3. Means here currently 1.2 is there, right? But I can convert that into that sometimes Power BI accidentally convert that into ABC 1, 2, 3 together. That means ABC 1, 2, 3 it will come. That means no data type. So Power BI is not able to understand what is the data type, right? At that point of time, if when you load the data, you will not see any problem, because technically ABC 1, 2, 3 will be considered as a text column by default in Power BI desktop. So whenever you have such ABC 1, 2, 3, so you need to understand two things. One, whether that column you are using for calculation. For example, employee name, employee number, product ID, or maybe customer ID. And you have alphanumeric and numeric both together. That means 1, 2, 3, ABC 1, 2, 3, both are there with, 1, 2, 3, let us say 450, one client customer ID, and 450A, another customer ID. So these two are there in the same column. That is why it is showing sometimes ABC 1, 2, 3, because it's telling I don't know what is the data type. At that point of time, my suggestion, convert that into text. Don't look into anything, because that column is useless for calculation. So just convert into a text. So no hard work. But it is a number column or a date column, then it is showing ABC 1, 2, 3. First translate that into a proper data type. If it is not proper data type. If it is already there, then definitely you will be seeing the errors. So once you convert into a proper data type, then it will throw the errors, what are the errors are there. Then what you need to do is simply load the data. So I'm just going to the home tab and just loading it, close and apply. Why? Because I want to see what are those errors. So when I load the data, Power BI will throw an error that you are having so many errors. Then what you need to do is simply load the data. Now you see view errors. There are 17 errors are there out of 799 rows. And now if I click on view errors, it will be taking me to the Power Query editor again. And there I can see there is one separate table generated in the left side, errors in revenue, and there are 17 rows. And 17 rows are having error in which column? If I scroll, I can see that duration has got an error. Now I can select one error and see what is that error. So actually, from the Excel, whatever you are loading as a DIV, it's a division error. Same way, you can see all the errors one by one, and most of the errors are having a DIV error or a name error or whatever. Again, you need to understand which error to be replaced with what, right? So now here I want to treat all errors as same errors, like a DIV error, and translating into 20, but you can understand every error what it is. If I select that right side of the error cell, you see that it is telling that for data format error, invalid cell value DIV, because it's a number column. There you are giving me a DIV like hash DIV something, which is I don't understand. So I think this column is having errors because not single one data type, right? So that is the reason I need to resolve it. So now what I need to do? I need to go to the revenue table, and then I need to go to that column. Now, if you know which cell with what value you need to replace, you can do one by one. Otherwise, I will just replace all the values with one single error. So I'll say replace errors and replace with 20 because I'm following a simple logic, and press OK. Then if I go back to errors in revenue, now you don't see any errors because you replaced it and the errors are resolved. So this is one more important step, how to find errors. Because out of 10,000 rows, only 2 errors, that is not your job to understand. It is Power BI's job to tell you. So if you load the data with a proper data type in that column where errors are there, automatically Power BI will translate that into errors and it will give you a separate table of errors. From there, you can pick up whatever you want to resolve, right? Now, I have a separate group also created. I can delete this group because that is not required now. So if you load the data with a proper data type in that column where errors are there, now you can see only revenue table is there. And now I have the errors are resolved. So if you go to the duration column, it doesn't have any errors. So with that, I have taken care of the complete data. Now the next step is I need to make sure that I have my revenue column because revenue is important for me. You can see, revenue column is already there. So I have the column here, fees per hour. But now the important thing is, this is called the silver layer. Bronze layer to silver layer. We are now come to the silver layer. That is a flat file, but complete cleaned up data in the Medallion architecture, right? But now I need to make it as an enterprise level data. So how to deal with it? So now what you can do is you can actually extract all the tables. There are 2 types are there. One is revenue, right click, and then either create a duplicate or reference. Duplicate means you are creating a new query. That means that duplicate will take the data from the Excel directly. Reference means it will take the reference from the previous table. So it will not go to Excel and bring it. But reference will have one small side effect. Whatever the changes you do in the main revenue table will be done in this table also immediately. So you lose the control on it. That is the reason I want a separate independent table to create other tables. So I'll select duplicate option and I'll rename this table as branch. So now I have a branch table and I have a city column. Now I want city is my branch actually. So I want to convert the city, only city column I want to keep. Rest of the columns I don't want to keep. So I can now write a step. This time I'm writing a step. So I'll just go to my formula bar. Then what is my previous step? Replace errors. And one more important thing you need to understand. So currently the replaced error step is coming, hash, double quotes, replaced, space errors. Reason, you're adding it is by default, it is adding a replaced errors as a step that with a space. What I'll do is, I'll rename this as without any space. What I'm trying to say here is keep your step names always without space. Then what happens when I go to custom 2? Can you see now? It is only simply saying replaced errors, no hash, no double quotes. So that is the reason. Whenever a name is created here in the right side, convert that name into without spaces. Then you can also refer this name easily without, when you type it will come easily. Otherwise, hash, double quote, then whatever written, then space, lot of hard work you have to do. So now I'm just starting with the previous step, that is replaced errors. Whatever data I received from the replaced error step, I want to keep the column called only city. So I'll write table dot select columns. And then my previous step is replace errors. You can see select as a table. So obviously replace errors is a table for me. So at that stage of replace error, whatever table is there, I'm picking up that table, comma, and then the columns as any. So when you're actually reading mQuery, you will see three kind of things. I think it is columns as any, as a text, and as a list. So three things you need to understand differently. As a text means definitely as a nullable value sometimes. Now as text, as nullable value, there is one more also, 4 are there. So now what is the difference between as any and as list? As any means if you're writing one column name, no curly brace is required. As a list, you need not define. But if you have multiple columns, you need to create a list. So if you are getting columns as any, that means if you are writing multiple columns, convert into a list. Otherwise, if you are writing single value, then just normally you can write it. But if you say columns as list, sometimes you will get. Then you have to convert them into list only. First curly bracket, inside that the values will be within double quotes, you will write. So here I want to keep only one column. So I'll just double quote and say city, because I don't want to keep anything else. And then I'll just close the bracket. Now when I click on OK, you see that I have only one city, one column, that is city. So branch column is having city. You can see all the columns. Now the next one, I want to remove the duplicates. Now what is my step custom 2? I can rename it as city column selection. If you see, I'm not typing any space, so that the column name I can write easily in the next step, and otherwise it will come also. Now I will add a new step. Now the step is coming. So city column selection. Then after that, I want to write a function called table.distinct. Then I'll make sure that my city column selection step is in the bracket. Then you need to give, if any, multiple columns equation. What is that? Which column is duplicate? Which column to be remove duplicate? Those things you need to say. Here, that is an optional field, because here only one column is there. In that, I need to remove the duplicates. Simply close the bracket. So table.distinct. City column selection means the table which has come from the previous step, and press enter. Now you can see all the values are now only unique. Now here 8 distinct, no unique. Now let me select custom 2, rename that custom 2 as removing duplicates. And then I have my table is there. Now I need to convert this into a dimension table, because it is now normalized. The what do you call that? The occurrence of the value is one time, so that I can add a new column. I can just add one more step. So wherever the step is removing duplicate step is there, where I got a table with a single column, then table dot add index column. So that I can add a new column. After removing duplicates, it's asking me what is the new column name. So as a text, can you see that? It is showing as text. That means the moment it is saying as text, double quotes, name of the column is city ID. And I want to start with initial value 1. And I want to increment it with 1. That means 1, 2, 3, 4, 5. And then the data type is integer 64-bit. That is integer 64 type. Now you have a new column generated city ID with 8 numbers. And now I'll rename this as index column. And then the data type is integer 64. Now my job will be much simpler. What are the other columns I need to create? What are the other tables I need to create? I need to create a customer table. I need to create a department table. I need to create a application table. I need to create a sales rep table. Now, in case of application, I need to bring application and fees per hour together. So let me duplicate the branch table. Now rename that as application. And then now I need to go to these steps. I'm not adding new steps. I'm using the existing steps. I go to city column selection. There I'll just replace this city with application. Since I'm now writing multiple columns, here I'm writing 2 columns. One is application, another is fees per hour. Open a curly brace. After application, comma, within double quotes, fees per hour. This is the structure of the column. Since I have created it, that is the reason I know it. So now I can see, just close the curly brace and press enter. Now this is just giving me only the application and only the fees per hour. I'm not creating a new step. I'm using the existing step. Then I'll go to the removed columns, that is taken care. I'll go to index column, that is taken care. Only thing is the name should be application ID. Now my second table is ready. Now I'll duplicate the branch table again. Now I'll rename that as customer. Then I'll go to city column selection and rename this. I'll replace with customer and removing duplicates. It is taken care. Index column, it is taken care. It is only adding only the unique customers, and the city is customer ID. Of course, in the step also I can change the name, rename that as not city column selection, but customer column selection. You can change the name if you want to be more precise. Now I'll duplicate the customer column table and then rename it as department. Then I'll go to this step and rename the step as department column selection. Then I'll go to this customer, replace with department. And then go to the next step, only unique, then index column already there, and just replace that with department ID. Now I have branch table with branch ID, branch table with city ID, that's okay. Application with application ID, customer with customer ID, department with department ID. Now I need to do the merging because these IDs are not part of my main table. I'll go to the revenue table. Then I'll go to merge queries. I'll merge one by one. I select application. So what is the rule for merging? Or VLOOKUP or joins. One column basically similar in both the tables. A key, matching key should be there with the data type as well. Application is the matching key. So I select application, both the columns, both the tables. Press OK. This will give me all the columns from the application table. I'll just expand it. I'll uncheck all the this thing and select only application ID. Same thing I need to do with other tables as well. Select branch. City is the matching column. And then expand it. Then only city ID. Then again merge queries. Select customer, customer and customer matching, expanded and select only customer ID. Again merge queries. But finally I have to merge with department matching is department and expand it, then select only department ID. With that, I have all the respective IDs. So since I have all these columns, I don't require remaining columns. So now I will show you another way of showing select columns. One is you can remove select all the columns. Otherwise, you can go to the home tab. You can use option choose columns. And I don't want customer. I don't want department, city, application, and I don't want fees per hour. Sales rep also I need to create a table now. I'll do one thing. I'll just remove them first. Then replace the department table, duplicate it, rename that as sales rep, and then just go to that department column. Then this will be sales rep. I think that is not the column name. Column name is sales space rep. So there I need to go to the step sales space rep, come to the next step, come to the next step, and then I'll just remove this department ID and name it as sales rep ID. Then I'll go to revenue table, merge this table also. So I'll select sales rep and select the column which is matching column, that is sales rep, and then press OK. Now expand it, select only sales rep ID. Now I'll come back to my revenue table and remove the sales rep column also. So I can just, I'll do one thing, I'll bring these two steps on top of removed columns. Then I'll go here and write the formula. So that is after department ID, not that. Department ID should not be deleted. I think I have accidentally deleted. Okay, this is the order basically, right? Okay, I'll just remove this sales rep. Department ID should not be deleted. I think I have accidentally deleted. Now you can see all other columns are there. Oh, okay, 1 second. I need to do one thing. Let it be there only. My query is expanded, then remove the sales rep. Now you can see the sales rep ID also. Now our enterprise level data is ready. Now I'll go to home tab, close and apply. Now you can see the data is getting loaded as multi-dimensional data. So all different tables are separately there. Now this is the schema, star schema constructed. And if I go to my schema view or model view, I have a revenue table and I have other tables are done. So that is how you can actually use Power Query to create this. So yeah. So now let me stop there. Would like to hear some questions, if any, so that I can answer them and then take it forward. So that is how you can actually use Power Query to create this. So there is no use case. See, M formula is to make sure that, I think Karthik is asking a question. M formula or M language or mashup language is to make sure that make Power Query more efficient, because in Power Query, almost 80 to 90% activities you can use the interface and do it. But rest of the 10 or 10 to 15% of the activities, you must know the code properly. So then you can clean it. So it's a cleaning process. It is nothing to do with any specific domain or data, right? Any data, when suppose you have a date column, in the date column, the complex dates are there. You need to convert them. There is no option to do just select and convert it. There you need to understand a proper way of this thing, right? Yeah.
Yep, that's really a great session, Vijay. Guys, if you have any questions, you can ask. If no questions, so we can wrap up the Vijay session.
Guys, if you have any questions, you can ask.
Okay. Yeah. Thanks, Vijay. Thank you so
Thank
much
you.
for
Thank
joining
you very
us
much.
for the insightful session. Like on behalf of the HDAC, I would like to appreciate your time, effort, and practical insights on Power BI and data transformation. As you know, Power BI data transformation plays a very key role in each and every dashboard development. You have covered all of the each and everything on the data transformation part and the best practices. That's really appreciated. And once again, thanks for joining and sharing valuable insights on Power BI data transformations.
Thank you. Shall see you then. Thank you very much. Bye for now.
Thank you, Vijay. Yep.
Data transformation part and the best practices. That's really
Yeah,
appreciated.
I guess
Joining
Tika Jain has joined.
sharing valuable insights on Power BI data transformations.
Thank you. Shall see you then. Thank you very much.
Hello, Pragati.
Thanks, Vijay. Yep.
Can you hear me?
Yes, Pragati, I can hear
Okay,
you.
perfect.
I guess
Yes, great to see you
I
once
hope.
again in the global
Yeah,
conference.
yeah, I'm quite excited. I think I've spoken at all the global conferences so far, if I'm correct. So I'm really excited
Yes.
to talk about something new today.
Uh-huh.
yes,
Yes.
Pragati, I can hear you.
Yeah. Amit, could you please make Pragati as a presentator?
Pragati is already a
I
presenter.
think
I think she can
yeah,
share
I
the
think
screen.
I think I can already see the share button. Let me just figure that out. Um, I hope you guys are not hearing like aeroplane voices. I don't know. Today there are so many planes coming over my place. I'm not sure if there's some schedule change or something. I hope
Yeah.
you don't see that noise in the background.
No,
Okay,
it's
let
very
me just
clear.
quickly share my screen. Okay, perfect. Okay, then my mic works if it is clear.
Yes.
Okay, can you see my presentation screen?
Yes.
Okay, perfect. Yeah, I mean, let me know when I can start. I think there's still time. Okay, perfect.
Correct.
Okay, then my mic works. And I'll just turn off my camera so I have all the bandwidth to myself. I hope that's okay.
Yes.
Okay.
Yep. So we can start, Pragati. So before that,
Okay.
I would like to introduce you to the community. Okay. Hi, everyone. So again, we are back with another insightful session. So let me introduce Pragati, who is a 5-time Microsoft Data Platform MVP, and she's a Microsoft certified trainer. And also she is mostly respected and contributor to the communities across India and the global. She has been actively contributing to the HDAC from last couple of events, and she also delivers sessions at global level conferences. And she has a very good implementation experiences and deep technical expertise on Microsoft ecosystems like Microsoft Fabric, Power BI. And we are truly excited to have her with us today. And I am sure this session is going to have a highly insightful and valuable session for everyone. Now the stage is your, Pragati.
Thank you. Thank you so much, Aditya, for that introduction. I think now I don't need to spend time on the introduction because you have already talked everything about myself. So yeah, hopefully everything is enjoying this amazing conference. I know there are so many speakers globally speaking at the conference, and there's so much content out there, so much to learn, and I know how overwhelming these conferences could be. But yeah, I hope everyone is enjoying, and I'm quite excited for my session. And before I go ahead, first of all, thank you everyone for taking out time to come and attend my session. session. And I'm very excited for this session because this is a new one I have been delivering here. And yeah, I think let's just quickly go through what the session is about, a little bit about myself more, and then we can just directly dig into the content of the session today. So as Aditya has already introduced me, just a quick one from my side. My name is Pragati Jain. I am a founder and principal consultant at Data Vibe Solutions Limited. It's a small data consultancy that I run in London, here in United Kingdom. I'm a Microsoft MVP as well, and yeah, I've got a few certifications around Fabric now. And also, if any one of you want to connect with me, I've got my LinkedIn profile, LinkedIn link there, and my Twitter username there, so you can come and connect with me there if you've got any questions. So yeah, let's directly dig into today's session. Now today I'm going to talk, my session title is basically Exorcise Your Ghost Pipelines with Fabric Activator. So we are today going to talk about I don't say it's going to be it is a small problem that we see in the real world scenario when we implement solutions for our customers in Fabric, but it is something I have been seeing multiple times for working with some of the customers before I have worked with. So today's session, if I just take out we are basically today going to talk about a silent budget killer in Microsoft Fabric, and those are basically ghost pipelines. That's the name I call them because they're really ghosty and something that we don't easily identify or understand if we don't keep an eye on them. And these are the pipelines that basically run on a schedule. I'm sure many of you have worked with the customers where there is a scenario where you have to create pipelines that do certain kind of job for you, and then you just put them on schedule so that say they run every 5 hours to run a notebook, do something, update your database, and so on. But sometimes what happens is when you run these pipelines on schedule, they can actually consume a lot of capacity units, and which can be really expensive for you in Fabric, especially when there is no data to process. Now we are going to learn today how to move from passive schedules to the reactive ones, and event-driven architectures using Fabric Activator. I know many of you must have already worked with Fabric Activator before, but I'm very excited to share this with you, this scenario today, because I've implemented it at a customer and it kind of really helped them, solve certain issues. And so in this session, one thing what I would really like to say here, it is not about more than just a new tool. It's basically a kind of shift in mindset, I would say. So basically, instead of polling every 15 minutes, we want the system to tell us when it is ready. The goal is simple. We just want to make sure we have less waste, lower latency, and a much healthier Fabric budget. So yeah, let's just go on to the next slide. I know I'm going to talk about key takeaways and other stuff in the coming slides, so don't worry about that. We will look at everything. Okay, looks like my slide is not working. Okay, now what is a ghost pipeline? Now, when we say ghost pipeline, obviously the name suggests it is something which is not right, but I would say ghost pipeline is technically not a bug. It is actually a design flaw. This is what I've learned from my experience. And so when we schedule a pipeline to say run every hour, but the data arrives say like only twice a day, we are actually paying for 22 unnecessary runs in this scenario. And in Fabric, the compute is matured by every second. And these empty runs end up adding up to a significant cost over thousands of pipeline runs. So like this simple diagram, it kind of tells you a picture what really happens in the real world scenario. We have got so many scheduled pipelines, there is nothing to process, but they still keep on running. So there are kind of a lot of phantom runs going on. It's in the end burning a lot of our capacity units, even if it is not doing anything. There is also a latency gap because when we have like fixed schedules, like every 4 hours or 6 hours or 3 hours, the data actually ends up sitting idle between run intervals as well. And also in the end, it actually adds to a lot of complexity. Like, for example, we end up over scheduling the pipelines to just reduce latency so that they can run multiple times and pick all the data. But it in the end ends up impacting a lot to our Fabric capacity units, and in the end finally to the budget. So this is what we actually start paying the price for. So basically we start paying a cost for doing nothing, and this is actually smoothing and throttling in Fabric. So if you have like ghost runs happening in the background and there is a lot of capacity unit consumption going on in Fabric, then it ends up into throttling. So where the real business critical workloads hit, you may actually just hit your limit, and this will in the end lead to throttling that actually ends up freezing your entire data state. And this is the last thing we want in the Fabric environment, especially when we are working with it, right? You don't want your whole environment to go down, right? Just because of these small issues that you just missed out taking care of. Now, the next thing comes is passive versus reactive. We just looked at the ghost pipeline, which is actually the real bug or the real problem. But the next thing is passive versus reactive. Now, if you see, there are three things on this diagram. One is scheduled, one is polling, and one is event-driven. Now, scheduled, we have already talked about. Schedule is basically where we end up scheduling our pipelines for multiple schedules, for fixed intervals, which actually end up costing more latency. And yeah, it just doesn't help when you really want it to be event-driven. It just takes up everything in the Fabric environment. But the middle column here, polling, this is actually the most dangerous thing what I see in real-world scenario. Because I have worked with customers where they actually build like until loops on their data factory that run like for 24 hours a day, just waiting for one file or one update in the database. And what this happens is it in a way just keeps on, just running your pipelines in the background, looping them until something comes up, and constantly burns your compute just to check for a single file or, just like a row of data if arrives in the data. But the game changer in Fabric is basically Fabric Activator. It kind of completely changes the game by moving the wait logic out of the expensive pipeline engine and into specialized notification engine. The reason it is because it is event-driven. Activator triggers only when something happens, when it identifies something on your OneLake storage. I mean, for example, if you say add a row or say update a row or delete a row in your SQL database, and Activator just picks up that change and then triggers something or triggers a pipeline for something down the line. It is basically not running every time. It is running there, but it is triggering your pipeline only when a change happens on your OneLake. Now, this kind of helps you with zero idle cost because nothing is really happening. Your pipelines are not running like for every hour or all the time in Fabric environment. And also there is like a near instant processing with the Activator. It's like a near real-time thing because if a change happens, Activator triggers the pipeline, it captures the event, triggers the pipeline, and then pipeline say runs a notebook to do further processing. So it's kind of the game changer solution in Microsoft Fabric, which completely eliminates the wait logic for us. Now, the next thing what I really want to talk about is the architecture of the reactive flow, basically the event-driven orchestration with Activator. Now, in today's session, I'm going to show you a very simple scenario. Like this can happen on any kind of, storage location on OneLake, but I'm particularly going to talk about the SQL database because this is where I ended up doing a few things for a customer I worked with a few months back. Now, say you have got a SQL database in Microsoft Fabric, and say I have got a table in there, say a orders table. And what I really want to check on that table is like, say, if a user performs a data manipulation step, now it could be insert or update. If anything happens on that table, then the delta log reflects a change on my OneLake. Now, as soon as something happens on my OneLake regarding the data, I want the Activator to pick up that event change and trigger a pipeline with the special order for a specific order ID for which the row came up or a change happened in the SQL database, and then trigger a notebook that basically processes that specific row and say does a particular kind of update on it. So basically, this is like a grand tour. Instead of a timer, we use an activator here as a scout. It watches my one lake storage. When a change happens here, it doesn't just start the pipeline. It actually passes the specific ID to the pipeline of the row change and does the processing only for that particular order ID. So basically, we are not doing everything for the whole table. We are just doing something for a particular order ID against which we saw a change or an update that happened in the database. And this is kind of like a, classic thing, because we can end up having this scenario because sometimes in the SQL databases, in a table, we end up having like multiple inserts happening, right? And we really don't want like for every time that pipeline keep on running. We really want the pipeline to run when something has really happened, when an update has happened for an order ID, or say when a new row arrived in the table for the order ID, right? So this is the kind of scenario we are going to talk about today in this session. And obviously, cost of checking data, which we have already talked about. Think of it, the good analogy that I think of when I talk about polling and reactive is like, think of this as a doorbell versus knocking analogy. And say, polling is basically you're walking to the front door every 5 minutes to see if someone is there. But reactive is just waiting for the doorbell to ring, right? You only want to go to the door when your doorbell rings. You really don't want to go every 5 minutes to check if someone is arrived, right? So that's the kind of scenario this activator helps us, built in the fabric, where, we can leverage the benefit of event-driven, capabilities rather than, just polling every hour or every 2 hours, the pipelines in the background. Now, how we can configure activator? It is very easy. The best thing about Fabric is like, many things are like just low code, right? You really don't have to code everything in the environment until and unless it's really required. Obviously, for some capabilities, like if you're doing some data engineering in the environment, definitely you need to write a notebook, you need to write a code in there, or say if you're working with data flows, you need to write some Power Query code in there, M code there to do things, to do some magic. But when it comes to like creating event-driven triggers or pipelines, or it's very easy in Fabric. And I come from a Power BI background, and when I started with Fabric like 3 years back, it was like really easy to pick up few things, because few things in Fabric are like just click, click, click and done, right? You really don't need to worry about what's really happening under the hood, because if you're doing everything like in the right order, with the right logic, then everything just goes with the flow, right? So basically configuring the activator in the Fabric is really easy. You can just click and drop and do things. Now, one thing, I'm not going to create the demo from scratch today, but I'm going to show you the created demo at every bit, like how this was created and what elements are included in the demo and how this works. So when we configure an activator, how we configure activator. So in this scenario, what I did was I ended up creating a Fabric SQL database first in Fabric, and the activator, how it actually defines defining the trigger and the handshake is basically the activator detects the Parquet file creation in the one lake, and the logic here what we are using is process status is ready. Now let me just quickly bring my Fabric environment screen as well here, so we know what we are really trying to do here. Let me quickly tell you this before we go on with anything else further. Okay, if Aditya, you can see if this Fabric screen is visible, or if you want me to make this little bigger, that would be really helpful. Or in the chat, if attendees can tell if this is big enough for them to see. If not, let me know. I can increase the size more. Okay, so what I have got is basically I created a SQL database in one of the workspaces in Fabric, and what I did was I just created a normal table in it, and it's a order landing table. And what this order landing table has got, I just ran the query to select few rows from the table, and it kind of comes up with 4 columns. Now, in this table, what I've got an order ID. Obviously, it's a unique identifier that identifies the unique order in my table. I've got a customer name against every order, like which customer placed the order for what amount and what is the status of this order. Okay. Now, what I'm really trying to do here is I'm trying to say, like, if say a new order arrives in my table, say it has got status like ready, or say it has got like process status ready, like ready to be processed. Now, whenever a new arrives for an order in the SQL database, I want the activator to capture that order ID event and trigger the pipeline to run a notebook. So basically, it's a simple 4-step process. I insert a new row in the SQL database. Then I created a data activator. Again, I'm not going to show you how I created the activator. And also, if you guys are interested in seeing how I did this demo or how I created, I have a blog on my website, and the link to the blog is in the slides. So I'll share the slides with the organizer so you can see. So this is a blog I wrote where I actually ended up creating how I did everything, and it has got all the step-by-step process of what this demo is about. So you can go through the blog and look at the demo steps if you're interested in. So what I did, I've got the activator, and what this activator does is it kind of looks at one-leg Parquet files for my certain SQL. I pointed it to the SQL database. So if I show you the managed source here, this activator looks at a stream which is connected to my SQL database, and in that stream I'm actually continuously capturing all the events happening against the SQL events. It could be update, create, or delete. And whenever a new event or a new change happens on this particular SQL database table, I've created a condition like if just that if a change happens, trigger my notebook. And what this notebook, trigger my pipeline, sorry. And what this pipeline is really doing, this pipeline is calling a notebook. And it is calling the notebook with a parameter order ID. And if you remember, there is an order ID column in my SQL database, which is like a unique identifier for the order that arrives in this table. And what I'm doing is I'm passing this order ID to my notebook. And what my notebook further down the line does is takes this particular order ID, as a parameter from pipeline. So when a pipeline triggers, it will call this notebook. And if the pipeline doesn't trigger, it's not going to call the notebook. Right, that's the basic thing here. So if the pipeline gets triggered by the activator, it will call the notebook. The notebook will take that order ID, do certain magic. It will just update the record for this particular order ID with status as completed. So this is what I'm really trying to do with the activator here. Now here what I did was I could have actually taken this pipeline, I could have scheduled it like for every 2 hours or 3 hours or something like that. But that's what I really don't want to do. Because say if I don't have anything happening in this particular table in the database, my pipeline will still keep on running every 2 hours. And this is what I really don't want, because running this pipeline every 2 hours on schedule is going to take a lot of capacity units in my Fabric environment, and it's going to cost me money, which is the last thing I want to do. So that's why we ended up creating an activator. Activator is going to trigger the pipeline only when a change happens on that order table in my SQL database. So this is the kind of scenario we are trying to implement and see how that works. So let's go back to my basically deck. So this is what the scenario, this is what the configuring of the activator is happening here. And defining the trigger and handshake, again, which I just showed you, pipeline parameters, we are using an order ID parameter, and which kind of, maps back to the SQL columns to the pipeline input. So pipeline takes that particular order ID, notebook takes that order ID through pipeline when it gets triggered by the pipeline, and then updates the status against that particular order ID in the SQL database. And then, yeah, I know I should be having this slide in the end, but I really want to put the slide little, in the starting before we go into the demo, is because in Fabric, sometimes, one SQL update can trigger, say, 2 file events. I mean, obviously, it sounds bizarre because if I did one update, then my activator should only trigger the pipeline once, because one activity happened on the SQL database table. But there are certain reasons like why these kind of triggers can happen multiple times. I mean, in those scenarios, I know that there are a few things which is still not there on the activator to handle, but yeah, there are ways to handle these kind of multiple triggers. I mean, it's basically rather not fighting the platform, we code for it. So within the notebook, I have actually added a check that ensures that if a record or an order is already processed, the second run of the pipeline or the notebook will just run and exit silently. So this is like kind of a production grade engineering. So I will show you why this was really required, because this is what really happens. Okay, so let's directly go into a quick demo roadmap. So I kind of showed you in the Fabric environment what my demo is going to be about. So this is basically my SQL database. If a metadata or update insert happens on the SQL database table, Activator wakes up. It captures all the data events, and based on the events that it has captured, it executes the pipeline for every other event it captures. And then pipeline runs and triggers the notebook. Notebook executes, and the notebook just takes the order ID for which the event happened and updates the SQL database with new status for that particular order ID. A simple diagram just to show how the demo is going to flow. And yeah, let's directly go to the demo because there's no point in talking more on the deck side. Let's see it live. Like, so what I'm just going to do is I'm going to just update a row in that order table for you, and I'm just going to change its status to ready, and we will watch how the activator captures the events and then triggers the pipeline, and see it pass the ID to the Spark notebook, and watch the status flip to completed, all without me touching the pipeline. Okay, so everything is automated once it's set up. So let's quickly go back to the Fabric environment. Okay, now there are a few events that I was just making sure it runs this morning. So yeah, there have been few events that happened in the morning around 10:24 UTC time. So we will see anything that is captured past this time. Okay, and even here in the streams, I can show you some live feeds, which I captured earlier, just to show you that, there were a few activities that I saw this morning. Okay, live demos can be slow, live demos. So, okay, my last activity that was captured was at 10:24. So we will see if anything get captured beyond this. Now for this, what I'm going to do everything step by step. Now this is what a table is, okay? And what I've got all the queries ready, okay? I'm just not going to write anything from scratch because I know people know how to write SQL query here, right? If not, that's in my blog. All the queries are there. You can just go on, help yourself from there. So what I've got is I have already got an order ID 101 here. And what I'm just going to do, I'm just going to update its status to processed in this table, just to make sure there is an event update on this table in SQL database, basically in a delta log or file in OneLake, and then Activator captures that change. So I'm just going to run this query. The query ran, and I'm just going to run the top query to see that the status for 101 got updated to ready. Okay, now if I go back to my activator, okay, now activator can take some time. Okay, so let's just wait. It will capture the event. Okay, it will capture the trigger soon. So we have to be just patient with it. Sometimes it is not okay. I think it captured. Now let's just wait for a few seconds. It will come through. Yeah, this was the last. It just captured the 12:23. Can you see? There's a new event I can see. I'm just going to, just make this here. So a new event was captured by Activator at 10. This is the UTC time at 12:23, and now you can see it actually captured 2 events rather than 1 event. Though I made a change, only 1 change in my SQL database, but I end up seeing 2 updates in the Activator, it captured 2 events. And if I see here, if I just go down the line, there is a lot of information that Activator captures, but I will show you the exact subject. Now, it ended up capturing 2 Parquet events for one change that happened in the basically, you know, on the SQL data, on the SQL database table. Now, the reason why it captured multiple times, now see, it actually ended up capturing a third event as well. Okay, now let me just give you a little bit, you know, background around it, why this can happen. Though I made one change, but it still captures multiple events. It has captured 3 Parquet events now for me rather than 1. It was 1, then 2, then this is the third one I can see, right? Now, why this can happen? Now one thing. What we are seeing in the subject column here is like the underlying file system operations of the Delta Lake format that basically powers Microsoft Fabric. Even though we ran a single update statement in the SQL database table, the storage layer, which is basically a one lake, it is doing more work behind the scenes. Okay, now just giving you a reason around why I might be seeing the 3 Parquet events. It could be 4, it could be 5, but currently we see 3 Parquet events, right? For 1223 trigger. Now, why we might be seeing it? Now, when we performed an update into the SQL database table, basically in way we have updated the Delta file on the one lake. The system doesn't just update a row to a file, it actually performs certain number of transactions. Now, for example, now the first thing what it actually did a write operation. Basically, it wrote the actual data to a new Parquet file. So that is basically the first Parquet event that I see here. Then the second could be the checkpoint metadata Parquet. Now, why this is? Now, depending on the size of the table configuration, it may generate like, say, auxiliary Parquet files for metadata or say for V-order optimization. So basically, it is just a Fabric's way of making your Fabric Parquet file super fast. So that's why it generated a second event there. Now, talking about the third one, now this is basically the Delta log update event, which kind of would have happened, which can sometimes trigger a notification that, you know, Activator picks up if it is watching the folder level rather than the table level. So these 3 could be a potential, you know, reasons why for one event we end up seeing 3 events captured by Activator. Now, obviously, our Activator captured 3 events, so it must have triggered the pipeline multiple times. Let's go to the monitor tab, and I can clearly see it triggered pipeline 3 times, right? I mean, obviously, this is not UTC. This is BST time, but it kind of triggered pipeline 3 times. But when I see it triggered pipeline 3 times, the next 2 pipelines actually exited quite early, right? You can see like they didn't do much. Now, the reason why they didn't do much, I'll tell you something here, okay? Let me just go back to one thing. Yeah. Okay. Now, when the first pipeline ran, let's go to this pipeline run. And if I see the activity here, it actually triggered the notebook. And if I see the input here, we did an update for an order ID 101 that was passed as a parameter from my notebook to the from my pipeline to the notebook. And when I went to this notebook processor, and if I just go to my notebook snapshot, like what it did with this particular triggering of the pipeline and then execution of the notebook, I see that I'm just going to hide few things, okay? What my notebook did, it got order ID as a parameter, okay? And in the end, it just updated its status to completed in the SQL database, okay? And now if I go back to my, say, SQL database and say, if I just run this query again, say we updated it to ready, right? Which Activator picked up, triggered the pipeline, ran the notebook, and it should have updated the status for this 101 order to completed. Now I'm just going to rerun this query. And then we clearly see for 101, a process status is completed. It means our pipeline ran successfully for the event that it got captured by Activator, and then further ran the notebook to done all the processing. Now, one thing I want to show you in the notebook is the guardrail that I have put in the notebook. Now, in the notebook, what happens is if nothing has happened, right? Now you can see whenever it checks for an ID, it actually goes back to the SQL database and checks its status. If it is already completed, it just says it's a duplicate trigger, exit safely. So it's basically not going to run any of the cells beyond this particular cell. So this is the kind of guardrail I have put in the notebook to handle the multiple runs. So there will still be multiple runs, but the other runs are not going to run. They will just exit quickly. So when I go to monitor, again, I'm going to the monitor. See, there's another fourth pipeline ran, maybe Activator captured another fourth event here. So there could be scenarios of multiple events here, but I'm going to go to monitor and show you the second run. Now, this was the first run where our Activator actually triggered the first pipeline, processed the notebook, and the notebook updated the status. Let's go to the second notebook run, which kind of exited very quickly. I go to this notebook and see if we see something different here, okay? In this case, I'm going to take the notebook, go to the notebook snapshot again, and see what it did. Let's go to the second notebook run, which kind of exited very quickly. Yeah, sometimes these things take little time to load, but it's okay. Now for the second run, let's see if it shows me the updated ID, order ID 101, and see if it kind of exited. So see, for the second run, what it did was it actually went back, took this order ID to the SQL database, and it says there is no record find for the ready status and exit and nothing to process. And that's why this notebook actually exited from the second cell and didn't process anything. It just canceled every other cell beyond that. And that's why in the monitor tab, when I go to the monitor tab, here again, my second pipeline run, which was here, it actually exited quite quickly. And same thing happened with my third one. I can show this to you again just to tell you like this is really truth. I mean, it triggers multiple times, but it exits. Again, third pipeline run took 101, but the 101 status is already updated to completed in database. So if I go to the notebook snapshot, it will again show me same thing for that particular time. It will say there is no ready status to be processed for this particular ID, so I am going to just exit it. That's what it's going to do. See the output in the notebook. Again, it says no records found in ready status, evaluating, nothing to process, right? So this is the kind of guardrail I ended up putting it in the notebook side rather on the pipeline side, because I can't control the number of pipeline triggers. Now see, there was a fourth pipeline trigger. Let's see what this pipeline trigger did. Again, I'll go to the pipeline logs. I'm going to see it's again gone for that 101, right? And it called the notebook. Let's go to the notebook snapshot again and then see what it done. It should have done the same thing because in the SQL database, that record is already updated to complete, so it has nothing to do. So if I go here, again, this is the final run. Again, it said, see, this is the 1329 run, right? So I am showing you the recent logs for the notebook, like, okay, there is nothing to do, and it just exits. So this is the kind of guardrail that really helps us, with controlling these multiple pipeline runs, because we can't control the number of events. I'm just going to close a few things here. Because we can't control the number of delta log events that gets created on the one lake, right? I mean, if there are 4 events for one change that we did on the database, like say there are 10 changes, that could be like 20 certain scenarios happening here, 20 times pipeline running. But you really don't want that pipeline running for long, because again, in the end, it's taking up your CUs, it's taking up all the capacity unit and the cost that you're paying. So you need to put some kind of code check somewhere where it exits quickly. And that's what happened. Only the first pipeline run did the job for us, and the next 3 just exited quickly. So that's the kind of, production ready engineering we need to do when we are working with Activator to handle this kind of scenario. Now I'm going to go back to this deck now, because this is the demo I really wanted to show you guys quickly and run through it, but we have got few things on the slide deck, so let's just go. So basically on the demo, what we did, we basically updated one row. We saw that Activator identified all the events, and we saw the pipeline wake up. we saw that it passed the ID to the Spark notebook, and we saw how the state. So basically on the demo, what we did, we basically updated one rule without me touching the pipeline. So basically everything was automated once it was set up properly. I didn't do any manual intervention while this process was running in the background. And now see, this is actually not running on schedule. This is only running when a change happens on the table. So basically everything was and only it triggers the activator. So basically, Activator keeps on running in the background, but still my pipelines are not running, right? Now, there is one caveat to it. We can talk about it in the end, but yeah, this kind of solves the issue of scheduling your pipeline for every 2 hours, or say, keep your pipeline running continuously in the background for 23 hours just to see if one row of data arrives or one file change has happened in the environment. So this is how event-driven triggering can help us, overcome this scenario of, scheduled pipeline runs. Let's go to the next slide. And yeah, as I said, I've got a blog which I just showed you, which has got all the steps of how to create this demo. And it's a very simple demo, nothing, big thing you need to do. It's just click, 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 and it just gets implemented. It's just that you need to do it in a proper way. If you miss one thing, it might create issues. Especially configuring Activator can be sometimes dodgy. So you need to make sure you're following the right steps, you're implementing the right logic and right filters to, configure your Activator. And obviously making it production ready, we talked about it. So make sure your security is, basically, if I want to talk about or if I want to move beyond this demo, we should be using service principles and so token-based authentication, because if we want to make it production ready, we have to go that way. We never hard-code passwords. We also ensure that our notebook logs its success or failure back into the audit table. So I think I missed showing you one thing. I do have an audit table in my SQL database, and it kind of captures everything that my notebook is doing. So if I just show you, what it is really doing is, if I just run, it is just capturing all the processing that the notebook did for this particular order ID. You can see, let me just show the latest one above. So you can see for 9th May 12/24, which was the last event, which I just showed you, the Activator captured everything and processed that 101 and updated its status. So this is the kind of audit we should be keeping in, because it can just help us trace back any success or failures happening with the notebook or pipeline run. So it's a good practice to have audit tables always in the databases. And then the second thing, error handling, logging failures, back to that audit table, and then multiple inserts simultaneously. This could be a thing of scalability, right? There could be multiple inserts at the same time, right? Rather than there could be multiple inserts at the same time, right? So we need to handle those multiple pipeline runs, and I showed you a way of doing it in the notebook. But again, when it comes to say 100 runs in a time, we might need to go with some other options to handle that as well, because there are ways to handle these multiple runs at the pipeline level as well, which I have not shown in this demo because it is kind of a bit tricky thing to do. But yeah, that can be done at pipeline level. In this demo, I just showed a simple way to create a guardrail within my notebook by adding a simple code to it. Then the summary and call to action. So what we today talked about, I think our goal in the end, whenever we create a solution in Microsoft Fabric, is in the end is just efficiency, right? So we have to make sure we stop polling our capacity to death, because those schedule runs, those pipeline running in the background for every hour can really kill our capacity, right? So that's why we need to start reacting to the data. So our budget and monitoring logs are going to thank us a lot in the end, right? So just the key takeaways from our today's session is, we need to make sure it is schedule free, right? We need to reduce empty runs and save our capacity units. We want the runs to only happen when there is a job to do. We just don't want our pipelines running idle in the background, doing nothing, if nothing is happening with the data, right? So we need to make sure they are event-driven. And we need to also make sure they are near real-time processing. So like, for example, I showed you Activator. It took few seconds to identify or capture the events, but in the end it did, right? So it is, I won't say it is real-time, but it is a near real-time process. It is still saving a lot of money, right? Because it's only reacting when something is happening in the data. And also it is a low-code approach, right? I mean, Activator is kind of bridging the gap between your SQL and pipeline, because you're not doing any hard coding. You just do some clicks and configure the Activator, and it takes care of everything, right? It is just helping you not to go through that scheduled pipelines and ghost pipeline run solution, which is going to in the end cost you a lot. So yeah, this is basically the session today that I wanted to talk about. And yeah, I mean, you guys can, there's a challenge code going on at the conference. You can enter to win. You can scan this code. You can answer questions and then submit your answer. And this can actually help you win some amazing gift vouchers and DP600 and DP700 vouchers, which are the great certifications. If you're working with Fabric, it kind of gives you, expertise and, helps you understand how good you are with Fabric. So yeah, fill this participation soon, and then you can win these vouchers and, certification vouchers. And yeah, thank you in the end, guys. If there are any questions in the chat, I'm more than happy to take. And yeah, let's connect and continue the conversation. You can find me on LinkedIn. You can find me on Twitter or X. This is my company email if in case you want to email me with few things. So yeah, this is what I really wanted to talk about. So I'm going to exit the slide and I'm just going to go back to the chat. And then I'm going to turn on my camera so we can have some conversations if there are any questions in the chat. Email me with few things. So yeah, this is what I really wanted. Which Fabric items can be directly triggered by an activator? So there are few things you can do with the activator. So like, I'm still sharing the screen, right? Okay, let me go back to the activator. Now, whenever you configure Activator, you can actually trigger a pipeline. So let me show you. I'm just going to, one second. I'm just going to stop my Activator. Oh, it kind of stopped. I don't know. Yeah, I'm going to stop the Activator for now. I just don't want it to keep on. So whenever you create an action, like if I'm understanding a question correctly, Nagaraju, I think you want to see what Fabric can what Activator can actually do, right? So Activator can do a few things. There are few actions. It can actually send email notifications. It can send Teams notification. It can also run a data flow. Now, one thing, this is under preview, okay? So you have to be very sure if you're trying to use this for a customer. It can run a pipeline, which we just did. It can run a Spark job. It is there. You can try it. It can also run a notebook. So if anything happens, run a notebook directly rather than having a pipeline. And also it can run a function which is still in preview. And here you can also create some custom actions. I haven't explored this in detail, but I'm sure there is documentation around creating custom actions with Activator. Okay, Pushpin, can we use the Activator when we fetch the data in CSV format or Parquet format? Okay, so one thing, Pushpin, anything you do in Fabric that in the end lands as a Delta log file in your OneLake, whether it is CSV or Parquet, right? I mean, everything is in OneLake. So basically, you're creating Activator on top of your OneLake. So it doesn't matter if your source is a CSV format or a Parquet format or a JSON, I don't care, because everything in the end will be ingested on your OneLake and stored in a OneLake. So you can do it using it. Can we call an ML model? Amit, I don't think so. We can call an ML model using Activator because I haven't seen that and I still don't know if there's a way to do it. I'm not sure if someone else has tried that in the chat, but I have never tried an ML model doing things with the Activator. So sorry, Amit, I don't have answer to that. But here, if I don't see calling a ML model action here. I'm not sure if it is possible to do it using a function or creating a custom function. But yeah, I can't see a direct option to do it or use it as an action. Any more questions, guys? I mean, more than happy if you guys want to put in some comments around the things that we just saw. It's always good to see what people's thoughts are, while seeing the demo or the session that we deliver. So happy for any comments that you guys have got in the chat here. More questions, guys. More than happy if you guys want to put in. And also, I've put the link for my blog in the deck. I'll share it with the organizers. So there are steps how this demo was created. So you can just go and replicate the exact demo in the same sequence, and then you will be able to, try this scenario. And also, I've put the link for my blog in the deck. I'm not sure if there are any more questions in the chat, guys. This demo was created. So you can just go and replicate the exact demo in the same sequence.
I don't see any more questions, but I think it was a very good session, and I think everybody liked it. Yeah, but I think Activator is one topic which is little, when you need it, you use it. So you need to explore it little, but I think good that you have given a session on this topic.
Yeah, I mean, there are a few obviously things with Activator, which, I should not say it loud, but yeah, there are a few caveats there. Like, for example, your Activator keeps on running in the background. It still takes a lot of capacity unit, right? So if you are trying to implement this scenario, you really need to make sure if you want to do that, right? Because we are not having the pipeline running in the background, but we still have an Activator in the background, keeping a watch on the delta log files on the one leg if anything happens. So it still takes a lot of capacity unit, but I haven't seen it taking that much capacity unit that it's trying to take your capacity down or to death. So it still works in few scenarios, but I'm really not sure when you take it to enterprise level how this is going to behave and how it can impact the cost on the fabric side, but it is like a worth testing scenario when it comes to these kind of things, like do you really need scheduled pipelines, or do you really want your pipelines running forever in the background for like whole day just to capture one event that might happen. So yeah, I just wanted to share the use case that I just ended up doing for a customer, which kind of resolved this scenario issue for them of ghost pipelines running in the background. So yeah, hopefully everyone liked the session, and if there are no questions, like enjoy, guys, the rest of the conference. This is an amazing conference. You have got amazing speakers sharing their knowledge from around the globe. So yeah, hope you enjoy the conference and have a nice time, everyone, at the conference. Hopefully everyone liked the session, and if there are no questions, like enjoy, guys.
Thanks, Pragati. I think we're waiting for the next speaker to join. Rajendra is going to join in a few minutes. We'll continue that.
Yeah, definitely.
Wonderful session.
Yeah, and if there is anything that you guys want to reach out to me, you can reach out to me on LinkedIn or LinkedIn. I'm pretty active on LinkedIn, so reach out to me on LinkedIn or I'll keep an eye on this chat for some time. But yeah, can't promise much. So yeah, definitely reach out to me on LinkedIn if there are a few questions around this session. Thanks, everyone. Have a nice time, and have a rest of the conference. Great, enjoy it. Bye. Take care.
Thank you.
So reach out to me on LinkedIn or I'll keep an eye on this chat for some time, but yeah, can't promise much. So yeah, definitely reach out to me on LinkedIn if there are a few questions around this session. Thanks, everyone. Have a nice time, and have a rest of the conference. Great, enjoy it. Bye. Take care.
Guys, we have 12 more minutes for the next session to start. So you can take a quick break if you want and just come back. Guys, we have 12 more minutes for the next session to start. So you can take a quick break if you want and just come back.
Hi, all. Speaker has joined Rajendra Ongole, and I have made him presenter also. Moderator, if you are there, please take. Yeah, I think Chirag is trying to get enter some time, but he's not able to.
Yeah, hi Amit. This is Vijay.
Yeah, yeah, I think Rajendra is there, and I think Chirag is trying to enter for some time, but he's again getting back.
Yeah. I don't know. Something happened. Even I'm trying to admit him, but it is just saying admitting.
Okay, fine. I think we can continue. We can. I have almost time. Yeah, I think we can start in a couple of minutes, and meanwhile, let's inform on the group that Rajendra. Hey, welcome, Rajendra.
Something happened.
Hi,
Yeah, hello Rajendra sir.
hi, Amit.
Saying
Good evening.
Okay, fine. I think we can continue. We can.
My voice is audible, Amit?
Yeah, I think we can start in.
Yes sir, but if
Yes.
can you be a little bit more loud, or can you
Sure,
volume
sure.
up?
Sure, sure. Definitely.
Yeah, hello Rajendra sir.
Hi, Amit. Good evening. My voice is audible, Amit?
Yes sir, but if
Yes.
can you be a little bit more loud, or
Now it is audible? Sure, sure.
yes sir, it's better.
Okay, okay. Thank you.
Can you please check if you are able to share the screen, sir?
Okay. Share my screen. Now it is audible?
Yes sir, it's better.
Okay, okay. Thank you.
Can you please check if you are able to share the screen, sir?
Okay. Share my screen.
Yes sir, it's better. Can you please check if you are able to share the screen, sir?
I'm sharing my screen. Can you see my screen now?
Yes sir, you can see your screen.
Okay. Fine. I will stop my screen sharing. Whenever we are ready, I will get started. Okay?
Yeah, we can just start in 5 minutes, sir. The
Sure.
session started at 6:30. Yeah.
Yeah, sure, yeah, sure. I'm sharing my screen. Can you see my screen now?
Yes sir, you can see your screen.
Okay. Fine. I will stop my screen sharing. Whenever we are ready, I will get started. Okay?
Yeah, we can just start in 5 minutes, sir. The
Sure.
session started at 6:30. Yeah.
Yeah, sure, yeah, sure. I'm sharing my screen. Can you see my screen now?
Yes sir, you can see your screen.
Fine. I will stop my screen sharing. Whenever we are ready, I will get started. Okay?
Yeah, we can just start in 5 minutes, sir. The session started at 6:30. Yeah.
Yeah, sure, yeah, sure.
Yeah, let's get started.
Yeah. Can I start sharing my screen?
Yeah, you share your screen, let moderator introduce you.
Okay.
Vijay is there? Yeah, let's get started.
Yeah.
Yeah, let's wait for Vijay. Yeah, you share your screen, let moderator introduce you.
Okay.
Vijay is there? Let's get started. Yeah, let's wait for Vijay. Yeah, you share your screen, let moderator introduce you. Vijay is there? Let's wait for Vijay. Vijay,
Sir,
you there, moderator?
Yes, Amit. I was about to say, Rajendra, we can start the session, sir.
Sure. Definitely.
Yeah.
Sure.
Hi all. A warm good evening. We are very excited to have an amazing lineup of speakers. So before we begin today's session, here is a quick update on the exciting community challenges and rewards. So challenges include social media challenge, DP 600 and 700 watch challenge, max sessions attended challenge, best questions asked challenge. So once you participate in these challenges, the rewards include our DP 600 or 700 certification vouchers, Amazon gift vouchers, and community recognition special awards. For social media challenge, share your I am attending post on LinkedIn, X or Instagram and tag the India Microsoft Fabric user group and Hyderabad data and AI community. We encourage everyone to actively participate and engage in the team's chat, ask meaningful questions and make the most of this community event. And now let's move to today's session and welcome our speaker. social media challenge, share your I am attending. Please join me in welcoming Rajendra Ongole, a Microsoft Data Platform MVP and BI lead at Bosch. Rajendra is an recognized expert in Power BI and Microsoft Fabric, with a proven track record of delivering scalable analytic solutions across industries. Beyond his professional achievements, he is a passionate community leader, certified trainer, and a frequent speaker who inspires audiences worldwide with his insights on data and analytics. Today, he brings that expertise to us. Let's give a warm round of applause for Rajendra Ongole. Yes, sir, please take over.
Yeah, thank you so much, Vijay. Thank you so much, Amit, for giving this opportunity. I will get started with this. So if you're observing my screen, from data cures to knowledge, how we are going to bring the knowledge on ontologies with Microsoft IQ, semantic intelligence. So I have flowed up with multiple agenda part. Okay, so it has been comes up within one of the real-time scenario. What kind of a mechanism we are going to use it for the semantic intelligence via Fabric IQ, which is an ontologist part, and how we are going to give the connections and relationship here. And already introduced by Vijay. So I am myself Rajendra Ongole. I am a Microsoft MVP on both Power BI and Microsoft Fabric. And if you want to reach out to me, you can scan the code and you can connect me there if you have any queries on Microsoft Fabric related topic or Power BI. Let's get started with our agenda. So here I have distributed in this way what is an ontology and how this Fabric IQ architecture in a simple mechanism instead of using the existing Microsoft Fabric Learn architecture. I have given within a very simple way of what kind of a layer we are going to use it in the Fabric IQ, and also the data flow diagram, how we can try to project it within one of the real-time scenarios within aviation industries. I'm going to walk you through that. So in that form of a step-by-step process. And if you're observing this domain, how this airlines is linked up or having the relationship with the terminals. Hope many of us went to the airports and we'll go to and pick up some airlines and some terminals, and how these has to be restricted. I go to the gates and the flight and then operating way. We will follow some sequence as well. I will give it in very detail how it has been get interlinked with each and every of the table or entity, and how it will be get detected at the backend part. We know and Power BI part automatically if you load a specific number of tables, it will give automatically some model as some relationship detections too. So on this Microsoft Fabric IQ, how it will be get derived in an easiest way, in a smart way, you can say, and over the many operations, how it will be get connected to one table to the another table, we will discuss in detail there in the labs part. Walkthrough domain part, and the key concepts we are going to define, like some of the tables. What I will do in the sense in the regular from morning onwards, we discussed about how the lakehouse has been get created and so on. I will showcase to you the similar kind of a terminology. We will try to extract some of the tables if you're observing like airlines, terminals, gates, and so on via lakehouse. We will store it there, and one of the real-time data like a sensor data, how we are going to read that sensor data, flight sensor data from event house, and that particular sensor data, how we are going to merge or else how we are going to configure with the sync with the existing tables. That particular walkthrough is very interesting. Hope you like it. That specific process I'm going to showcase to you in the fashion, like via Microsoft Fabric and approaches part. And if you're observing, we are going to discuss key concepts as well, and the AI readiness, what kind of features and functionalities that are available in the ontologist part, the layer level, which has been inbuilt in the Microsoft Fabric. And if you have any queries, please post it your queries, and I'm happy to take your queries at the end. Fine. What is an ontology? If you're observing here, an ontology is a structured semantic representation of a domain. So we are already aware the load of the data into the Power BI general. If you load multiple tables, we know the rows, columns, and how the relationship has been exist from one table to the another table, like example, product to the product table to the sales table, how it has been linked between one to another based on some unique information like a product ID to the product ID, and how these connections has been existed between on the modeling, defining, and Power BI. Like the way, if you're observing these ontology features, which has been introduced by Microsoft, is a seamless integration where we will see the different types of entities and how the relationships has been triggered between one to the another table, and we can even follow various vocabulary, how it has been linked up with one to another based on identical columns or similar columns between table to the table. And this, when you are trying to build a semantic model, how the model or else the data sets has been linked up with the one to another, this functionality also we are going to observe via ontology functions part. Some of the times, if you are importing multiple tables, we will see some disconnected tables also in Power BI if you are loading multiple tables, if you are not giving some auto detection of the relationships. So how this has to be interlinked with the existing table. This kind of a connections mechanism as well, we can easily find out via this concept name called ontology. And even we can see, as I said, completely defined vocabulary, how these connections or else a relationship has been exist between one to another. We can easily identify via graph mechanism internally has been exist on Fabric IQ. So again, the Fabric IQ is a semantic intelligence layer. Within this, whenever if you're extracting multiple tables into either to the Power BI or in the ontologies part. And as I said, for today's activity, I'm going to showcase to you some of the tables which I said it as an aviation related industry. Some of the tables I'm going to load it into the lake house, and one of the table I'm going to extract it via event house streaming source system wise. Like a sensor data, I'm going to inject some data, and how that particular streaming data I'm going to bind or else sync up with this existing semantic model, that is airlines related data. I'm going to showcase to that. And finally, the main activity or else what kind of an advantage if we can make use of this ontology functionality in Microsoft Fabric. If you're observing visually, we can easily identify how the connections are entity to the another table entity, how the relationships are connectivity has been exist, and it is easily navigatable from one table to the another table. Maybe if you want to rename it, or maybe if you want to change some data type functionalities and so on, we can easily detect and find out the knowledge graph as well. And even we can write some queries where it will get detected and projected some of the outputs, and it's completely an enterprise level scalability part. If you're observing this particular Fabric IQ architecture, the first three layers like data source, storage layer, semantic layer, we are very familiar. It comes up with a few of the data sources like CSV or Excel files, or maybe if you're extracting from cloud-related databases or via API REST APIs, or maybe if you're extracting data from IoT source systems and endpoints too. We are familiar with the types of source systems. The data should be resides at different places. Like example, as I said, if I want to build a project on aviation-related, flights-related data, some of the tables will be get resides like airlines data is resides on some flat files, or maybe the gates, flight gates. Maybe if you are moving on to if you booked a flight ticket, we have to check it out at some particular gate. So the gates related information is stored on some another databases. Or maybe if we want to find out track the luggage related, that is going to be the IoT, live storage, real-time data, that going to store are available at different place or else different way. We are aware of the first layer, that is the data sources. Where it will be get stored. There are different options here. If you're observing the storage layer part, if your data is an unstructured or semi-structured, in such kind of a scenario, even the structure too, we can store the information on the lake houses, the files or databases and so on. And of our source, as I said, I'm working on a streaming source system and the data should be completely real live data. In such kind of a scenario, I'm going to use the KQL database, which is already available in the Fabric, Microsoft Fabric, which is event stream wise. I can inject the data and I can store it via event house. And the last part is one link. That is complete and unified platform where the layer, the foundation layer wise, it will be get built and we can fetch it over data from various workloads too. You can use for the data science applications, or maybe if you can make use of the data engineering concepts and so on to avoid the deduplications, we can make use of the storage layer is one lake storage. The first two layers is very clear, data sources and storage layer. Fine. Maybe I want to build from the lake house, I want to extract few of the tables and build some Power BI report. In such kind of a scenario, we are going to make use of the semantic layer. Like example as I said, is generally we are already aware of it. Power BI semantic model. We will try to fetch it over some of the tables or files and give the name with some connections between one to another. Example, the hierarchy should be something like example, terminals to the airlines or airlines to the terminals, vice versa, based on the airline's ID, if you are working on an aviation related, or maybe from the airlines to the gates and followed up with flight details. If you went to the airport, this is how we will go first to the terminal. We will find out which terminal we are moving on. Is that a T1 or T2 in Hyderabad itself? If it is a domestic, one particular terminal. If it is an international, we will go to some different terminal. There should be some hierarchy here. T1 or T2, T3 and so on. Like that, the hierarchy, or to find out the hierarchical part, T1 is going to the terminal and followed up with the airlines. And again, from airlines, it has to get connected to the which gate of the airlines or that a particular flight is available. And from there, we will navigate and move on to the flight information. Then we will take the particular flight. Like that, we were going to prepare a proper semantic model. And we know the relationship has been built based on the common connection between one to another tables. And based on the measure, business logic, we are going to implement it via measures. And if you're working on the Microsoft Fabric, the data should be stored in the direct lake itself, until unless if you're using the Power BI desktop layer and you can use the direct query mechanism. But if you're using this mechanism, the data will be reflected on the direct lake itself in the Microsoft Fabric. The first three layers is very clear, like a data source, storage layer, semantic layer. And if you're observing how this ontology layer will be add to our architecture means, sometimes, as I said, automatically the relationships between two tables, entities, it will be detected. And if not, we have to give it the connection or else the relationship between by identifying the entities or tables based on the key columns. Likewise, it is seamless identifying the business vocabulary of one table to the another table. And we are going to find out the relationship very easily via ontology concept. And sometimes if you are trying to configure or sync, specifically we will have a name called a bindings. Another name is syncing with real-time streaming data with the static or else connected tables means we can use the static plus time series sync up. And finally, that is navigating to the Fabric IQ, which is already there on your Microsoft Fabric Power BI layer, while giving the connections between one table to the another table. How these tables or entities, it is generating the connections between one to another. These are all the details while working. Maybe that while doing the particular exercise demo part, I'm going to showcase to you how we are going to generate that particular ontology concept on the top of building a semantic model. This is how the Fabric architecture, if it has been included within IQ. As I said, you can take one example end-to-end flow here and taking it as a CSV files and one of the streaming source system, which I'm going to extract via event stream. Few of the tables like I'm going to extract with a CSV format where I'm going to use it as a standard procedure like a lakehouse files. I'm going to pull it over some of the tables, airlines related data, aviation related data, files like flights, airlines, terminal details. I will also showcase to you, and the data sets are already available in my GitHub. You can also pitch it up and make use of it, maybe if you are doing some practice. And after that, what we will do in the sense, end-to-end flow wise, we know how to extract the data via lakehouse, like files. If it is if you are considering the CSV files, we know how we are going to bring it over to the lakehouse. After that, we will convert that particular CSV files, which is a comma delimiter, to the proper standard table. We will modify into it. And from there, we can navigate and we can also make use of some kind of a semantic model design. We know how we are going to build it over the semantic models between bringing the connection between one table to the another table, relationship bringing. After that, once if you can configure the semantic model with all the aviation related data, we can also fetch it and generate ontologies. We can find out the business vocabulary between one table to the another table, how it has been bringing the relationship between one to another, or how this particular ID column has been getting impacted with another table. Okay, and even very deep down manner, we can easily find out how the relationship has been giving a functionality in the layer wise from one to another table, entities part. And finally, we can also find the business graph, knowledge related design, which has been giving a connection to the one table to another table. We can define it, which is the preview feature. I will also showcase to you how this methodology works on once you define a semantic model. Example, as I said, though I have to change the title, it's not a healthcare related, it's just taken as an airlines related. How this ER model has been get reflected. As I said, from terminals, which terminal it is that a T1 or T2 and so on. It will be get references to the airlines based on some airlines ID. And from airlines, it should be navigate and flow the data to that particular gate table, gate ID. And from there, the hierarchy should be the flights and so on, flight sensor data and so on. So what I will do in the sense, as I said, if you are observing the notes there, I'm going to fetch one real-time data via event house, KQL database. Data set is there. And that particular sensor data, I'm going to combine it with the existing, the above ER model. Airlines to the flights, flights to the gates, and so on to the terminals. How it has been get connected to the another sensor related data to our model, ER model. This kind of a methodology, or else this particular mechanism, we can try to bring it over ontology mechanism, ontology systems. Airlines to the flights, flights to the gates, and so on to the terminals. How it has been get connected. But how we are going to build this ontology? So briefly, I have written some statements here. What are the activities we are going to do? First of all, we need, if you are working on a fabric related, we need a proper trial license. If you are moving with the trial related accounts, trial license is required, fabric trial, which is valid for 60 days. So with fabric, you can create a workspace, a dedicated workspace, and create a simple workspace name there, fabric related content. And as I said, we are going to fetch few of the CSV files, file source systems, like as I mentioned, airlines. And I will showcase to the data how it looks like, simple data set. Terminals, which terminal it is, T1, T2, and even I have taken the reference of Hyderabad related terminals to gates. Which gate? Once you enter into the airport, check-in has been completed. We have to move on to the particular gate, like G8, gate number 7, gate number 8, and so on. Which gate? So that the flight will be get arrival or else departure from that particular gate. So how it will be get connected, the gate to the flight and flight to the flight sensor. And these tables, the raw tables, we will get converted to the proper conversion, delta table mechanism, like a proper, easily identifiable tabular form. After that, as I said, after extracting those 5 tables and converted those 5 tables to the standard tables in the lakehouse, I'm going to fetch over another live streaming source system, sensor data. I will inject the data set from our event house, get data with some file source system. We have many options there. Tomorrow we are going to discuss about RT as well. We will extract one of the sensor data. I'm not going to fire any queries there, KQL queries. On that particular static table, how it will be get referenced to the connected tables that are already available on your lakehouse. That is the third step. And as I said, we will try to build a model with the 5 tables. The first table which we have, we are going to extract it. Like as I said, the 5 table names also have provided there. We will try to bring one side to the many side, okay, based on the common columns, and we'll give it as a cross filter direction and so on. And the next activity, that particular, once you define the model, there is an option on the, while defining the model, we have an option or tab name called generate ontology to find out the table information, the relationship, how it has been get connected from one to another and so on. So here the concept, automatically we are aware one table to the another table automatically will get connected. Yes, it's true. Sometimes we are not sure whether that is the right column it is, other than the automatically, whether it is right or wrong, we are not sure about it. In such kind of a mechanism, we can overcome via ontology. And even sometimes, manually, we can change the connection from one table to the another entity and provide the relationships as well. And finally, as I said, configuring the sync with sensor data to the connected 5-table semantic model. How we are going to bring it over, that part we are going to discuss, while how we are configuring or syncing with our existing semantic model. Sensor data to 5 tables. Okay. This is simple example. So how I'm going to bring the static, the flight ID key to the sensor ID. Just to give a simple glimpses here. What are the identical columns from flight ID if you're working on the flight related data, gate related, or some starting date, which date, time it is, and so on. We can easily find it over. And coming to the table, the sensor table, which we are going to extract via live streaming source system, sensor ID or flight ID. Timestamp is must and should, and which, we have to find out which time it is going to refer, like a time series wise, real-time data, right? We need to identify when it has been loaded and what kind of a changes it is trying to bring it over from the sensor-related info. We'll get to know via event stream. The data will be get stored into the event house itself via KQL databases. How this particular table will be get link or as a data binding with the existing model, that part we are going to showcase to you and then completely demo part. The data will be get stored into the event house itself via KQL databases. Very important glimpses here, which you are observing. The tables are very important because that is the key entities. And after that, we need to identify the right or referenced unique keys, property information. What kind of a relationship has been bring it over with existing terminals to the airport, airlines to the flight, and so on, based on some unique to the another one-to-many kind of a relationship. And remaining all we are going to discuss on while creating the data binding on time series optimizations of the matching mechanism. These are the things which we just now discussed. The types of models, how it has been getting interlinked with one table to the another table as an aviation industry part, the linking between the one level to the another level, we are going to discuss thoroughly. What it will bring us, maybe if you are working on this ontology concepts or else maybe already working on the Microsoft Fabric, if you start utilizing this ontology, automatically there is no manual interaction should be there. We can see the generation of this, connections or else relationship between one table to the another table. And maybe if you are trying to bring it over the real streaming source system to the existing semantic model, how we can try to bring it hold and give the reference key information to the connected semantic models. And as I said, if you are making use of this ontology mechanism, Microsoft Fabric or trial capacities are required, which has been covered, and making use of one lake foundation level. And even there is a data agent also incorporated at each and every level of, even from the lake house, you can see data agents are there to see the complete, you can write the queries, natural queries, and the output will be stored in the form of SQL, and also you can see the outputs. It has been incorporated even in the ontologies part as well. But as I mentioned here, it is still a general preview. You can maybe when you are working on it, on concepts, you can see that particular mechanism too. So this is one of the examples which you are observing, Fabric IQ, how it has been integrated on this ontology. You can use ontology concepts part, the existing semantic models or lake houses. You can just have to get it configured. Like whenever you are selecting some tables, right? It has been already integrated with your data agents. You can connect to the right data sources After connecting to the sources, right data sources, you can bring it over what are the tables that you are trying to see some analysis, and as well as how this particular connected tables or else entities are giving the value added to your business. What kind of a vocabulary has been defined. And you can see that some of the sample queries has been defined. Maybe if you want to try your own queries also, just like how we are using the Q&A mechanism in Power BI, likewise you can also define and try the queries too. The output should be, if you're observing in the center ontology part, how this product has been linked with one table to the another, like a shipment to the product, product to the orders, product to the forecast, and so on. But in our activity, which is that aviation related concept, we have at that particular theme I have picked up, we are going to discuss detail. On the right hand side, if you are observing entity type configuration, dynamically one table to the another table, the key columns like a product ID, if it is a product table, product ID to the another table, the table has to be get it linked. Sometimes if it is not, the key is not identified, we can also change it manually. We can give the proper connection to the another table. And the in between, if you're observing data binding or else a sync up with another table, which I'm going to showcase during the event house related extraction, how we are going to sync up with the streaming, that is a sensor data to the flight related information. That part we are going to discuss in detail. The final goal should be if you're observing how this particular product table has been linked up and what kind of a entities has been get connected or else a relationship, we can easily track and find out this data vocabulary. How we are going to sync up with the streaming, that is a sensor data to the flight related information. That part we are going to discuss in detail. Fine. The final goal should be if this last question is a kind of a simple quiz. I will take you at the last. Okay, just take a snapshot as well. Important. And let's move on to the demo part. I'm changing my screen now. Can you able to see my screen? This last question. I'm just changing my screen to Power BI workspace. Okay. Everyone aware of this? This is the Power BI workspace. And currently I'm using the trial capacity, fabric trial. Let me showcase to you. From here also you can change the fabric and create a new workspace, or from Power BI, you can get started with creating some new workspace and so on. Let me create a simple, from end-to-end activities part, a workspace, okay. Giving a name of global, something like this. I'm not using Power BI Pro, using the trial capacity, fabric trial. We know this is how the workspace will be get created, right? Then what I will do, and before getting extract the data and so on, I will also showcase to you how the data looks like. Okay, so these are the tables: airlines, flights, flight sensor, gates, and so on. These tables are already there, as I said, in my GitHub. This link also will provide it to you. Sample data is available. You can make use of it. So if you're observing, I'm going to fetch it over 5 of the tables, 5 tables via Lakehouse, and convert the tables to the delta load tables. And then on the top of the 5 tables, I'm going to create a semantic model. Like example, terminal table. Few tables I'm going to showcase to you, and then we will move on to the next. I have taken some records like this: terminal ID, terminal name, airlines, code, type, and count. So I have added 2 terminals, T1 and one for domestic, another is for the international, which is in Hyderabad, other locations as well. Okay, this is the first table. The hierarchy should be flowing this way. Terminal to the, we will first, if you look at flight, we will first go to the terminal, and from there we will check inside, and we will go to the airlines. Which airlines it is? Is that an Indigo? If it is an Indigo or some another flights and so on, we will navigate like this, right? Another table. Okay, another 5 airlines. Next hierarchy from terminals to the airlines. Example, I have picked up few data. If you're observing, these are the few number of simple data set. You can see airlines ID, name, IATA code, international code, country, hub, and fleet. You can see I have added from India one of the flight. Okay, next up, hierarchy should be from terminal to the flight. Which flight it is? It's a sunrise air, or maybe some another Pacific zone air, and so on. I have added airlines table. Like that, another hierarchy. After finding out the airlines, which flight it is, we will move on to the gates. Which gate is that, like G1, G2, G3, which gate it is, voting gate, voting pass from it. For this, I have added some record. You can see with this approximately 20 to 30 records I have added. Gate ID, gate number, we will go to the particular gate, terminal ID, which has been getting linked with another table, gate type, voting capacity, and so on. This is not required as of now, but we've just try to focus on in general mechanism, gate number and gate ID. So how it has been get connected with another table is very important for us. That is airplanes. Okay. Let me close it. One more table we will discuss and we will walk you through this. Next one is 3 tables we discussed. Flights. Which flight? For this as well, I have added some flight details, approximately 17 to 15 to 20 records. You can see some flight ID, flight numbers. And I have added where from where to where and what is the status, okay, boarding status and so on. Okay, is that a delayed, on time, or maybe is there any lag, or else boarding has been already done, or last call. These details have been added in this flight information. So this flight, how it has been get connected to the airlines, that is, I mean, gate related, that matters for us. How it has been get connected to the flight ID or else current information to this previous tables, which we just discussed. And this particular sensor read, I'm going to extract it via, I'm going to pull it over the sensor data via binding source. That is an event housewise. I will store it from there. I'm going to link up this particular sensor data to the existing, the previous other tables, like airlines, flights, terminal, gates, and so on. Sensor is also there. You can see this table also I'm going to fetch it over via one of the dataset, CSV dataset, telemetric information, where I'm going to give a connection to the sensor reading. Okay, so simple data. As I said, these datasets are already available in my GitHub. You can also play with this. Fine, we are aware of the tables, table details, and so on. Let's try to create a lake house. Via lake house, we will fetch it over some of the tables, as I said, 5 tables, other than sensor reader. And we will convert those tables to the tabular model via delta nodes, delta table information. And from there, we will bring it over semantic model. We will give some connections as well, relationship between one to another. And we will see further activities. Let's try to first create lake house now. So we know how to get connected to the lake house. I have created a workspace as a fabric content, new item. And from there, we will bring it over semantic. These are all different workloads. From morning, you have come across multiple workloads as well as a part of learning. These are all the workloads. And you're already aware how to create the lake house now as well. So you can search it over here, lake house, or else you can find via just scroll down and get data information wise, you can find out the lake house too. Let's try to fetch like this lake house. So it will be get stored the structured, unstructured, so any kind of a source systems. So I'm going to give the name of this. So you can search it over here, lake house, or else you can find via just scroll down and get data information wise, you can find out. And the schema will be created by default. It is a debugger schema, database object schema, and this is our location. Okay, it's getting stored. This is our workspace location created. And if you have any queries or something, just post it in the chat. I'm happy to help you. In between, it will take some time because I'm using the trial capacity. Okay, and also my network is a little bit slow. If it is taking more time, what I will do in the sense, I already done the exercise earlier. I will also showcase if it is time consumption means I will just go through the worked one as well. Okay, to showcase to you how it is and so on. Whenever you're creating the lake house, we are already aware 2 things on the left hand side Explorer, 2 folders. One is tabular, it's a table folder. Okay, managed sources. Files is an unmanaged files, like semi-structured, unstructured. We can fetch it over from here, folders. And if it is a tables folder means you can see the completely structured information with the proper rows and columns. And maybe if you're extracting some kind of an external sources like Google Cloud related sources or ADLS2 and so on, you can try to fetch it over. If it is your data source is an unstructured, you can use shortcut approach as well. And even we can also create some folders too for our better understanding, which from where these tables are coming up. We can also create some subfolders too. What I will do in the sense, as I said, 5 tables excluding the sensor read, 5 tables, terminals, gates, flight and airlines, flight sensor. I'm going to extract it via files. Okay, all the CSV files, upload it. What I will do in the sense, as I said, 5 tables excluding the sensor read, 5 tables, terminals, gates, except the sensor read, airlines, flight sensor. I'm going to extract it via files. Okay, all the CSV files. Very fast because it's a simple data set. Okay. You can see our tables too. So from here, you can use a different mechanism, like you can use a data flow. Gen2 wise, you can load it this particular CSVs to the tables, or maybe you can also make use of data pipelines to convert these flat files to the table conversion. Okay, it's up to you, wherever you feel comfortable to convert this raw data to the main, okay, structured data. You can use your methodology. But as of now, the simplest approach is also there. These 5 CSV files, I'm going to get convert via simply load tables, load more. These are new tables now, so I'm going to load it as a new airlines. If you want to change the naming conventions, you can change it, okay, if required, or maybe just load it as it is. And it will not accept the space or hyphen separators. Make sure that you can use as is, okay. Comma separator, delimiter it is. So I'm going to load it as a new airline. You can also refresh here. Whenever you're creating the lakehouse, automatically on the right hand side lakehouse and as well as analytics endpoint will be get created. Maybe if you want to do some customized, optimized tuning on this SQL part, or maybe if you want to do some visual level data transformations, we can perform it by changing from lakehouse to the SQL analytics endpoint. So it's still running. So see here, you can change it from here, from one layer to the another. This is currently we are at lakehouse. So first table has been get loaded. This is our table by records. Let's try to fetch it over a few more tables too, like flights. As per the hierarchy, if you can see, first one is going to be the terminal, next is the airlines. Let me load the terminal too, new table. This is currently we are at lakehouse. So first the hierarchy follows. Okay, I'm just following the hierarchy, like a terminal to the airlines, airlines to the gate, gate to the flight, and flight to the flight sensor. This is how the hierarchy. You can just try to refresh here. And we know here, from here, we can create earlier, we can see automatically we can create the semantic models too. But the name has been changed to the new semantic model, and we have to select the tables, and we can also prepare the data modeling activities from here. Okay, 2 tables. Let's try to load a few more terminals to the gate. Airlines is already loaded. But the name has been changed to the new semantic model, and we have to gate to the flights. And we can also still it will take some time, as I said. Okay, 2 tables. Let's try to load a few more terminals to the gate. So main thing is creating an ontology means you are defining the business entity types. It's very important how the relationships has been exist between one table to the another table. How the data is bound between the actual data source to the conceptual model of your connections. Okay, each and every relationship. Okay, another table, flights. Relationships has been exist between one table to the another table. How the data is bound keep in mind between the actual data source to the conceptual model of your connections. Okay, each and every relationship. Okay. Another table, flights. So from here, right, once the tables are available in the DBO schema, we will create a semantic model. Okay, a new semantic model from the DBO schema. I will fetch it over all 5 tables. Okay, 5 tables, even the flight sensor as well. So from here, right, once the tables are available in the DBO schema, we will create a semantic model, okay? A new semantic model from the DBO schema. I will fetch it over. Any questions up to this part? Okay. Do you have any questions? 5 tables are available on a DBO schema here. See this? What I will do in the sense, directly, instead of creating a semantic model and work on the relationship, the another table is there, sensor data. I'm going to extract the sensor table via event house, okay? So we have 2 approaches. If you want to extract the real-time data, we can inject the data via event stream, and we can load it into the event house via KQL database, and we can query on the top of it. And another way is you can also create the event house, and from there you can connect the data and store that information in event house in the form of a KQL. I mean, you can on the top of you can write the KQL queries and KQL design as well. We can do that. What I will do, these 5 tables are already available in the DBO schema. And the real-time data, the sensor data, which is in the form of a CSV, I'm going to fetch it over the particular information via event house. Navigating back to my workspace, new editor, giving something like this, name of the event house. Navigating back to my workspace. Okay. Naming standards also, whenever if you're working, make sure that you're giving right naming standards. So event house, because it's a streaming information, I just want to create it in an event house. Left hand side, if you're observing, this is the KQ empty one. Nothing is there. Once you can click on this database, it's going to be an empty. No tables are available. So from here, I'm going to fetch it over that particular data. Okay, let's try to extract it from this get data, or from the center also you can extract it. I'm not discussing each and every details on this particular layer. It's going to be the time consumption. Tomorrow anyway, I have an RTI concepts to be discussed, event house and event stream. We will discuss at that time tomorrow. Get data, I'm going to fetch it over this data from here. Get data, local file, giving some name to the new table. I'm giving like sensor, airlines sensor data. Okay. Get data, I'm going to fetch it over this data from here. Get data, local file. You can see your information here as well, because it will take some time to get reflected on your connectivity while bringing this ontology. So that's the reason I'm extracting right away this real time, the event house wise. And after that, while building the data model, while giving the connection to this sensor reading data to our existing lakehouse table, at the time it's going to be visible. Okay, that's the reason it will take some time to get it reflecting this information. I'm extracting right away. It's up to you. Maybe you can build a semantic model first. After that, you can fetch it over and extract this real-time data. Okay, it's as per the work concept wise. Okay, left hand side you can also see what are the steps and how much has been finished, or else which layer we are. I'm extracting right away. It's up to you. Maybe you can build a semantic model first. After that, you can fetch it over and extract this real-time data. Okay, it's as per the work concept wise. Okay, left hand side you can also see what are the steps and how much has been finished, or else which layer we are. Here, sometimes this happen. 1 second. Sometimes this happen. 1 second. Okay. Sometimes, okay, it takes some time. Doing this. You can see the step by step. So how we get connected this sensor, and what are the ways to get it configured. And also we just observe the data with some records, right? After that, we are loading this sensor reading data to the event house, right? Successfully injected, close it. So from here also you can explore the result, the trends, And on the top of it, you can also apply some data transformations like filter. You can manage the columns, whatever that are available. Okay, you can also showcase some trends. And you can also create the real-time dashboards too. Okay, I'm not discussing this part. We just loaded one of the sensor information via Event House. Successfully loaded. You can see that information. EL data that is the name I have provided. In the center, you can observe the data tracking part, the number of records. So what I will do in the sense, this particular data which we just loaded, I will keep it as it is, static table, this particular information. And let's try to build our semantic model via Lakehouse. We know how to do that activity from here, right? We have an option name called new semantic model. Let's try to refresh. All 5 tables, we will try to build the connection between one to another. We just discussed what is the link between one table to the another table and how the hierarchy should be followed from terminal to the airlines, airlines to the flight, terminal to the airlines, airlines to the gates, gates to the flight, and flight to the flight sensor, right? Give some name to this. Airlines to the flight, terminal to the airlines, airlines to the gates, gates to the flight, and flight to the flight. It's not appearing. Right. Give some name to this. Any questions up to this part in the chat? So as I said, from here also you can bring and derive some queries, okay, SQL queries. Okay, you can write based on the, I want to see very detailed analysis on fact or dimension related information. Such kind of a scenario, you can also build the data agents too from here. Okay, new data agents or else maybe existing data agents too. You can combine it. Let me create. Any questions in the chat as of now? Very detailed analysis on fact or dimension related information. Such kind of a scenario, you can also build.
Yes, sir. We have one question.
Okay. Maybe existing data agents too. You can combine it.
Shall I read it out?
Sorry?
Shall I read it out, sir?
Yes, yes, please.
Yeah. So Nagaraju is asking, can't we load files simultaneously to the tables? We have one question.
Currently, yes, from here, yes, that's what the mechanism. You can directly use the data flow gen 2 and you can extract and we can create it in the tables itself. Or maybe the general processes we will follow from files and from here to the load. That is as per your wish. You can directly use the data flow gen 2. You can load it to the tables too directly. Yeah. Yes, that's what the mechanism. You can directly use the data flow gen 2 and you can extract and we can create. Is that clear? Or maybe the general processes we will follow from. 1 second. Still, it is not reflected. Give me some time. That is as per your wish. You can directly use the data flow gen 2. You can load it to the tables too directly. Yeah. It should be appear here. That's what the thing. I'm just looking over. Is that clear? 1 second. Still, it is not reflected. Give me some time. It should be appear here. That's what the thing. I'm just looking over. Why this much delay? Maybe that is the questions if you are asking. Because of I'm using trial release and also the network speed is slow. That's the reason it is not reflecting immediately on this building the semantic model. Okay. Otherwise, it will definitely comes up. Why this much delay? Maybe that is the questions if you are asking. Because of I'm using trial release and also the network speed is slow. That's the reason it is not reflecting immediately on this building the semantic model. Okay. Otherwise, it will definitely comes up. Okay, in the meantime, what I will do in the sense, I will make it ready that event house data as well. Just give me a minute. This is the data, right? Few things I just want to showcase to you. In the meantime, the backend, the data load should be visible onto the one lake and preparing the semantic model. What I will do in this is I'll just try to give you some glimpses on this from this event house, how we can write the queries or on this particular real sensor date table, how can write the queries and so on. I'll just try to showcase to via query set. Okay. So here we can prepare some queries. Okay. There is some specific commands on the KQL database, Kusto query language. Maybe if you want to see the top 100 records, or maybe if you want to count it, you just try to write your table information and then see the number of records based on the timestamp. And still, if you want to see some more KQL references like queries, the commands, you can make use of this KQL guide as well, which is very important. I will also regularly follow, and I'm not very familiar with the KQL stuff, so I'll just try to make use of from here. I will take the commands, whether it is a distinct or searching for some keywords, I can make use of this. You can see here how we are going to write and so on. We can use Cloudy, or maybe you can just try to copy paste and just modify table information. It works. So I'll just try to make use of from here. I'll just try to showcase to one example, AL sensor D. Before those tables get appear, this is how the data looks like on your sensor information, like a read ID, sensor ID, and when the data timestamp, latitude and longitude, engine configuration, cabin pressure, and so on. This information that is available. Let's try to move back to the event lake house to the event house to the lake house. Let's try to see. Yes, see here. These are all 5 tables. It took some time because as I'm using, as I said, trial license, let's give some name to this tables. Okay. Flight SH, SM. 5 tables I'm going to give it. Airlines, flight sensor, confirm. What I will do in the sense, if you are trying to prepare a semantic model on the top of this, we know what are the identical, similar columns. So these activity, giving the relationship or connection between one table to the one flight, airlines to the terminals, and airlines to the flights, and so on, we have to identify the common column between one to another. That is the key columns there, which is how the automatically it will get derived. We are aware of it if it is in a Power BI desktop. But if you are defining these activities on cloud environment, it will take some time. Manually, we have to give the relationship and have to configure one to another tables. Basically, it looks in this way. It's not an automated or automatically it will not bring the connections. We have to manually give the connections from one to another. Let's try to quickly give the connections from one to another. As I said, the hierarchy should be from terminals. First, we will go to the particular terminals to the airlines, and from airlines to the gate to the flights. So we have to identify the terminal ID to this. Let's try to quickly give the connections from one to another. As I said, the hierarchy should be from terminal. Go to the particular terminals to the airlines. Airlines ID is also the right airline ID to the airline. So we will give the terminal to another. Okay. Very important when you are working in the cloud environment, giving the connections, the new relationship building, data will not get as a preview, just like in the Power BI desktop model, data modeling part. It looks in this way, airline ID to the airline ID. And if there is any terminal to the terminal, we can definitely give the connections as well. And make sure that, make this as an active relationship. Assume referential integrity, which is very, very important. We have to enable this functionality for the seamless or else for quicker execution. Suppose if there is any mismatch or else maybe if there is any blank information, this referential integrity will not work out. Okay, make sure that this is enabled for the quicker or else faster performance prospect as well when we are working on the bigger data modeling part. If there is any duplicates or the column names are little bit different, we can almost automatically it will be get disabled when you are giving the connections. And even the visualization level, we can see the incorrect values too. That's what I have observed personally. If without enabling this referential integrity, with enabling this referential integrity. As of now, I'm enabling it. This unique information as well. And from airlines to the boat gates, let's try to give the connection here. Without enabling this referential integrity, with enabling gates. As of now, I'm enabling it. This unique information as well. And from airlines to the boat gates, manually we have to give the connection here. Gates. Manually we have to, or here it is. This complete flow, the entity connection, as of now I'm giving it. Whenever you're trying to generate this ontology on the top of this connections or model, we can easily find out and track how it has been linked up with one to another. Okay. As of now, let me give 2 tables are left. Let's try to just to flow, the entity gate ID to current gate number for flight. Generate this ontology on the top of this connections or model, we can easily find out and track how it has been linked up with and flight sensor data to the flights. Flight ID based. 2 tables are left. Fine. This model we are aware how we are going to build the connections. So whenever, if you are not clear how this entity has been related to the another table entity in such kind of a scenario, to find out this vocabulary between, business relationship between one to another, this here, if you're observing at the top while defining the model, generate ontology. You can see the relationship and you can see completely how the decision, because as of now I have given the connection, but whether it is a fine or not, the relationships, the entity part, we can get it defined from here. Generate ontology. I'm just selecting that, giving the name as like flight. Because as of now I have given the connection, but whether it is a fine or not, the relationships, the entity part. You can see, unify the model, simply expressing this relationship or else how the connections between one to another, and track if there is any static or else if you want to sync up any another data from lakehouse or even from another sources systems, external source systems, we can make utilize of this concept. And just like how we are observing the lakehouse, the explorer, here also similar way. On the left hand side, on the explorer part, entity types, those are the current table information, airlines, flights, terminals, gates and flight sensor. And whenever if you are selecting the airlines, example, one table I'm selecting, how it has been linked up with this airlines with one table to the another. These concepts has been getting very clear here. And whether this workspace or this table has been get connected and which workspace and what is the schema and from which table to the which table, another table, we can easily track and find out from these details. And maybe sometimes, right, if you want to change the connection or else entity keys, we can also change it by, we have an edit option, we can also change it from here by selecting this in the center part. Okay, let me showcase to some another connections too. Flights and flight sensor and gates, and this is how the relationship of properties has been get connected. And maybe this particular relationship is referencing any another Power BI report. We can also generate the resources links too. So we can configure with some different reports. We can configure it from here too. Reporting mode. Okay, from here. This model has been getting reflected to some another existing reports, means we can configure. Okay, and the main important thing we have to observe from the right hand side, entity type configuration, which table to the which table, automatically it will get detected. If not, if it is not detecting, we have to also give the relationship manually. As of now, it is terminal ID is the key column between gates to the airlines in center terminal. And from gates, it's loading. So see here, it is not getting detected. Add entity key, right? We have to manually define it. Maybe see here, gates, gate ID is the key column. Manually also we can get it defined, the relationships. We can just have to edit and provide the sequence. Okay, fine. As I said, how I'm going to bring the sensor data to this relationship to the flight sensor. Flight sensor are given the connections to the flight, but flight sensor have in one more hierarchy, which is already existed on the lake event house. And that particular table sensor reading data to the flight sensor. How I'm going to give a data binding, data sync between flight sensor to the sensor reader. I'm going to showcase to you by a binding concept. Binding is simple terminology binding is, do you want to sync up with any another existing model or else any other data source connection? In such kind of a scenario, you can use this binding. And as I already mentioned, resource link is for referencing this particular semantic model to some existing other reports. In such kind of a scenario, you can add resources links. Okay, so if you can click here, other reports, you can try to sync it up this model too. Okay, that's what the meaning. Let me bind it, this flight sensor data, add data entity type. See here, event house, sensor, this is the name I have provided. Okay, so if you can click here, it will take some time based on the timestamp. Okay, I'm going to bind it over. 2 steps, configure the source, configure the data binding based on which column you want to configure. Key column. Sensor ID column is there. So based on the sensor ID to the sensor ID column from sensor table, I'm going to give the relationship. It will take some time. It's trying to identify the table. Wait for some time. Yesterday also I faced the similar error. So as I said, trial license, it will take some time. Let me close it and do the sync. Sensor ID to the sensor ID column from sensor table, I'm going to give the relationship. It will take some time. It's trying to identify the table. Few minutes, I will not take much time, almost completed. I will showcase to the output how it looks like. Okay, can you give me a few minutes? Is that okay? Do you want me to ramp up?
Yeah, sure, sir. No problem.
Few minutes only. I will not take much time. Few.
Yeah.
We'll try one more time. Otherwise, I will showcase existing model also. Okay, give me one more time. Can you give me a few minutes? Is that okay? It's loading. This is where it will, because ontology part still under preview, general preview session, it's a preview feature. It will take some time. Okay, because I am currently using the trial. If you are using the proper license like F2 to F4 or F64, you will definitely get it. So see here, no, there is no error. This is the sensor reading data, which I have fetched over event house, and I'm going to give the connection to the sensor reading to the flight sensor data. Next activity is only the configure data binding. Let's see that. Based on timestamp, we have the timestamp field there as a showcase to you. Sensor to the sensor ID, give the connection. That's it. It will be get linked properly from flight sensor to the sensor reading data, live data. Okay, and maybe if you want to change the naming, or maybe if you want to delete the existing columns, we can get it deleted too. So if you can select here, you can see sensor reading as well. So it is missing. Let me refresh. It's not missing. Just now we completed. It's done almost. Let me showcase to you how the relationship, entity relationship overview will be getting existed here. Okay, while defining this model. So if you can select here, you can see sensor reading as well. Yes, Amit. Few minutes only.
Yeah. So do you need more time?
2 minutes only. I will not take first.
Okay, fine. Yeah. Sunil, and welcome, Sunil. We are just wrapping up.
I'm wrapping up. Sorry. See here, this is how the model and where the relationship has been get connected as a showcase to from airlines to flight, and very in detail functionality you can observe via from this feature. It's loading. Okay. From table to the table, this is how the entity relationship. Even we can try to manage the rules, and we can define the proper controlling on the top of each and every table for the business vocabulary functionality. I mean, connected tables wise. Okay, and this is what I just want to showcase to you. Why this is blank in the sense, as I said, if you want to configure this particular analysis with the existing reports, we can configure via configure link, and we can define resources link to for the existing reports and so on. As of now, I haven't configured anything, so that's the reason it is showcasing some blank. Otherwise, each and every column, how it has been linked up with one to another. You can see how many times has been repeated, or what is the locations wise, or you can see the complete analysis. And I'm done here. This is the last query. Okay, just expecting an answers from you people. Your team is tasked with integrating external data source into Microsoft Fabric using the Fabric data agent. Just now I have showcased to you the data agent concepts to each and every workloads part and each and every functionality level. We have the data agent feature. Arrange the following steps in a proper sequence order. What we will do first. Context we are going to add, select the data source, relevant tables, publish it to the Fabric data agents, and find out write the queries and try to define some meaningful analysis. What is the approach? ABCD. important, just maybe if you're interested, just post it in the chat. And if you have any queries or something, happy to answer. Hope you like it.
Thank you, sir. Thank you, Rajendra, sir. It's a wonderful session. We understood the basics of ontology.
Thank you. Yeah. Thank you so much. Thank you. Thank you so much, Amit, for giving this opportunity. Thank you. We'll meet you tomorrow. Happy learning.
Thanks, Rajendra. Thanks for a wonderful session.
Thank you.
Thank you, sir. Thank you, Rajendra, sir. It's a wonderful session. Guys, if you have any questions regarding Rajendra, sir, session, you can just post them so that he can reply you back.
Thank you so much, Amit, for giving this opportunity. Thank you. We'll meet you tomorrow. Happy learning. Yep. Thank you so much. Have a nice day. Yep.
Thank you, sir.
Yeah. Thank you.
If you have any questions regarding Rajendra, sir, yeah, guys, you can just post them. So we have our next session. It's yet to start. We have Sunil Sabat, sir, available in the call. Hello, sir. Good evening.
Yep. Thank you so much. Have a nice day. Yep.
Thank you all from California. It's 7 o'clock. Okay. Yeah. 7:05.
Yeah. Yeah. Then good morning, sir. It's a warm welcome to you.
Yeah, I know. See, IPL is starting the game. I hope everybody sticks in the in the session. Yeah.
Yeah, sir. The IPL paper is on.
From California, it's 7 o'clock. Yeah.
Yeah, sir. So before we dig into the session, sir, I just want to update a small thing. So, guys, as you already know, we have some few challenges and rewards in the community. So we have social media challenge, DP 700 and 600 voucher challenge, max sessions attended challenge, best questions asked challenge. So to once you participate in these particular challenges, the rewards which include are DP 600 700 certification vouchers, Amazon gift vouchers, communication recognition special awards. So for the social media challenge, share your I am attending post on LinkedIn, X or Instagram and tag the India Microsoft Fabric group and Hyderabad Data and AI community. Yeah. So before we move on to session, I please welcome Sunil Sabat, sir, Principal Program Manager at Microsoft Azure Data. With over 3 decades of experience spanning Intel, IBM, Informatica, and Protectity, Sunil has built a career at the intersection of cloud, data, and enterprise innovation. He is certified expert across Microsoft Azure, AWS, Google Cloud, and Salesforce, and holds advanced degrees in computer engineering, computer science, and an MBA from Santa Clara University. A frequent speaker at global conferences and a contributor to open source communities, Sunil is known for his customer-first approach and passion for emerging technologies. Today, he brings us insights on the future of analytics and cloud innovation. Let's give a warm round of applause for Sunil Sabat, sir. Sir, please take over, sir.
Thank you, the organizers for the 4th conference. I have been speaking here. This is really a privilege to speak. I usually speak at the other conferences also, but being held in India and spread out to the globe, right? This is really very good. Thank you for doing it. Okay. So as you know, for the session, right, I want to cover about high-speed ingestion, right, for actually Fabric. Right, I'll discuss about all the patterns, but because I'm the PM and I belong to the Data Factory group inside Fabric, right? Old Azure Data Factory. I come from there, and so my talk will be mostly based around Data Factory, but it covers every aspect of Fabric. Okay, so let's start. Okay, I'll present my presentation. I hope everybody can see. And I belong to the Data Factory group inside Fabric, right? Old Azure Data Factory. I come from there, and so my talk will be mostly based on Data Factory, but it covers every aspect. Everybody can see my presentation. I'll present my presentation. I hope everybody can.
Yes, sir. We can see your screen.
Oh, okay. So I hope you all like the first slide, right? It's about high-speed data ingestion for near real-time analytics, right? See, I will talk about real-time analytics with the RTI piece, right? But if you do real-time analytics, with the transformations and other functions that RTI has recently provided, right? You can do real-time, but he's more of a near real-time, but we will cover that as well. Okay, and as I said in the beginning, I have a data factory centric approach, because that's that's a very easy way, to accomplish your goals. Let's start. Right, you can do real time, but he's more of a near real time, but we will cover that as well. Okay, and as I said So what are our goals for this session, right? As you know, right, we're living in a world, right? It's full of data, right? We have structured, unstructured, semi-structured data, right? And with the rise of mobile computing, AI computing, right, data has become a big asset and data is everywhere. Okay, so what is the current need across all the vertical industries that we all serve, right? Ingest fast, analyze fast, and decide fast. That is simple, right? You can tell to a high school kid, okay, anybody, right? Hey, I want to get data fast, right, and analyze it fast and decide it fast. This applies to Meta, it applies to Uber, and it applies to every Fabric customer also, okay? And it's not that the batch ETL and the batch decision make doesn't go away, because without historical context, right, we human beings cannot make good decisions. So we need that historical data, batch loading, we need that. But, to make up-to-date decisions, for both AI and BI, we need fast ingestion, okay? And then correlation and connection with the existing data, right, and make much better and better decisions, right? So who is our audience, for this session, right? Data analytics leaders, architects, BI and the data engineering teams. I'm sure, this audience has all of them, okay? So what do we want in the end, right? The outcome we want is choose the right Fabric ingestion path for near real-time insights, right? Which is applicable to both AI and BI. Just before this, Mr. Rajendra was speaking about, semantic and, the agents, right? And IQ, right? If you look at last 6 months to 9 months, the Fabric announcements, right? We've doubled down, on this analytics piece, and we've infused now AI on BI, kind of, right? Your Power BI is agents, but we have our own IQ led, right? Agents, data agents, operational agents. But in the end, if you look at this Power BI agent, right, it just looks at the semantic models, right? The relationships make decisions. Now with our IQ agent, data agents, operational agents, again, it goes back to the data and, fits the data and lives on the data and gives the prompts and gives you the answers, okay? So what is the core of the problem, we see, right? Operational data changes continuously. Analytics often sees it hours later. If you just go back, a few years or 1 or 2 years back, right? Most of the operational data coming to a big decision, right? Whether it's a business decision or operational decision or whatever, right? It's always hours later, right? Because there is a trust issue, there's a governance issue, there is an authentication issue, right? All that, right? So, and see, we cannot exclude those issues, but we have, with these new requirements, right? How can we embrace them, but still able to, do, quicker decisions, okay? Okay, hold on. Okay, so what is happening is, if you ingest slowly, okay, what happens? Your dashboards, right? Whether it's a direct query dashboard or you do a traditional Power BI dashboard, they show stale data, right? And that leads to delayed actions, okay? And then AI ML features trained on yesterday's signals reduce accuracy and impact, right? And if nowadays, right, you look at the AI implementations, right? You look at the inference, right? When you inference based on a model, right? The model would love to serve you or, from a basically near real-time data, right? Your data comes somehow and is ragged somewhere in some vector database or somewhere, right? And you feed that to your LLM and you give a pretty up-to-date inference, on the data, for your need, right? That would be the best, okay? So what is our goal now, right? Shrink, okay, the create ingest model insight from hours to minutes and seconds, right? I know we are pretty good, ingest slowly, spend some time, build this semantic model for BI or your foundational model with some trained data for your business, build it and keep serving it, right? And take some time, right? See, while that model is operational, right? It just takes more time, and then how we reduce it to, minutes and seconds, okay? But as I've been telling you for last 8 to 10 minutes, right? Everything, right? Even your near real-time insights, right? It feeds up the data, right? So data becomes your centerpiece, right? It is the central, action, place, right? So that's why, right? That's why, right? Microsoft, right? We announced Microsoft Fabric almost 3 years back now, right? So this whole idea was, right? How can we centralize this data in something called one lake, open delta format, right? And it makes it usable across workloads, right? Whether I'm near real-time BI or near real-time AI, doesn't matter, right? Or I'm in a healthcare app, right? Whatever, right? It all these requirements, are met, from this one lake data, right? And so the common foundation. So what has happened is with Fabric, as you see, right? We have a data factory, we have a lakehouse warehouse, we have a real-time intelligence and Power BI, IQ. This list is growing, right? But in all these workloads, right, which let you, build this data layer and serve this data layer, right, and make it usable. All these workloads are available, in Fabric and the feed of, from this one lake, right? Pure handoff, because all the data sits there and all these workloads have connected there and all the workloads serve from there. So what is the outcome? Outcome is you have fewer handoffs, and then there's one place, one copy of the data, right? And start from there, right? There is, so there's a traditional way of, hey, I'm doing this batch ETL, I will do batch transformation, and, I will store to, some other, faster storage serving layer, and I will, all can be done, okay? But that's a passe, given the current requirements, right? So this Fabric, right, gives you that foundation, right, to actually, achieve, our stated goals. Okay. So net result, if you compare to our goal, is less data latency, less analytics latency, which lead to faster decisions. Okay. So what happens with this fast ingestion, right? Yes, we want, so it definitely enable the rapid insight, but it increases complexity. How? Right? How? Because now with this new platform, right, we have two broad, modes, right? One is a continuous, right, replication or streaming base, and other is the scheduled batch and micro batch. Okay, so if you look at this, right, so as I told in the beginning, right, we will need this batch and scheduled data load for history, right? We just cannot make decisions, real-time decisions without knowing history. That doesn't make sense. At the same time, we need this continuous replication or streaming or mirroring of your source data into that one lake. Okay, so we need two modes of operation always active. Okay, so if you look at so now given all these modules, right, workload you have in Fabric, which workload gives you both these capabilities? Okay, to make you easily, get started. I'm not saying that you cannot start with the data engineering or data warehouse or RTI. They're all there, everything can do it, right? But the main purpose of this session is, we want to talk about, how the data factory enables you to stitch these things together. Your continuous mode and your batch mode with a single pane of tool, right? Where, you can control, you can monitor, right? You can authenticate, You can apply your tenant and workspace admins, right? Security, governance, complexity, I talked about that. Or you can achieve them, with if you start off with the data factory. Okay, because data factory, now, right, gives you mirroring and a copy job, right? Right now, mirroring is almost near real time. I'll talk more about that. It's near real time source to, one like mirror DB replication, right? Copy job is since like enhanced, age old, proven ADF copy activity, right? We just made it very easy for you to use, multi-source to multi-destination. You can say, a batch, batch load, or incremental load, right? Copy job can do it, right? And we have this our age-old pipelines, right? You can run in a scheduled manner, or now interface scheduling, very, 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 very short schedules, right? 1 minute or maybe 2 to 3 minutes, right? It's almost near real time, right? So every 2 minutes you start copying, say from Snowflake to warehouse, or Snowflake to Salesforce, or whatever multi-destination, right? You can do that, right? And the beauty is RTI, right? RTI is our Fabric Workloads Real-Time Engine, is our the KQL database, right? The Kusto database, and Data Factory and Kusto, right? Our RTI have married for a long time, right? If you use ADF, right, you have KQL activity, right? You can run the script, and and with Fabric, we have this data factory integration into RTI, right? But particularly when loading to the Kusto databases, you can invoke a pipeline, right, within RTI canvas, right, and load the data, for your almost near real-time analytics. Okay, again, you can start that. I'll show you that a little later, and also Spark streaming, right? We have a data engineering Spark, right? And hey, Spark streaming has been micro batch Spark streaming has been there for 5-10 years, right? Can you use that? Yes, you can use the Spark streaming, to stream the data, and within data factory pipeline, you can orchestrate that Spark notebook. Okay, so data factory. So the second bullet is all about, right? Data factory is the center, and how it connects to all these mechanisms. Okay, and you could orchestrate, right? Your both continuous and batch modes using a single tool. This is very powerful. Okay, and everything is visual. I know, I'm Databricks certified, I'm Snowflake certified, right? I know what other tools provide. I know them very well, right? But I think Data Factory is one of the pretty good, visually, efficient tool, and it works on the same one lake, right? And it takes same identity, right, aware, right, across all these things, right? So you don't have to jump around, right? You don't have to handoffs, right, that I talked about. Data Factory basically reduces all those frictions. Okay, keep in mind. Okay, and then what? So after data, I talked a little bit how Data Factory puts things together. The another thing is pick based on freshness target, transformation needs, and operational complexity. See, if you do just RTI, suppose don't use Data Factory, you start with RTI, right? You can do some aggregations on a small, because RTI, the event streams are very small. You cannot do a lot of complex transformations, right? But if you look at the near real time use, the AI BI use cases, you need this huge continuous load stored, right? Continuous batch, and then do a last minute ETL with some real time data. How will you do that with RTI? Right? So, just RTI might meet some need of, some factory in somewhere, right? Just RTI is okay. You just dump the data to event house and do a quick Power BI, you're done, right? But that's a very corner use case. But if you want to do the comprehensive, right? Working across all the modes, right? What do you need, right? So again, this all goes back to what your business outcome. What is the latency? What is the freshness? What is the data volume, right? And how these data streams flow, right? How you put together. And let me know, from my experience working for so many years, with the different companies, so many customers, I have worked with, right? Every customer has a different need. And 99% use case is, Data Factory led, they need something batch, they need something continuous, they need different methods, right? They need a little bit of mirroring, they need a bit of copy job, right? Or, sometimes they use just Spark streaming, right? you need to be abreast of all these things, right? So that you can you can work once you decide on your freshness target. Okay, so what happens, right? So how we are solving this this complexity issue, right? Which is our core need is ingest fast, model serve fast, and decide fast. And data factory, is your key enabler, to actually solve that kind of complexity. Okay. What happens, right? So how we are solving? So just I kind of gave a brief overview of what data factory does, right? Yeah, whatever. Let's actually start with the mirroring, right? I don't know how many of you know what I'm sure most of you know about mirroring. There was a FabCon Atlanta, that finished recently, right? And I was from the PG side, I was in the booth. Most of our questions cannot believe. Most of questions to us were, hey, Sunil, hey, what about mirroring, right? What about copy job, right? And hey, and other question, SSIS, right? I have SSIS, how I move it? Can I move SSIS to fabric? But mirroring was a top, category. Okay, so what it is, right? This is zero cost. I say low cost because because this is the storage and computer chip, zero cost until the capacity of the fabric capacity you bought, right? Say if you bought an F64, right? So up to 60 terabyte of mirroring is free for you. You never pay for a compute. Okay, after 64 terabytes of mirroring, you pay little storage money. Okay, that's why a low cost, no cost, low latency way to continue to replicate data into through one leg data. And the one leg data means you create a mirror DB which sits on delta tables. Okay, and we give you a SQL endpoint. Okay, why it matters? Fastest time to value for operational reporting without custom ETL. Okay, see another big trend of last year or two. See, I come from Informatica world. I worked on data stage. I love ETL space. I lived there for years, right? But now if you talk to any CIO or any new IT ETL, new data projects, they don't want ETL, right? They want this fresh data, right, from the source. Go to the destination, some analytics endpoint, right? Somewhere it land there in table format, right? Whether BI or your AI agents can read that. That's the first and foremost need. Okay, and mirroring lets you get that. Okay, and it's best for curated gold data for reporting or operational tables you want to analyze quickly. Okay, and what is the trade-off? Ingestion time reshaping is limited. Think replica for analytics. See, one thing, mirroring is just takes your change data from the source, okay, and constantly mirrors to a endpoint SQL endpoint driven a mirror table, right, in a warehouse, right? So you don't do any kind of transformation there, right? So you get the table and do a quick analytics, right? But in the case you want to do some transformation, hey, you can write a little Spark notebook right on that table or create a shortcut on that mirror DB table, and then you can write some transformation and do the analytics. That's optional. But this speeds you up from operational data. So say SQL or we support Oracle, right, and others, right? We'll be supporting Salesforce pretty soon, right? So you can do it quick analytics, right? And there's a URL also, and you can take a look at. But if you look at, I put a little diagram there, right? You can mirror from Azure data sources, Azure SQL, or on-prem data source, SQL server on-prem, right? And mirror it, right? And basically what happens is you have the Delta Parquet files in one lake, all the change data, insert, update, delete, those events, right? They store the Parquet, right? And you can feed, mirroring can get feeds from warehouse, lakehouse, and even Power BI and Spark, right there, right? And then what happens is, so the mirror item has a SQL endpoint which you can consume. Okay. Now the next is, right, with the data factory, we have copy jobs, right? So copy job, as I said in the beginning, right, it just enhances a copy. We don't let you, create a copy activity, define a source, define a destination, tune this, no. You just go through a wizard, right? Step 1, step 2, step 3, you give a source, give a destination, do some mappings, right? But in this new copy job features, right, we have more like like abstract features, SCD1, SCD2, right? You can create additional meta tables, right? In meta columns for auditing, all that new features that we have released 6 months, right? Last 6 months. But a copy is a copy plus plus, right? And it is also very popular. Okay. So what it does is, you just start a wizard in 5 steps, right? You do some source like Salesforce and write to some destination like Snowflake, right? You can do that, right? I don't think there is any other way, right? Yeah, hey, I can write some C# or Python code, I can do it. But look, maintenance code, getting the access, refreshing the things, right? You can do all that, right? But copy job is pretty easy tool, right? To ingest data, and what it does, if you look at this, the best for what? Files plus databases, the strength of copy, medallion ingestion, right? You want to put your silver or bronze, right? Incremental loads, CDC replication features, SCD1, SCD2 support. Okay, all that we are giving, right? What is the trade-off here? Latency depends on the schedule state, not inherently. It's again, copy job is not streaming. Okay, it's kind of based on some watermarks or something, right? It continuously copies. You can say it's like a Spark streaming. Okay, it's just another way to get fresh data, right, on your destination. Okay. It's kind of then comes our age-old proven pipeline plus copy activity, right? Orchestration. If you are coming from ADF world, right, you must have built, ADF pipelines, right, with copy activity, with some for each, so lookup and a for each, right? And within the copy, you look at some beginning time and end time, right? You can look at the metadata of the files and the copy. It's a very, very standard pattern, right? And you can do like every 2 minutes copy, right? It's pretty solid. Right, you can do terabytes of data movement batch and then do incremental 100K, 100K, 100K. It's proven, and nobody is complaining that, right? That pattern, right? We brought in from ADF, Fabric Data Factory gives you that, right? And so the key takeaway from this is, why I want to talk about is, use when ingestion is part of a multi-step workflow. Remember the second one, right? Validate, transform, notify, refer. See, when you build this master ingestion pipelines, right? Whether it's a continuous or a batch mode, doesn't matter, right? There's a lot of governance, right? You want to validate something, you want to check something, then you want to do a lookup something. You just don't want to go crazy that, okay, this is my source, this is destination. Okay, there is some need, but we've seen from customers, they want to, more control. Okay, that's where you can use it. LTI is the best for complex orchestration and metadata-driven, patterns across many data sets. Okay, and near real-time approach, micro batches, persisted incremental state, watermarks, we support all these things, right? So in some cases, this might be the solution. Okay, but Data Factory gives you that opportunity. Okay. Now that I talked about copy job, I talked about mirroring, right? I've talked about our, copy activity plus complex copy activity, with our, pipelines, right? Now come to the RTI event streams, writing to KQLDB, right? What it is, if you look at, Fabric, right? RTI is one of the workloads, just like, Data Factory or data engineering, data warehouse. It is used for low latency streaming ingestion plus transformation plus routing, right? So transformations, they've been adding little by little bit, right? And routing here is, once it comes, lands in, your actually, event house, right? You can write to, several data sources, okay? Destinations. It could be event house or it could be one lake or etc. Right? And once you write there, you can create shortcuts, right? You can do real time, capture, right, of the source stream data. Okay, why it matters? Seconds to minute insights for telemetry, click streams, logs, alerts. And see the good thing is, here you can ingest with Data Factory pipeline and data flow, from RTI canvas itself. Right. So again, because this session is about Data Factory, right? Even you might be RTI, workload user, but within RTI, right? You can actually, I do have a little example here, right? If you look at this, right? See, if you look at here, right? This is my RTI database, right? If you look at, so this is my KQL database, right? If you look at the get data, okay, you will see you have this pipeline and then the data flow, okay. So this is what I would talk about, okay. This is my RTI database, right? If you look at, so this is my KQL database, right? If you look at the get data, hello. You will see you have this pipeline and then the data flow, okay. So this is what I would talk about. I don't know. Okay, let me open it. Why it is slows down. Okay, let me open it. Sorry, it's getting a little. Why it is slows down. Give me a minute. Okay, so I just gave you a quick example of if you have a KQL DB, right? You're RTI shop, but how data factory both pipeline and data flow lets you ingest data, okay? And it's best for streaming time series analytics with KQL database and real time dashboards. It's a bonus, right? Route the same stream. Once the data lands in the KQL DB, right? You can do live, you can consume it, or one lakehouse for history plus machine learning. Okay? So in today's world with operation agents, data agents, this is a very, very useful thing. Okay, because you have to do the operational agents, your AI agent make the decisions, right? If you look at IQ, your operation agent, you basically feed this data to the operation agent. Okay, and that with the data factory pipeline, right? You have data factory, you have a KQL data sets. Okay, suppose you want to run some kind of script, on this KQL DBs, right? Before the agents work, right? Suppose your agents will have to do some work on this all the field data that has been ingested into a KQL data set, right? But before the agent work on the data, you want to run some script activity exactly at 5 p.m. California time, so that actually 6 p.m. your actually agents do the job, and then if the report is ready for your executive look at 6:30 p.m. right? You could orchestrate all that using the data factory pipeline. Okay, exactly at 5 p.m. California time, so that actually 6 p.m. So if again going back to what I did, right? I talked about mirroring, I talked about copy job, I talked about RTI, right? Which is our real-time engine, but it allows you other agents, your new agents, consume that, and then how the data factory, pipeline and data flows, can work with those KQL data sets, right? So this kind of serves, both your continuous and your real time, and real time needs all orchestrated and managed by the data factory. Okay, so this is more for architectural, right? Or you're an advanced data engineer. Some question is, what decisions you will, what the decision, for, data processing, right? What the guide, right? So coming to data ingestion and then mirroring, right? Use copy jobs to mirror raw or bronze data ingestion to ensure data is available for further processing and analysis, right? Copy job. Okay, if this might be a question in your DP 700 exam, I don't know. Okay, because exams change all the time, but it could be there. And a complete complex data orchestration, right? Implement pipelines combined with copy activities to manage complex data workflows and orchestrate various processing tasks. Okay, I gave you that example, right? And then the last slide, right, is about real-time streaming. Utilize event streams and Spark streaming with notebooks, to handle, real-time data ingestion and analytics. Okay, and so if you look at this, right, more and more, right, as I said, right, the freshness of data, near real-time aspects of the data, for both AI and BI, right, you have to use all these three things, collectively, to achieve your goal. Okay, so here, this screenshot is all about that tool I showed you, right? Between that, you create a pipeline, to ingest. Okay. So designing for freshness, latency, service level objectives, and matrices, right? So let's look at the different aspects. Okay, that's the angle we'll take. Okay, freshness target. Okay, you being an architect, right, or you're a business leader, right, or you have to decide, right, what's my freshness target? It's a second, minute, hours, right? See, if it's seconds, then definitely there is an RTI component to it, right? Hey, if it comes to minutes, you don't need to do RTI, right? You can just do a copy job, copy job can do the job, right? If it's hours, right, because definitely a batch. Right, it's a quiz question, but it helps you quickly, zero on your thinking, like where to focus. Operational awareness, right? Does your management need operational live dashboards, right? Suppose I'm doing say, delivery, right, or I'm doing a patient care, right, or my students are in the school, in the playground, right? I need to see it live dashboards, right? How you get that, right? So giving a live dashboard means there should be some kind of sensor who is sensing the data and generating this AMQ, this message queue, AMQP protocol, and it constantly feeds this data to somewhere in the cloud, to a KQL kind of database, right? You're getting live dashboards. Okay, so if there is a or like the live dashboards for every 3 to 5 minutes, right? I know KQL could be expensive, or you don't use KQL. If it's 2 to 3 minutes live dashboard, right? You can use copy job. You can use Spark streaming, right? Generate this direct query approach, right? Fabricate direct query approach, right? Once you land the data, right, and you have a direct query on the direct lake mode, right? And both are available. So direct query with this Power Query, Power BI, that is for if you want to do both historical analysis. For this live dashboard, use direct query, but you don't want to do that. You want to just do a live dashboard, on the Delta Lake table, use direct lake mode. Okay, so again, it all comes to what you mean by live dashboard, and what the latency and what is the volume. Okay, deep analytics, right? History and machine learning, right? There is new deep analytics, right? Suppose, but this is very much applicable to hospitals, right? I am to do some patient diagnosis, right? I got patient's recent sensor data, that, but I need to look at the patient's history, okay, all the reports and then everything, right? And then I want to apply some kind of AI or some machine learning, right? On top of this, to make the best options for me, right? And then I have a doctor in the loop, and I'll make the decision. Okay, so if deep analytics is a need, right, you have to again re-architect the solution, right? Where to use AI agent, and Fabric gives you all those options, right? I can have a deep analytics agent sitting there and looking for data, right, from the KQL or some Fabric one leg, and then make the decision. Okay, it can be done. So we give you the tools, right? But it's up to you to decide what's your target. Okay, and incremental state, right? And if you don't have real-time need, like you don't use event streams, right? Then incremental state is a very, very important thing to know for near real-time analytics, right? Watermarks, right? LSN for the SQL, right? Item that writes, right? Those are the markers, right? You can tag, just to go back, from actually where to start mirroring or replicating again. Okay, so as a business owner, right, you want to stick to watermarks, It depends your source table, right? If it is a column which can be identified as watermark, right? If it is SQL, hey, LSN, but you have to enable LSN, right? With the SQL Server admin, and the item writes that this is a new method, right? So once so this is kind of tag you're writing, right? It cannot be changed, right? And that is used more and more, right? When you do say continuous petabytes of data mirroring or something, you want to track in the middle, right? You want to stop it, right? You want to unmutable, immutable write points, so that you can check back, right? It's kind of checkpoints, you can do, or you can call it checkpoint also, right? That method also can be used, okay? And last but not least, this whole end-to-end measurement, source change to dashboard update, right? Something changed at source, and you have to reflect in the dashboard, right? While I was doing some mirroring POC last year, right? And one person said, hey, in our hospital system, right? This hospital's data, right? It's a SQL data, it's getting mirrored, right? And then I will need to see this, live dashboard from this hospital, right? In our Fabric warehouse, right? What is the easiest, the cheapest solution for us? Hey, Fabric mirroring is cheap, okay? It's free. And your SQL Server, right? In the hospital, you put OPDG and start mirroring, and you have a mirrored table, right? And they want to apply some transformations, okay? They want to mirror like 4 or 5 tables, and they want to do a couple of joins, right? They wrote a small Spark notebook, right, on the shortcut tables, mirror tables, and it was done. The whole solution was built in 3 to 4 hours. And they want to apply some transformations, okay? I don't think, you can say, hey, Databricks can let you do that, Snowflake can let you do that. I know, but visually building and, getting started, right? Fabric is pretty good, okay? Just keep in mind, okay? So, I talked about a direct lake, I also talked a little bit about direct query, right? But let's focus on direct lake. This is a unique innovation, with Fabric OneLake. As you know, right? OneLake is the central repository for all the data assets. We store everything in Delta Parquet, right? And, we came up with this direct lake approach, where what happens is operational data, gets replicated or copied, right? To this, OneLake, right? And, once it lands there, right, it is directly consumable by your Power BI service, okay? We have, so once it lands in Delta Lake format, we automatically create a semantic model, okay, for you, okay? And then your job, I think Mr. Rajendra has talked about it, right? We give all the tables, we have the metadata. Your job is to just combine or write a DAX query on those tables, done, okay? And direct lake gives you that direct semantic model on just ingested data. This is very powerful, okay? In fact, you combine it with the shortcut method. We have a shortcut. I'm not talking about shortcut here, but shortcut is always there, which is very fast in memory, right? It's just, you have the, you have the, all the options that humanly possible, right? In OneLake, and you can do direct lake on top of it, right? And once it is OneLake, so it's a direct lake ready, right? You can use your mirror DB, for your regular mirror DB means, the SQL on the mirror DB for analytics. You can now recently release data and operation agents, right? For any outcome you want. Okay, I was just playing with the operation agent, right? In the operation agent, I can do a business goal, and then I can give you steps. Okay, look for this threshold, and then alert me, right? It's so easy to do, right? Those agentic steps, you just write and we run it for you. Okay. And then ideal for operational reporting without burdening source systems, right? This whole direct lake and mirroring combination, that's the focus area of this chart, right? Semantic model uses direct lake for the fast BI and fresh data. I talked about it. And minimal ingestion engineering scale with governance and semantic modeling. Okay, so that is the really benefit of this direct link and this mirror DB approach. Now combine it with your agents, right? Data agents, operation agents. I think you can have the best of both BI and then AI. Near real time. Okay, yeah. One thing, right? This is more about, right? I would like twist towards, right? Coming to the today's need, right? More and more near real time. Okay, event streams ingest and transforms real time events, though it's a minimal set of transformations like sum, aggregate, in average, like that, right? And then the way it operates is you get the event stream, right? A route to a KQLDB in event house, right? And that's live dates dashboard ready. And I talked about, right? I talked about here, right? Here the second table, right? Live dashboards provide an end-to-end measurement. These are to measure things. When you go for projects, right? Do the junior data engineer, senior data engineer, or senior, doesn't matter. These two questions, second and fourth, will give you pretty much scope of the work that needs to be done. Okay, and then so that's what and they want a real time dashboards on the real time data comes from the sensors. Go for it. KQLDB gives you live dashboards, and and if you write DP 700 and all exams, right? The KQL, right? The language, the query language. You can get data you want, and you can render it, and you have your charts, right? Also, land that same data to one lakehouse for long-term history, feature engineering, ML training. See, once the data comes, right, through event stream, so within event stream, right, you can write to one lake and lakehouse. Again, you can enable further AI, and then suppose you have a machine learning model, right, foundational model, but you hello, what's it? Amit, yeah. So you can further drive the downstream use cases, right? One stream to consumption modes now and history. Okay, so KQL brings you all that, right? And see the good thing is all the KQL scripts, right? On the database script, you can orchestrate that KQL activity, right? Using data factory pipeline. Okay, so you have your live dashboard management, KQL query management facility controlled by data factory. You can batch managed by data factory. Now the mirroring and the copy job, right? That also managed by data factory. Okay. On that front, right? I'll just talk about, right? Data factory also gives you airflow and DVT activity, right? Airflow is another pattern of orchestration. You can write, suppose you don't know, you use the visual orchestration that comes with the data factory. You want to your client or you want to use airflow. We give you airflow activity. Okay, you can start with data factory. And recently, we've released the DVT activity, right? That's a very widely used data quality and data transformation, data loading pattern. It started with Snowflake. Now it's available for Fabric Warehouse, right? So you can orchestrate a DVT activity, Power BI semantic model refresh activity. You can do airflow activity, all with data factory. Okay, those are all available. Okay, just note of it, right? So what is the operational playbook for reliability and governance, right? Because data factory gives you all these utilities and things, right? How to make sure that you are doing your data operation with reliability and with reliability and with governance. Data quality gates, schema drift alerts, row count checks, live late up duplicate event handling. Okay, you need to manage this. Late arrival data handling, right? Your SCD1, SCD2 patterns, right? Data factory gives you the visual tools, and also you can write something in the Spark notebook and orchestrate that activity inside the data factory. Okay, and so you can do that. Batch pressure planning, right? Handles burst with capacity, partitions, and then batching, right? If you look at the copy engine or look at the data flow Gen 2, right, which are data factory features, right? You can use a partition, even a copy job. We are all partition aware, right? That helps you handle very large volume of data, right? How can you do partition, right? Then you can get speed, parallelism out of it. Okay, observability, right? Monitor lag, source to one leg equal, and refresh the health, right? Fabric now comes with your monitoring, right? You can monitor your KQL activity, your pipeline activity, and all that, right? Those comes those monitoring capabilities available with the Fabric. On top of that, you have a Fabric metrics app, right, to monitor how your capacity is used by each of your workloads. Okay, and we have a lot of open source project, Fumo and all, right, available, right? You can enact them just to granularly, right, check at how the capacity be consumed by data factory, or if you deliver RTI for real time streaming, you can do all that. Okay, and at the last, governance, clear ownership for SLAs, lineage, and access controls, right? So now, if you look at the Fabric innovation last 6 to 9 months, right, we're doubling down on this one leg lineage, right? One leg security, we announced it, right? We want to give you that similar granular level access control, run controls, like Database Unity Catalog does, or Snowflake Horizon does. Okay, so all that is now available, right? So this is, and there is as right, we do mirror with Databricks Unity Catalog, right? And there is a data, definitely you can share the data, right? Similarly, our doubling down on this Iceberg format, right? Iceberg catalog, we're part of the Iceberg open source team also, right? So you will see, right, if your data lands in, imagine Iceberg in Databricks, Iceberg in Snowflake, and Iceberg in Fabric, how they can all work together. Okay, you should look in that. You should look more into that in future. Okay. So you will see, right? So as you come towards the end of my session, right, I want to talk about this, like enhancing business outcomes with BI and then AI, right? So what are the 4 things you should do? Okay, implement real-time business intelligence. That's the call of the day. Develop operational dashboards that reflect up-to-date information to monitor ongoing business activities effectively. I gave you many examples also. Hospital, or you're doing patient care, hospital patient care, or you're doing your delivery, right? You're delivering the items, right? There are many such examples. Your EVs, your cars, on the road, right? You could monitor constantly with the data, right? Set up proactive operation alerts, right? With this RTI, with this activator, right? It is wonderful, right? You see, you don't go somewhere else, go event bridge in AWS, hook up to an event, and then do SQS and NS, and then do some Lambda function, then do it. Hey, I can do it. Okay, it's all possible. Okay, but Fabric makes it very easy. Where your Fabric data is there, you send the data, RTI as activator, and you put all operational aspects add on to it. Okay, configure alerts to trigger earlier interventions for issues such as fraud, outages, inventory problems, etc. Okay. Integrate fresh AI features, right? Again, we are doubling down on the AI. Look at IQ. We have a data agent, operation agents, right? And already Power BI with agents, we were kind of led that whole work, but now we're doubling down it. Continuously update AI models with fresher features to enhance, to predict accuracy and minimize the model drift. Okay, see, this is, suppose your company, your business has some model, right? And you are continuously training it, for your use case, right? It could be hospital, it could be finance, it could be government, it could be anything. Okay, manufacturing, doesn't matter, So, but all this raw data, right, that needs to fed continuously to this your foundational model and get trained, right? So through the trained, right, Fabric gives you data science experiments, model training experiments. You can do that, or you can take this data and feed it to NVIDIA, stack, right? But get your your model back, right? That's up to you how you do it. But we give you the data to just train your model for better. Okay? And streamline teams and processes, right? Reduce handoffs. That's the core strength of Fabric One Lake, right? Reduce handoffs among teams to enable faster iteration cycles and lower overall maintenance efforts. Okay. And then, and then what is the last thing I want to share with you, right? Because this session was all about, right, in high-speed ingestion and near real-time analytics, right? How you will, tomorrow you go to a company, right? What do you want to do? How you want to help, right? Identify one or two key decisions that will benefit most from accelerated processing, okay? Because see, you're from this session, you're going to the work, say, hey, we're doing all this batch, we're doing some real time, but I went to this session, given our new business requirements, where the world is going, we want to put this new practice into play, right? Identify one or two, activities. Define the fractional service. Again, what is your live dashboard and end-to-end latency? Those are two things. Just ask those two questions to your business stakeholders, right? And you will get one or two, okay? Some objectives, right? Define the fractional service SLO, right? And for those two decisions, one or two decisions you want to make, leverage data. So, and now with our data agents operational agent available in preview mode, you can quickly, do a POC, by bringing some data, real-time data, do some batch with a pipeline or copy job, combine them and do some operational agent, build some alerts. In 2 hours, you can show them. It's so good for you guys, right? For everybody, right? So if you from this session, right, take this tip, try to use it, okay? Choose the ingestion path, and I gave you so many patterns, right? Copy, mirroring, regular pipeline copy, event stream, shortcuts, right? We give you all these options, decide on the data ingestion method, mirroring, copy job, pipelines, event stream based on the use case and performance needs, right? If on the DP 700 exam, right, most of the questions come around this, right? So beware of it, right? Build end-to-end dashboard model also, right? Because in the end, what will be consumed, right? That's it. Nowadays, okay, we are gone from the world where, hey, I have this BI, Power BI dashboard, it needs to be fresh and I'm happy. No. That is part of the game. But now with AI being everywhere, right? How this data, right? This Power BI semantic model data also very useful. And this real-time data, how do you drive your real foundation model, right? The AI models and how will it do better inference serving, for better outcomes, okay? Scale and implement the best practices, right? Expand the solution with governance frameworks, monitoring mechanisms, and reusable patterns to ensure sustainable scaling and consistent quality, okay? And again, right, if you stick to one platform, right, in a fabric-like platform, we're constantly innovating, we're making secure, we're making govern, we have all these workloads, everything there, right? You start small, and then go, and then scale, okay? So with this, I think, I'll stop here. I will, entertain, any questions you have. Okay. Yeah. We have all these workloads, everything there.
Yeah. Thanks, Sunil. That was indeed an insightful session regarding the fast track development process. So I would request if anyone has any queries, if they can just raise their hands, I can just unmute them and they can ask the queries. And meanwhile, we can just go through some queries in the chat if we have any.
Yeah, I didn't look at the chat window, but ask me any questions. Is there? Yeah.
Yeah, sure. So I would request if anyone has any queries, if they can just raise their hands, I can just unmute them and they can ask the queries. And meanwhile, we can just go through some queries in the chat if we have any.
Yeah, I didn't look at the chat window, but ask me any questions. Is there?
Yeah, sure. Okay, I think there are no queries from anyone, and yeah, I think we are good to go. Thank you, Sunil. Thanks for your wonderful session. Yeah, thanks a lot for.
Thank you. I hope it was useful to everybody.
Yeah, okay. It was indeed very useful. Thank you.
Thanks, Sunil. Thanks for your time. Really appreciate such a wonderful session.
I hope, Amit, I hope it was useful, right? Some new way of doing the same thing. Yeah.
Wonderful session.
Thank you.
Thank you. So yeah, so let's welcome the next speaker. So I just take this privilege to welcome Mr. Aman Jain, our next speaker. He is a product leader at Amazon with over 10 years of experience in building innovative and customer-focused solutions. He holds an MBA from the GIES College of Business, University of Illinois,
and has a strong expertise in product management, business analytics, and leadership. Aman is also certified as a Safe Agilist, Scrum Master, and PMP professional. Along with his corporate experience, he is actively involved in community service through Rotaract Club of Young India. Today is here to share his valuable insights and experience with us. Let's welcome Aman. Aman is also certified.
Yeah. Hey everyone. Good morning.
Yeah, hi.
And good afternoon. Are you able to hear me?
Yeah, Aman, we can.
Okay. I present my screen. Just let me know if you guys are able to see it.
Let's welcome Aman.
Okay, is my screen visible?
Yeah, Aman, it is.
Okay. Okay. Thank you, team, for the introduction. Just some more context. Yeah, my name is Aman. I work at Amazon, and I'm based out of Seattle. I have got lot of experiences around product and technology roles, where I help to build some enterprise systems, manufacturing execution, operational data, and as said, some analytics driven exercises. Through working with Amazon, I've got an opportunity to work on designing drones, okay, for deliveries, as well as I'm working right now with groceries, where I'm helping to build the distribution centers, okay, to do the same sub-day delivery for our customers. Now, through doing all these things, I've got a good experience, working through the processes, data systems, to make the operations faster. Okay, and there are some pieces of it which I'm going to present today. Example for this is I got a chance to work through a product lifecycle management system, manufacturing execution systems, ERP systems, and various analytic platforms. So the topic for today is basically the AI powered MES optimization. Okay, MES stands for the manufacturing execution system. Traditionally, this has helped teams, or the operations to track what is happening on the shop floor, which work order you need to run. Maybe the operations which you need to perform, is schedule it, what is the kind of material which is going to be consumed, the quality of them. So tracking the whole experience as an operator, as an auditor, as a manager, of all the things which are happening on the shop floor. Now, working through this, there were traditional ways of how the manufacturing execution systems used to operate. Okay, but now the things have changed. As we were talking in the last session, there is a lot of AI stuff which is coming around. So now the manufacturing, is able to get more visibility. Okay, or could get more visibility after the fact. When AI is introduced. So the opportunity is not just the AI, but also some kind of real-time intelligence, okay, to move the manufacturing execution systems closer to supporting the decisions, okay, for all the layers. So we are going to talk a little bit about that today. I'll try to be not too technical into this session. Okay, we'll take it as a building block of how to think or how to strategize through building these systems. Okay, how to identify what is happening, what to predict, and then probably the recommendation part of it. Okay. So having said that, yeah, I'll go slide by slide, but yeah, I'll try to keep the session brief, with all the high level concepts, and we'll discuss more later. So moving on, talking more about the challenge. Okay, the starting point for many manufacturing teams is still operating currently, okay, in the reactive mode. AI has reached, okay, it has reached, I would say, still, based on my experience, it has reached rapidly towards maybe the software side of the things. Okay, but when it comes to the operating models for the manufacturing floor, it is still in the reactive mode. Okay, and slowly it's picking up. Okay, so example might be a machine goes down, or the maintenance has to respond to that. Okay, so what is the overall product life cycle of that? Okay, for what we are doing, a quality issue appearing, at inspection. Then how do the teams trace it back? Same way, work centers getting constrained, with the schedules or the materials not available. So how will the supervisors know that, they need to adjust the labor, they need to adjust the sequencing of the things, or they need to tell like some upstream or downstream, customers or stakeholders that, they need to take care of these things. So, like in this example, like the responses are happening, but it's probably after the disruption has been already created. This results into downtime, your late orders, rework, a lot of operational burden. Okay, and that's where I think, like, the AI-enabled manufacturing execution systems will definitely help. It will change the whole operating model of how you're operating on the shop floor, as well as, like, how you're combining the rapidly changing or the evolving tech stack with this manufacturing execution systems. So the first problem, like, if you think of it, it's like about visibility. Okay. Again, the visibility is still reactive. Okay. Most of the manufacturing flows know after the impact has been created. So how do we augment it with, like, more visibility prior to even the things which are happening, okay, or likely to happen next? The next part is about this is speed. Okay. If the systems can detect pattern, maybe calculate an impact, recommend the next step. Okay. Can that happen? Okay. The other thing is about the recommendations. Okay. Which I think obviously we have seen in the other side of the things, that things are getting recommended with more data logic, across shifts, across teams, so that decisions can be less dependent on, like, who is looking at it. Okay. But maybe even, like, just telling them upfront that this is what's going to happen. But anyways, the key message here is that we want to have this AI-powered manufacturing execution systems, which will help manufacturing to move from, like, late discovery to early detection, and from manual interpretation to a faster data-supported action. Okay, so that's what we are going to deep dive today. But anyways, the key message here is that we want to have this AI-powered manufacturing execution. Just giving you more insights into, like, how we will cover this. So what I will do is that I will structure this whole session. Firstly, like, I'll try to cover the AI and MES foundations. Okay, relatively more in the context of the manufacturing. That's what I'm going to do. Then we will try to go into the real-time intelligence part. Okay, the bottleneck detections, predictive maintenance, and those kind of things where AI can immediately create an impact. The third thing is about more scheduling. Okay, that how AI can help, for scheduling the labors, machines, materials, those kind of things. And then finally, we'll close with some of the adoptions. What are the barriers, which can slow down this AI MES programs? Okay, and what could be a practical roadmap to bring this all together, from data connection to detection, prediction, optimization. Okay. So yeah, like, we'll try to keep it simple. Okay, walking through the 4 layers. So yeah, let's start with the foundations. Now, again, this could change, but this is just my definition of how, if you look at the manufacturing execution system, they come in different flavors, but the traditional MES systems, what it is and how it can involve. Now, to understand the AI in MES, we should just start with the data foundations. Okay, MES is already, it's, as I said, it's closed enough to the execution. If you think from an operator's point of view or the operations, okay, they're not thinking a lot. They're just executing this stuff. Okay, so that's where the manufacturing execution system stands for. It understands what is the order, operations, routing, work centers, labor, and then based on that, it just helps them to do their stuff. Now, where AI can come or become useful is that this operational signals, if are all connected with each other, okay, and giving some more context to it. Because right now, still, like, since the MES system is said to be connected, but it's actually not. Okay, and that's where there is a big opportunity. So there are 4 data categories we have created into this. One is obviously your production data, okay, the cycle time, the work in progress, those kind of things. This will help, the AI. If this kind of layer is created, the AI will help to detect where the flow is slowing down. Okay, is your cycle time smaller? Is your yield rate, okay, that is smaller? The throughput is not coming out correctly. Okay, so it will help you to build that. So that kind of production data layer we need. we also need like equipment health data. Okay. So because as you're operating on the manufacturing floor, there are obviously a lot of equipments, so we need some kind of that data, okay, which could be the sensors, the vibration, the temperature, all sort of things, which is getting captured. Probably the maintenance history also, how we are doing the things for that. In like traditional manufacturing flows, these things are not connected. They are disintegrated. Okay, they are not at all there. Then comes the scheduling. Okay, the scheduling actually, like most of the things, if you guys are aware of the manufacturing how it operates, it connects to the ERP systems. Okay, which tells you about the demand, the order priority, the material, how it is getting available, when it is getting available, those kind of things. Without that context, it will definitely, your production won't work correctly. Okay. So again, that's very important, to lay out that scheduling data, because AI might help you to detect like a problem which might be upcoming, and then it might also tell you to recommend, okay, maybe the best operational course here. Okay. There is obviously quality, okay, which is a very important piece. Inspection results, your signals which are going, the defect codes, the scrap, rework, those kind of things, This is again where AI can come and it can help the downstream processes to make sure that whatever quality outcomes are happening, that will help you to, maybe do better with your process streamlining. Now, again, the practical point is like AI is not the separate layer here. Okay, it's flowing across, the manufacturing floor. For that, it needs that MES context. Okay, just it could not be just that the sensor is reading something. It's not connected throughout. So that's like we need to build this foundation layer across the manufacturing floor, which all of these things are connected. Okay, through whatever mechanisms we can implement, and tell us, that what product has been built, what operations is running, what kind of quality problems are there, if some material is lost. When it all comes together, it creates a solid foundation for us to, just start with. Okay. Now again, like, I have seen like, couple of MES systems. Okay, they're trying to implement that. Okay, but does not mean that that all the out of the box solutions which are available out there will have all that context. Okay, this is where like someone like someone who is engaged with the production floor, okay, whether it's a product manager or operations or someone with the available tech which is out there right now in the hands of people, they can actually try to create this ecosystem, okay, where the systems can actually start talking to each other. Because once that foundation is laid out, you probably won't need like to implement another out of the box solution. Okay, you can actually use the existing systems by creating this data layer. Okay, so I'll move on to the next slide. The AI is intelligence, MES intelligence stack. Okay, so this is basically like if you now think through this, okay, we talked about like how the data foundation is created. Now this is the stack, like the tech stack, how you could think of it. Okay, so at the bottom we start with like think of like the data collection, like all the data collection we talked about in the previous slide. That all is coming together. The next one is the MES integration. Okay, now you have got all the signals. Now it's a matter of contextualizing it. Okay, it connects all this data together, and then it started to learn from the past data and probably from the context we have already given it to that. Okay, so it happens. And then the top layer is of the AI and ML models, okay, where the things like predictive analysis, anomaly detections, optimization models, recommendation engines, they all operate together. Now this stacks only works when all the three layers are healthy. Okay, it can't be like your the things which we talked about previously. Okay, that something is unreliable. Okay, maybe your quality data is unreliable or your production data is unreliable. So that this won't work. And I think we all understand this at this point of time, that like bad data in, bad data out. Okay, that's how it is. So yeah, we need to make sure that the MES context is proper. If it is missing, your model may just identify the correlations incorrectly. So yeah, a common mistake which I have also seen while working on the manufacturing environments is that usually when like a tech team comes, okay, they start with the modeling first. Okay, they think like, okay, let's just build this AI ML models. Okay, but what they don't think is that in order to even get there, we need to have a good foundation. Okay, of all these things connected. Okay, so that's a very important thing to think through, so that the decision is not too slow or too manual still, and again being inconsistent that it was previously. Now, once that decision is clear, like, the stack is created, we can identify the data, context model, and, obviously the workflow where we need to make all the improvements. Now, having said that, now let's move on. Okay. From there, like we have created the data foundation. What would be the next thing? Okay. Now, once the foundation is there, the important thing is like identifying the bottlenecks, okay, which needs to be communicated, but also communicated to the right place, okay. And the bottleneck is really just like maybe a issue which is just local, okay. It could be like, let's say, one constraint station is there. It will create like a chain reaction, okay, across the shop floor, because it stops, okay. The buildup stops. Operator has to wait. The downstream system, they have to wait. They are just starving, okay, because no product is coming to them. Okay, the schedules will slip. So it's like a cascading problem. Okay, if you think of it. Now the traditional MES reports, often tell us like what has happened after the fact. Okay, the AI augmented MES system, as we talk through this, can help identify what is about to happen. Okay, the first capability here, like as we talk through, is continuous throughput variance monitoring. Okay, instead of waiting for end of the shift reports, AI can monitor in real time. Okay, what is the cycle time, the queue times, the work in progress levels, the station output, all those kind of things. If a station normally completes an operation, let's say in 10 minutes, okay, and begin trending towards like 13 minutes or 15 minutes, okay, this may not initially be an issue, okay, because it's fine. It's just a matter of maybe 2-3 minutes in an overall grand scheme of the things. But if model also sees that the work in progress is rising ahead of the station, okay, and the downstream idle time is increasing, that's where I think like these things could be flagged. Okay, so it's just an emerging constraint. Okay, if you know that, hey, this 2-3 minutes over time might create a bigger impact for me, AI can help you with that. The second thing about here is like, maybe let's say the root cause clustering. Okay, the model which we have designed, okay, in the previous data foundations, it can help, okay, for us to say like, okay, what are kind of the recurring patterns? Okay, what are the bottlenecks tied to a product family, a material, or certain things? Okay, maybe it's something like, some kind of material, which had been sent from the ERP system. It's always creating a problem from a particular vendor. Okay, so that kind of root cause clustering might happen. Okay, and the system would be able to tell us. So in essentially, like, the best system does not simply alerts. It does not just say that there is a bottleneck. It should be able to tell an operator, a supervisor, that where the constraint is, what is likely causing it, what is the expected impact, and what action is recommended. And that creates like your overall thought process of how the mental model shifts, okay, from what is happening currently to the future, which is more from just from visibility, but it's also giving you a decision support. Okay, you don't have to think, okay, a lot, but the operational decision support. And I know, like, couple of these things might have become obvious again in the software world. Okay, how we are designing the softwares, how we may be designing our BI reports and other things, but when it comes to manufacturing, it's still like, operating in a legacy model, okay, that will continue to consistently change. So, okay, with that, like, let's move on to like predictive maintenance, okay, which is again a very important piece of it. Right now, again, it's most of the times it's scheduled, okay, but we need to come to a point of condition based. Okay, what it is, prediction maintenance is one of the, like, it's one of the cleanest use case. Okay, whenever you will talk today, like anything about maintenance, this is one of the cleanest, because many of these maintenance programs are still schedule based. Okay, so let's say a asset like, needs a service every couple of hours, or the impact or the inspection has to be done, okay, for that. So there is a schedule, okay, which is there. It's better, like, to have it AI assisted than waiting for a failure, because it has two problems. Sometimes what happens, maintenance happens too early. It's not needed, but still it happens because the asset is still healthy, you're doing it. And sometimes, which is most of the times, the asset fails before the scheduled maintenance window. Now AI help, it shifts the maintenance from fixed schedules to condition-based schedules, okay, or condition-based decisions. The first building block here, let's say, is the sensor fusion, okay. Instead of looking at, let's say, the vibration, pressure, temperature, those kind of things, AI will combine the signals, okay, and give a more complete or holistic view of how the health of the equipment is, okay. The second thing could be here is the anomaly detection, okay. The equipment often behaves differently before failure. Okay, it's not that at the time of the failure only it will know. There's some nuances. Okay, some different things are happening. It might be very small. Let's say a vibration pattern or a temperature drift or a pressure fluctuation. Okay, those kind of things are happening. Now, this unsupervised ML models, they can help you to identify the deviation from the normal baseline and give a predefined failure threshold. Okay, but okay, this is what's happening. It seems like it's going to fail. So what can we do about it? Then obviously there is the third thing about the maintenance window optimization. So it's not enough that the asset needs service. The system should recommend when the service is needed at the lowest production impact, right? Because let's say it says that okay, now Tuesday is the day when you need to do it, but then the production volumes are high at the same time. Should we do it that time? No, possibly we should do it earlier or maybe do it some other day, depending on how the same thing, the sensor fusion, anomaly detection, those kind of things, right? So those are all the things, and AI can definitely help to recommend the window, okay, where we should do all this maintenance. So the value is reduced, unplanned downtime, you will have more stable production flow. You will have fewer surprises for maintenance and operations team. Okay, so that's how it could be. Now, same way we can think of the quality signals from here. So the quality signals, it's again catching drift at the source. Quality where often problems are detected late. If an issue appears only at the first inspection, the product has already kind of consumed, material, labor, and all those kind of things. You've already invested in it, and then you are getting the, the impact of it. Now with the AI augmented quality monitoring, it can help you to move the decisions upstream, because the core idea is to connect, the upstream process parameters with this downstream impacts. For example, let's say a defect may be related to a combination of temperature, pressure, tooling, maybe some material, operator steps, what they're doing, some humidity and other things. So every individual signal may look like it's okay to accept, but it might not be, because the combination of all these things might result in a quality problem. So there is this value, okay, where the quality systems can help. Okay. The traditional ways of this is you have got this statistical process control, we call it. Okay, so you study the things and then you see kind of a variation, and then you say, oh, something has crossed the expected limit, and this is where the problem is. But the AI can help to create this maybe multivariate pattern, okay, much earlier before the issues could happen. And then what could happen is that a MES system could help to recommend actions that, hey, you need to adjust this parameter, you need to trigger an additional inspection, okay, or maybe hold a badge or notify an operator before all these things, or a non-conformance could happen. But again, the key message here is that AI also could help quality to move from just detection to prevention, okay. Instead of asking that why defects were produced, the systems help understand that the conditions, okay, which might have created those kind of things. Okay, so yeah, it's again we talked about maintenance, we talked about how AI could help into this. Now let's move on to the other part of it, where it's scheduling and resources. Okay, because that's another important piece of it. So when we talk about scheduling, okay, Right now, it's in many of the places. In fact, like, last week I was at a shop floor, and then, they actually had a board, okay, where they will schedule the things, okay, that, okay, the outbound operators or associates are coming, okay, so this is what their schedules look like. But the bottom line is it's still like, static, okay. So we need to be more dynamic into that. Scheduling is like, one of the hardest manufacturing problems, because, the shop floor is constantly changing. Your material might be delayed, okay. The output, might be delayed, there might be few people not appearing, so demand is changing, priority is changing, your materials are, like, as I said, your machines might go down. Labor availability might be very, interesting. And obviously the quality, which you talked about, right? So a traditional schedule, as I said, it's created based on assumption at a point in time. But once execution begins, those assumptions just become outdated. Okay. Now, AI-powered scheduling, how it helps is that it makes the plan more dynamic. Okay. The first input is like your demand-driven planning. Okay. Orders, priorities, due date. We talked about it. Okay. But yeah, like these things, they continuously inform, your scheduling or sequencing, that, okay, for this day, this is what's going to be incoming. That's how I should have my scheduling. The second input could be like, your labor optimization, where like not every operator has the same certification of training, okay, to work on the things. Now, AI can recommend that based on those things, you have to do the assignments, because based on the skills, people will perform. If you will give the same thing, to two different operators with different skills, the amount of time it will take is very different, right? So that's where like, AI can help. The third input could be like a machine allocation, okay? Scheduling should consider not only whether a machine is available, but whether it's healthy. We talked about it, about in the maintenance. So that's where again, like, it becomes interesting to do it. So if two machines, let's say, are performing the same operation, but one is on the declining side of the things, but other is not, AI can help us to recommend, to shift the critical work to maybe healthier machine, and maybe the other things, we need to plug in the maintenance window. And so again, like the goal here is to not to remove the planner or the supervisor, because that often comes across when you go into a manufacturing shop floor. They're hesitant to adopt AI kind of the things, because it just creates an impression of replacing them. But it's important to tell them that, this is something of assistant. It provides them better options, clear trade-offs, and, faster resequencing, whenever the condition changes, right? So that's for the scheduling, okay? But also like, the other part of scheduling is like, the autonomous MES responses, okay? Now, what's happening here is that so far, like, we also talked about some kind of recommendations, okay, but now it's a time of, okay, now recommendations are happening. How can you make it more autonomous in terms of creating actions? Okay, once like your predefined thresholds are there, governance rules are in place, this AI augmented, MES system, which we have kind of thought about so far, is like it can be functioning in certain places to derive actions out of it without waiting for manual instruction. Now, example, it could be like, let's say the system can auto reroute a work in progress, around a degrading work center. Okay, it can auto reroute to another work center because it knows something has happened. So it can trigger like, maybe material replenishments before the line is starving. Okay. It can escalate, some kind of anomalies, okay, that exceeds its decision authority, but ultimately, to a human operator or a manager. So the important concept here is the governed autonomy. So like thinking out of it is like AI is not just, again, replacing your operators or supervisors. In manufacturing, there are certain things which are very critical, the safety, quality, compliance, judgment, okay? And human oversight, it remains a central problem, okay, today, because think of it like, a supervisor is just, managing so many operators, so many operations, and the operator is basically just focused on the things what they are doing. So the trust, it builds gradually, okay, with the things, and same goes with the AI. AI is another operator here, okay, rather than the just replacing the things. It will immediately start, making that high risk decisions, okay, without explanation. because it's natural, it's happening. Okay, so it will happen. So users will resist it, but it will start making some recommendation, show some confidence levels, okay, explaining why it is recommending an action, and then probably it might start with some human in the loop, okay, but at one point of time, it will become more automation for the low risk actions, okay, and then slowly the adoption will begin, okay. So again, this is one of the major challenges which happens in the manufacturing shop floor, as I said, okay. They are not welcoming oftentimes to all these sort of things, and that's where I think we have to take it at a pace, okay, at a slow pace, then evolve it, build that trust, and then go from there. So now the question is not about can AI automate everything, okay, but the better part of it is what decisions can AI safely recommend, okay, which actions can it automate, okay, where should human approvals remain required, okay, so that we can expedite our processes, what's happening on the shop floor, maybe with the same amount of labor, okay, or the supervisor capabilities we have got, but at the same time, see how AI can be another operator here, expediting all these things. Okay. So yeah, but again, this is a very interesting part of it. Moving on, the adoption barriers. Okay, I think I've talked about some of it already. That what at least personally I've seen, in the AI world or with the manufacturing world, that how it operates. But the programs usually fail. Okay, I have worked on few programs which have failed significantly. Okay, but it fails because the model is weak. Okay. It could be your data foundations we talked about very first. Okay, they are weak. Okay, because maybe the operating environment, okay, it's not available for adoption of the things. Okay, and this is also silos of the things. Okay, we talked about how there are multiple systems. Okay, we were focusing on the MES system, manufacturing execution system, but think of it, there is this enterprise resource planning system, maintenance systems, quality systems. They all are disconnected. Okay, it's not never going to happen often. What happens is that it's not coming from a single entity. Okay, it's coming from a different universe. Okay, all these things are disconnected. They have got own data sets. So if these systems cannot be connected through let's say common timestamps, okay, equipment identifiers, work order IDs, okay, like a common set of parameters, okay, then what will happen is that the AI won't be able to help getting a clear operational picture. Okay, so that's where it's important that we do that. Okay, again, coming down to the same thing which I spoke earlier, which was about the data foundations. Now the second barrier is about the system integration. So many, as I also said, that many of these manufacturing shop floors are working out of the legacy tools, legacy equipments, okay, and custom integrations. So this makes really difficult for the data extraction. Okay, the standard connectors, the APIs, and things, they can help to reduce this friction to do that. In fact, if you guys might have seen the news, Amazon actually has offered their supply chain systems, okay, now to the market. Okay, and the whole goal there is that Amazon is trying to build this universe, okay, where it's a single entity connecting the dots to everything, okay, in the supply chain system and the manufacturing system, and bringing it all together rather than going into different things and bringing it. Because what Amazon did is that they created, they have got a very powerful supply chain system, okay, and they build their own things. Okay, they build from the scratch their own things, okay, end to end. So they understand the supply chain very well, and they created the systems which are connected to each other seamlessly. Okay, and it avoids the companies to go out and build their own own systems or purchase own systems. So it's an integrated system, which is interesting, that how it might play out in the market. Now the third barrier, obviously, we talked about previously, is the change management, right? Operators, planners, supervisors, they need to trust the recommendation before they can change their behavior, right? It requires explainable, AI confidence scores, override paths. Okay, so it has to be like a phased rollout. It can't be like you bring in AI into manufacturing and tell them that, hey, go ahead and adopt it. It has to be like phased. Okay, and this is why your AI MES, it should be treated as a manufacturing transformation effort. Okay, it should not be just like any other data science project or something like that. But yeah, again, the model is one piece. Your integration, your workflow design, building the trust, building the governance around all these things are very important. So just moving on, thinking of what data points matter the most into this thing. Now, because AI efforts try to collect too much of data, too quickly, more data is not always better. Okay, and this is also something which I have seen. The right data has to be there, to make it the best. So thinking of it, it could be we start with data which is already collected reliably and has direct link to the business outcome. It could be things usually, manufacturing teams, supply chain teams, they have their weekly business reviews, monthly business reviews. Those things we know, those are business outcomes. Okay, which they're focused on. So maybe we just need to figure out that what is directly linked to that. Okay, if the goal is let's say bottleneck detection, focus on cycle time, queue times, work in progress. Okay, those kind of things. Or the goal is predictive maintenance. Okay, or the goal is quality drift. So what are those goals? Okay, that we need to work through. And then that's where this kind of pyramid. Okay, it kind of makes a practical order. At the foundation, are this again your cycle times, okay, how the teams are operating or the operators are doing the things, and then there is machine, okay, which is working along with them. So then after that comes in what is the quality inspection results, okay, work in progress tracking, those kind of things. Then comes your scheduling constraints, your resourcing and other things which we talked about. And then at the top of it, it's your strategic things your demand signals, your supplier variability. Okay, so these things the point here of this pyramid is that, as you see, the upper layers are so valuable. Okay, but they're harder to use effectively if the operational foundation is weak. Okay, so this is what, again, it could be different, but this is from my experience that you start slow, you start with this foundation layer and then start building on it. Okay, so now if you think of the whole thing we talked about from the data foundation, but there is a building layer to it. Okay, how you can actually start building the things, gaining all the confidence, gaining all the trust from your stakeholders. So yeah, this is, to me, when implementing it, it's simple. Okay, it's avoids capturing data until you know which model, workflow, or KPI it will support. It will start with a very high level use case, okay, which is your foundation, and then again it will prove out its value and then continue to expand through other layers. Okay, and then you will just create a whole ecosystem of this MES system. Okay. Adoption roadmap. So just this is a supplemental to what we had already spoke. So the roadmap is intentionally, it's phased. Okay, as I've been repeatedly calling out that because most organizations cannot just directly jump, okay, to autonomous AI-driven manufacturing. So the phase one of it, okay, it talks about connection, okay, which again I'm reiterating the same thing, but it's quite important. So that's why again talking about it, unifying these data resources, creating a reliable timestamp pipeline, okay, because I talked about the timestamping thing when I talked about multiple systems, okay, but it's very important from the shop floor to the analytics layer. The output of this phase is again trusted contextualized data, okay, which is coming out. Now once you have connected all the things, you could detect, okay, this is where teams they will introduce anomalies, okay, the dashboards, the alerts, the real-time visibilities, and probably I think from the last session we learned how some dashboards could be created with much faster things, probably those kind of things could be done. But The models are more mature at this point of time. The third phase is more about prediction. Again, predictive maintenance and quality drift models, which we talked about. Okay, that could be your next phase. And the fourth phase is your optimization, where like AI assisted scheduling and autonomous MES responses, they become possible, okay, with governed boundaries. So the most important point in each of this phase delivers is like it delivers it values independently. You do not need to reach out directly to the phase 4, okay, before achieving like some kind of ROI while you're starting to build these layers, okay, and then build your reliability. So yeah, this phased path, like it helps to build the trust, okay. Detection, obviously it improves your response time. Obviously the connect improves your data reliability, detection improves your response time, predict, it reduces your downtime and quality risk, and then your optimize helps you to improve your execution speed and the resource allocation. So with that, we will come to the key takeaways, okay, of all the sessions. Just summarizing it with 4 key takeaways. Basically, it is that again, AI, it elevates the MES, from a record keeper to a decision support engine. Okay, MES has always been strong at recording what happened, but as I told you at the very beginning, AI helps to explain what is happening, predict what may happen next, recommend what action we need to take from there. The second is the right data. Okay, so right data, it helps to get the more data which is correct into that. Okay, the best AI MES systems they prioritize let's say the high fidelity responses which we need before you expand the scope of certain things. The third thing we learned about is the phased adoption. Okay, it helps you to de-risk the whole journey. It connects, detects, predicts, the optimizes certain things, and each step, it should stand on its own business case and deliver measurable value, okay, through this. And the fourth is the trust. Okay, is the tech. It's like you need to build that confidence score or human in the loop governance. Okay, through this, and override controls. Okay, wherever it's not optional. These are just foundational. Okay, to build a sustainable adoption, but the trust is very important. So yeah, finally, AI and MES is not about just adding the technology just for the sake of innovation, which just happens. It's actually building this whole smarter operating system, for manufacturing, where the teams could be much faster, better, more consistent through the things. So, but yeah, we need to again we need to think through this, what could be better for our stakeholders. Okay, work backwards from that. Okay, rather than, as I said, just completely coming into it and just building something into that. So okay, so that was it. That was my last slide, but thank you. I'll open up for questions. I understand this might be a very different thing. A couple of folks here for manufacturing, but yeah. Sorry, I did not check the chat yet.
Yeah, Aman, I have a question here. Basically, so for whatever we are discussing for manufacturing, is there already a framework available for using it, or still it is, individualistically we have to do all these things using AI?
Yeah, good question. I actually have not seen a framework. Okay, what I showed today is what I learned from at least working in multiple orgs within Amazon, as well as few orgs which are outside. To my knowledge, now the frameworks are coming up. This MES systems are there are multiple out of the box MES systems. Okay, but then there are also ERP systems, there are this quality systems and all other things, but there is not a common framework which is bringing all the things together. Okay, so I saw a lack of it. Okay, and that's where there is obviously a need of it, but I've not seen one yet.
Okay, another thing is some of this AI is already embedded into the devices, or when we are talking about this entire bigger picture, so we are talking that you get the data or the parameters and then you take a decision, or some part of it you are what you are referring is an embedded system already?
Yeah, like couple of these systems have evolved to embed it. Okay, but what happens, or at least what I've seen, is that they lack the user context system. So example, I'll tell it to you. What happens is that, like, let's say MES system, out of usually teams use out of the box systems, which are from let's say the Dassault systems, Siemens, and multiple of those folks. Okay, so they work on the things, but they lack a lot of context of like a particular use case for a particular industry. Like, I will take out of the box solution, it has got some AI features, and I will implement, let's say, in a company XYZ, but that manufacturing organization might have its own ways of working. Okay, so it might not connect very well, okay, of what this out of the box solutions is. So there are some AI capabilities which are available, but there is a need where someone has to come in, understand what is the out of the box available, what is the problem happening on the shop floor for that particular organization, connect the dots together, and whatever is missing, that's where they need to bring a mental model and connect and create that ecosystem, right? So yeah, that's where the opportunity is. Again, not saying that the embedded AI is not available in couple of the systems and the equipments. It's just that it's not connected in a way which is contextualized for a particular organization. So that's where, like, some of the folks still need an opportunity to come in and do that exercise.
Okay. I don't see any other question here in the chat. I think I posted few questions which I've asked. So thanks, Aman. Thanks for giving this. This is one of the topic which is most useful or need to be used, but I think very less talked about. And the good that you bring it, that to us. And definitely, we are talking about AI. When we talk about AI or when we talk about data analytics, we're talking, the data when it's already came out of ERP and CRM. But the data is everywhere. It's there in the device, and the decision are actually all can be done at the device level. If the device is giving some data, the action need to be taken. It need to be stopped, or it need to be done repair or maintenance need to be done quickly, because there are certain parameters which has changed, which actually means that it is not the scheduled maintenance which is going to do the job. But I think that's where this is really useful. And I think all of those who are going to work with manufacturing, especially when you deal with manufacturing, when you look at the machine data, especially I have worked on the preventive maintenance data, so I understand it that there is a preventive maintenance need. And what happens if the machine goes down? Sometimes you plan for a preventive maintenance, and that I'm going to go down for a 1 day, or let's say this much of time. But if it happens before that, the machine fails, it is loss of business. It's a loss of opportunity, loss of business, and it's really critical for some of the organizations. So I think AI can definitely help us out with the better things in this area, like having if the preventive maintenance is needed before or after. So thanks for bringing this topic. I think especially it would be really helpful some of those who are going to work on I know quite a few of us are already working, but it's basically in data and AI. It is not necessary that every day we are going to get a manufacturing project, but whenever we are going to get it, I think these things will help us out in thinking that, okay, these are the areas where we can also think about having a solution.
Yeah, absolutely. So again, like, the opportunity is huge. As I said, I don't see a lot of folks or a lot of teams working through it. Okay, but there is a big opportunity for bringing it all together. So anytime you guys get an opportunity to work for manufacturing, I'll tell you, like, that's the most honest spot. Okay, to check your opinions, to get a real feedback, from the manufacturing stakeholders, to get challenged and work in the ways of how to do it, because those are the people who will give you the most amount of resistance, but the best product will come out of it, right? So but yeah, thank you for the time. Reach out if you guys have any questions, want to partner or anything, but thanks for the opportunity.
Sure. Thank you, everyone. Thank you, Aman. I'm going to share Aman's LinkedIn ID in this chat window also. Also, one more update. Tomorrow, we are starting little early. We are going to start the room 2 also at 7:30, not at the 8:30 as planned earlier, because we have more sessions coming out. Tomorrow, we will wrap up little early, but I appreciate everyone who has stayed this entire day-long journey with us. Room 1 is still one session is ongoing, but for room 2 we are wrapping up. I'm going to stop the recording as well as I'm going to stop the YouTube live also. Thanks Aman for this last session, and thanks everyone who stayed long, and some of you still wanted to attend something. Yes, room 1 is still going on with the session from Perry on calculation group versus UDF. So please do join that. Thank you everyone. Have a great evening and see you tomorrow morning India time. Thank you. Thanks Aman for this last session, and thanks everyone who stayed long, and some of you still wanted to attend something. Yes, room 1 is still going on with the session from Perry on calculation group versus UDF. So please do join that. Thank you everyone. Have a great evening and see you tomorrow morning India time. Thank you.